7 का हो जाएगा अभी अक्टूबर
जी
में।
सर। जी सर। जी सर।
और दुनिया भर में घूम रहा है दौड़े
जी
दौड़े।
सर।
एक आध बार
जी
वैसे
सर।
गिर गया था,
Ladies
एक
and
बार
gentlemen, esteemed
सीढ़ियों से
delegates
हाँ
and honored
हाँ हाँ हाँ
guests, good
सीढ़ियों से गिर
morning.
गया था, बट
It is with great pleasure and enthusiasm that I welcome you all to today's event on the compelling theme of One Health for the Well-being of All, under the aegis of G20 Chief Science Advisors Roundtable. G20 CSAR is the flagship event under India's G20 presidency and led by the Office of the Principal Scientific Advisor to the Government of India. It brings together the top and emerging scientific powers of the country. This event is being organized by the Jodhpur City Knowledge and Innovation Foundation and the Indian Institute of Technology, Jodhpur. As we gather here today, we are presented with a unique opportunity to engage in meaningful discussions and collaborations that transcend borders, disciplines, and sectors, all in pursuit of a shared goal: the holistic betterment of our planet and its inhabitants. The concept of One Health encapsulates the intricate interdependence between the health of humans, animals, and the environment we all share. It is a reminder that the well-being of any one component is inextricably linked to the well-being of the others. Today, as we confront unprecedented global challenges, from the pandemics to climate changes, we are reminded that a fragmented approach to health and well-being is no longer tenable. The G20 Chief Science Advisors Roundtable serves as an invaluable platform for us to collectively address these challenges by bringing together the expertise, experiences, and perspectives of some of the brightest minds in the country. As science advisors, policymakers, and researchers, we have a collective responsibility to shape evidence-based solutions that promote health equity, safeguard biodiversity, mitigate environmental risks, and enhance societal resilience. So now, I invite Professor Shantanu Chaudhary, Director IIT Jodhpur, to deliver the welcome address and set the context for today's event.
Good morning, Dr. Ganguly, Dr. Katuch, and all other dignitaries. Welcome to this event. I think it's a pleasure to talk to all of you in presence of Professor Ganguly and Dr. Katuch. And this event is essentially on One Health. And what we term the event as One Health for well-being for all. In fact, One Health is not just for human health. If you see, One Health is a collaborative, multi-sectoral, and multidisciplinary approach which actually covers human beings, animal, environment, plant. The entire ecosystem is what is encompassed by the whole philosophy of One Health. And therefore, the approach to human health in isolation and not looking at in the context of what else there in around is not really valid anymore, because changes in environment is impacting human health, and the zoonotic jumping, which has happened, in fact, COVID has been a big example, is also a reason why we should be bothered about our relationship with the animal kingdom as well. Because this jumping of viral infections or even bacterial infections opens up some kind of new directions to explore and look at. Look at in terms of creating also a strategy for prevention. So the environment is critical because the way we are actually impacting our environment, it also have an adverse effect on our health. If you look at it at IIT Jodhpur, I think one of the key points that we have addressed that the desert region, that is Thar, as an integrated system, and we are trying to approach and understand the Thar as an integrated system and how it has an implication with reference to One Health. Another point which is very, very important is the role of data and the predictive models. Because some of the diseases, for example, if you take that some of the viral infections which affect animals first, and when we find that animals are dying, that could be also an indication that disease may spread and come to human being. In fact, this has been observed in a number of diseases which has come up in recent times. So therefore, creation of predictive model for securing human health also requires looking at the data from variety of sources and using the data whether you can create the models for this kind of predictive protection. So when you talk about digital health, this is which is also linked with, if you look at today, linked with One Health, because the data is fundamental of digital health. The only challenge today is that in Indian system as well as globally, the data is fractured, it's not organized, it's not available. And that is a major bottleneck for really building up a One Health strategy. Because without data, you cannot create these models. And until unless you do the models, you can actually do the, and that's very important when we look at it from a kind of a overall perspective. It's not just the analysis of the disease, it's not just the coming up with the drugs or the treatments, but also it's very important that how you create the system to capture early signals. In fact, that's the only way possibly you can create a secured health system for the world, not just for the country. And that's also is aligned to what we have now embarked on, a major digital health initiative. And therefore, digital health and One Health is aligned in various ways. Although obviously One Health has various other parameters as well, and that's also is of concern of us. And so we want to look at it as a wholesome perspective, with a wholesome perspective. It's not just I look at human health and just look at how the human health is impacted from the migration of diseases from zoonotic source or otherwise. We have to look into the overall perspective and the ecosystem. If I talk in terms of a systems perspective, we live in a world where human beings, environment, animals, plant, everything is linked together into an overall systemic fashion. Ability to understand and model the system, and based on that, creating health strategy is need of the day. And I think this discussion and meeting what is happening today may be well a starting point of investigations in those areas. And IIT Jodhpur is committed in that space. We have actually started working on Thar as a target ecosystem, and also digital health has been a major initiative in our part. And another very important thing that we are looking at today is in terms of integrative medicine, integrative precision medicine. Because there are different schools of medicines and thoughts. We need to analyze scientifically, we need to discover their fundamental bases and try to see that how well we can use those concepts, because in many cases, those traditional medical sciences also look at human being as an element of an overall environmental system and not just in isolation. So therefore, all these contexts actually sets up the key point for defining a completely new research program and research perspective. And that's what we are interested in. And in fact, today's meeting is a step in that direction. Thank you.
Thank you, Professor Chaudhary. I now request Professor Mitali Mukherjee, Head, Department of Bioscience and Bioengineering, IIT Jodhpur, to speak about One Health as a transdisciplinary framework.
So, good morning, everyone. I think we've dragged you all on a Sunday, but I think it's an honor to have so many dignitaries joining us today. Professor Ganguly, Professor Katoch, our director, Professor Chaudhary, Lieutenant General Pawan Chadhaji, Professor Vadera, and Mr. Hitesh Bhagirathji. Dr. Anand, Dr. Abhimanyu, there are so many people who have come at a very short notice to hear or deliberate what we want to do as a One Health perspective, and it's really been heartening. So I welcome all of you also who are attending the deliberations of today. And I just wanted to emphasize what Professor Chaudhary already has alluded in his wonderful starting note. Previous one. Previous one.
Share it on WebEx.
Okay. The slides are changing, right? We are just sharing it on the WebEx. So go to the slideshow mode. So, Dr. Ganguly, are you able to see the slide? Yeah, okay.
Right.
So this is my way of working through a very complicated thing, and I try to make it into a simplified version of a mind map so that today's meeting, why we had come here with so many different kinds of expertise, is because One Health requires a transdisciplinary framework, because as you know, it is all about the ecosystem health and biodiversity conservation, where there are so many interdependencies, and it has to have a systems approach in trying to understand the problem. And there are challenges. There are challenges of scale. We cannot do it at a small piecemeal level. It's just not possible. There has to be a context, socio, cultural, spatio-temporal, because those kinds of things can totally change the ecoregion in various ways, and you cannot actually port information from one to the other. And there are multiple levels in which you need to assess the health of the ecosystem, both below the soil, above the soil, and within us, within the fauna, within the flora. So it's because everything is seamlessly connected, and anything perturbed in anywhere will be reflected as an indicator in any one of these places. But the question is, how do you collect all this, right? And it needs to be economically viable and sustainable. It cannot be one-time exercise. So it has to be in such a manner that you are able to kind of address this. And then when we come to the implementation, that's why we need transdisciplinary involvement collaborations across multiple stakeholders, each have a very important role to play in not only getting the best of the science, best of the innovation, and also sustainability. So we need to connect with academia, research organization, health, environment, agriculture, veterinary, strategic sector, and then also because those are the people who are going to be the final beneficiaries. And if we don't connect with them, we are not really aligned to the needs and to also the way the research should be oriented, industry and NGO. And all these should actually help in development of a knowledge hub, which is eco-region specific, the context specific. For that, we need to build capacity, because we just cannot create knowledge without capacity, and we need skills. So, and we need technology to be able to upscale it, to be able to disseminate it. The other thing which is very important is benefit sharing. This has to have a equity in such a manner that it is inclusive. It is not benefit to one particular set of stakeholders. It has to connect to the community, and a development of recommendation engines which could allow, just like Professor Chaudhary mentioned, early actionable interventions, remediation and rewilding solutions, and also create evidence which would enable policy recommendations. So this is the framework which we need to develop in any context, and these all considerations have to happen. And as Sir mentioned, the clusters which have been set up by the Prime Minister's Scientific Advisory, these provide a very, very amazing enabler for setting up these things. Like the Jodhpur City Knowledge Innovation Cluster, we are connected and we are getting more and more connected through this cluster. It enables to source expertise, to reduce on the time to develop technologies, to reduce the cost, because lots of things we will not be should not be able to incur to develop things. And also it provides connects. Like Thar Design is one such example. Thar Design is Desert Ecosystem Innovations Guided by Nature and Selection, which was a pilot study in the Jodhpur cluster. And through that, we could actually organically develop it into a One Health perspective. And very slowly, we could actually connect a huge number of people. And this is like still a networking is getting built. And today, through some of these networks and some of the networks of these networks, we will try to see how we can, at the end of the day, maybe come out with certain kinds of knowledge, certain kinds of key points which would enable us to have a focused way of growing in a particular direction. So the idea is today's is that we kind of, if we can think through a strategy for meeting sustainable development goals, because there has been an original state which is not there anymore. Development, anthropogenic activity, climate change, all of them are contributing to the present current state, which we now know is not going to be sustainable. So we have to actually move towards an envisioned state which has to be in a One Health perspective. And all these points which are needed to be done, it requires multiple stakeholders to come to a platform, and the government to be able to support such kind of initiatives. So I'm looking forward today very excitedly to the deliberations of today. I think we would have some people joining online also. So thank you so much for coming, and I'll give over the podium to Sharmishta to take care. Thank you.
Thank you, Professor Mukherjee. It is our great honor to be joined today by Dr. Nirmal Kumar Ganguly, our distinguished guest. He holds an illustrious background as the former Director General of the Indian Council of Medical Research and a former distinguished biotechnology research professor for the Department of Biotechnology, Government of India. He has an impressive array of roles, including past presidencies at institutions such as JIPMA and the Asian Institute of Public Health. Dr. Ganguly's educational journey includes an MBBS from Calcutta University and an MD in microbiology from PGIMER Chandigarh. His exceptional contributions have been acknowledged through numerous honors, including multiple honorary Doctorate of Science degrees and the prestigious Padma Bhushan Award for Medicine in 2008. I now request Dr. Ganguly to share his precious words with us.
Thank you, Shantanu. Thank you, Mitali and Dr. Katoj. I will start with some stories which I experienced in the area of One Health. One of the things which exemplifies, which actually Dr. Shantanu told about, having the big data, digital data, and environmental data which could be processed to solve some of the problems. There is a one speciality which was not in my time. It has come up and in many universities, including including the Pune Symbiosis imparts it very well. This is known as the spatial geography, and one of the areas which they do is also hydrology, and the data is collected through various means. It is collected from environment, is collected through drones, it is also collected through laser aided systems, and ultimately what you get is a huge amount of data, and with this data then you analyze this data to find out solutions. There are some, all the guys who are doing special geography these days, they are getting immediately absorbed even when they have not done PhD. They're lapped up by the international organizations. So one of the things which I came up when this was used was the Casanur forest disease. This is one of the things which ICMR solved, which was very original. This was a virus, this is a hemorrhagic virus, which passes through monkey, ticks, rats, and humans, and was essentially resulting with the deforestation which happened in the Karnataka, and people were dying like flies. And at that time, this was one of the earliest novel vaccine which was manufactured by ICMR over there in a small factory. It was a old crude technique, but the Bharat Biotech uses this technique even now. This was like killing the virus, making it inactivated and pushing it back as a vaccine. Today there are better platforms, but this vaccine is still being used in Karnataka. But then we thought that it will be in the Shimoga district only, and it will be confined to that till the hydrology group from the Britain came and worked here with Dr. Hathi and others, and we could see that this particular disease has spread in Maharashtra, Vidarbha, Goa, the Kerala, and we could really map it out very precisely, and it became a major infection in the world. The second story which I will like to tell you, this was also very recent, that there was a Soumya Swaminathan asked me to accompany her to Gorakhpur, because the Gorakhpur there was a JE infection which happened during my time, and the Chinese vaccine was included, and there was a symposium to see that how the acute encephalitis could be handled. But lo and behold, the space was occupied by the scrub typhus, Susugamushi. And this is again is a result of deforestation, one of the degradation of the environment, and and at this given moment, these are urban setting shrubs, etc. They also harbor this particular tick, which infects bites the human and passes this disease. So this is not only was so this became 30% or 40% of the disease in India at this given moment. Even now, it's one of the major infections. And one of the things which we were really perplexed, that some of the signatures through the sequencing, because these days you could sequence all the bugs, so was very very near to Japanese trains. So there are Japanese cities near Gurgaon, and this was seen in some of the hospitals in Gurgaon area. So as as Shantanu said that today this is global, and this was really global. I again come to another thing with which I was familiar. You know that cholera, the Gangetic Belt is a um, place where cholera happens. And one didn't know that how cholera is transmitted, although we know that some people excrete cholera. But essentially, cholera loves to eat chitin, cholera bug. And they remain in the blue-green plankton in the Bay of Bengal and remain in a latent stage. They don't multiply. But El Nino effect, what happened that with El Nino effect, these planktons bloom. And when they bloom, they start multiplying rapidly and then cholera spreads. So Rita Colwell, who was the NFS director with the Mizanur Rahman of Bangladesh and GB Nair, one of our ICMR stars, they did this study and they measured the chlorophyll through the satellite imagery to see that when these blue-green planktons will multiply. And lo and behold, that every time the El Nino effect came, there was an outbreak of cholera. And this was also connected to Peru outbreak of cholera when for nearly 80 years there was no cholera in the South America. So this and they also remain the whole biology was studied through the vibrio fishery, with another vibrio which remains in the fishes, and the estuary, which is the Bengalis are very fond of hilsa fish, and like salmon, hilsa comes in the estuaries, the river and the sea where there is a salt water, they come to spawn there. And with the hilsa also comes the vibrios. So there is a very common link between environment and the infection. Another thing on which I had a frontline seat, I was in PGI Chandigarh, and there was a plague outbreak at that time. So in Latur and Beed, there was an earthquake, and people fled the place, but they stored their grain in their houses and locked the houses. And the rats then descended on those grains, and when they came back, the bubonic plague started. And these guys then went to Surat in a big mela, and in the Surat they had started pneumonic plague. So a team came from the CDC to NCDC. I will not name the scientists that who did what, but there was a scientist in ICMR Pune, and there was a scientist in the NCDC. So Mei Chu came, who was the expert on the plague. Plague was one area where India has a great expertise. And at one time, Dr. Halimar Hafkin, who worked in the Hafkin Institute in Bombay, was the discoverer of the plague vaccine, and he the areas near Calcutta, Bombay, and other places, India has a great expertise for the plague bug and how it spreads. But all the expertise had gone. All the people didn't know, and at that time, the scientists in the NCDC and the scientists in the Pune from ICMR Institute, they suspected that it was melidiosis, Pseudomonas pseudomallii, because the peculiar, when you spread the throat, a peculiar colonies came up. So, but when the plague didn't abate, Dr. Ramlinga Swami was asked, he had retired, but was well respected. He was asked by the government of India to lead this. I was in PGI Chandigarh. I don't know why he picked me up. I didn't know anything much about plague, but he picked me up and to ask me to accompany him. And so we started solving the problem. One of the problems which came up, that how do we fight this this battle of melioidosis with the plague. So we went around to find that who had the expertise in the plague at the moment. We found Dr. Batra in the Gwalior DRDO. He had this expertise. So that one expertise was identified. Then in Chandigarh, we had a biotech. I was heading a biotechnology department, so we could see that whether these were plague like bacilli and whether they had a clonal origin. We found they had a clonal origin, and Dr. Panda, who was in the All India Institute, developed the various reagents, including the antibodies to F1, which fluoresces and which diagnoses plague. So we identified that it was plague all around, and with autopsy and all the samples, plague was identified. But then we got into a problem that how do we prove that this is how this had spread? So there is a science of mammalogy. The mammalogy is those who understand the behavior of rats and how the rats behave. So Dr. Ramlinga Swami identified the mammologist. So the mammologist worked in that area, and he found, that in the house rats are either Rattus rattus or Rattus norvegicus. However, we found that feral rats, which are known as Bandicoota bengalensis, they came and mixed with the house rats because of the grain, and with that they pass on the bug to others. So we identified this plague bug over every place, and India actually lost billions of dollars because although plague was spreading in centers in America and other places, 13 countries it was spreading, nobody will trade with India. But again, this was a very important thing which I saw from the front line, that how it spreads. The next story which I am going to tell you about this H5N1. H5N1, again, ICMR investigated it in the Navapur and other places of the Maharashtra. And it was spreading from the bird to bird. And Indonesia and other places, it was very big infection. So here we needed to get so we sequenced it and all the things, and we got a particular clade which was very unique to India, and some places in Iran, Egypt, and Russia. So here the main theme came up, that how do we find out that it's coming to India? How did it come? Which was the bird and how this clade was peculiar here? So we went to the ornithologist, and the birds have a migration route, and these migration routes are peculiar. They follow the same migration route all the time. So we found a peculiar migration route for these birds, and so with the forestry and others and Indian animal science and other guys, we could ultimately create a commission which could deal with. At that time, the One Health thing came as a big concept in India, and we started developing expertise into this. But again, the Indonesia, the problem was solved. It was not the transmission from the one to one. This was a transmission in the wet markets. Actually, ducks also have this, and in Bengal, that when it happened, it happened in the ducks, and ducks have a chronic disease. So in the Indonesia, the ducks and chicken are all dumped together in the wet market, and that this was a wet market thing which created transmission into human, as it happens in the China and other places. So these are some of the things which taught us a lesson and importance of the One Health. The next thing which I encountered in the One Health was SARS. The SARS at that time ultimately was linked to civet cats, and although we have in Rajasthan we have a Camel Research Institute, and that there is a lot of expertise there, we didn't investigate Mars. So when it came in India, we were able to do two or three things. ICMR had cryo-electron microscopy, and this particular virus had a very peculiar shape. And Atanu found this out in the urine and the stool of the contact who were not suffering from infection. So we also proved that 2 or 3 infections only were found in India, and we proved that. And then I told at that time all the guys that we have an asymptomatic infection. But I was shut up by the people because they thought that I will spread the panic. I also told at that time that the N95 mask should be used. Our current mask doesn't prevent it. I was again asked to shut up because thought that it will have prevent a panic. I don't blame those guys because one of the things when you look at the outbreak, you do it very quietly. You don't spread panic into the population. But those lessons, if we had remembered, we would have dealt with the COVID. And these lessons we learned as we moved, and the One Health system came up. So two or three things of ethical importance which come up over here. The one of the thing is that one of the guys who manufactured polio virus, it is very easy to manufacture polio virus in laboratory. It is a disastrous thing. Suppose it leaks, it will cause a complete wiping out of the human population because the immunity to polio is waning within us. Another guy who, because H5N1 doesn't transmit between human and animals so well, he made a functional enhancement, and in the functional enhancement this virus could move to humans. So this guy was fired from his job, and this study was also prevented. So with this I want to make a point that how important. I could go on giving you one after the another, the Gamburo virus in the vultures, the dengue and other things, but I will move to one last point into this and finish with this. That is the AMR. AMR is a real big issue over here. And what happens in the AMR is that the animal and human and chicken actually and human, there's a bad cycle. Most of the antibiotics which should be given to human are also given to animal, in particular in the free-ranging cattle, not the farm cattle, free-ranging cattle. And they are given diclofenac also for arthritis. That wiped out our vulture population. So our space between animal and human, there are no grazing ground in India. Space between animal and human is getting reduced. So these are actually spreading from human to other. And now, although Government of India has a policy that these antibiotics which are used in humans should not be used in animals, but because of the non-prescription drug which is found out, the farmers could easily access them and give it to them, particularly the free-ranging cattle, which are the largest cattle population in India. So here I found the Amul CEO who had developed a very good app in which any cow or any cattle in his area, if he gets sick or gets fever, that thing comes under his screen, and they are treated with some herbal preparations which they had prepared, and they effectively treated them, and that is how they prevented it. Then I found in the IIT Roorkee there was a huge material science department. They looked at the global BLD data, that is beta lactamase database, and created through material system. You could measure thousands and thousands with MIC. The AMR thing was AMR diagnoses are very costly. So this was Dr. Hajra in the IIT Roorkee. So there are systems now which we could use to tackle this One Health issues in the animal and human in AMR. Two again short bites, because I think that Mitali has risen up. So I have done my three things which are doable. One is a John's bacillus. We could create I chaired that thing in CSI. We could create a vaccine in one of the institutes which is near Mathura, Makdoom or something like that it is known as. And this vaccine was created here. This is also a One Health issue. But another issue is the cows, the tuberculosis in the cattle. And in India, we don't cull cattle who get tuberculosis. All around the world, they are culled immediately if they have tuberculosis, and that is how it is controlled. So in India, the cattle tuberculosis is very high. They have human tuberculosis also, and one of the most worrying thing was that they have a variety which is known as the Mycobacteria origins. This is now one of the major areas. So the diagnostics for this was created by Tanvathu, one of the animal research institutes in Chennai, and Vivek Kapoor from the Penn University. A major vaccination was started in the India and Africa. This was the BCG vaccination. So there are solutions to this, which are AMR. The same was in anthrax. India, Dr. Rakesh Bhatnagar and Dr. Singh from the IGIB created the anthrax vaccine, which was the best anthrax vaccine, much better than the Walter Reed and others. But it was never used. It can be used because anthrax is still there between cattle and human in Odisha and many of the other places. It could still be used. The brucellosis is another area. The Indian bison strains are very, very different. And one of the Indian institute has created a vaccine to brucellosis, and there is a vaccine company in Bangalore for animal vaccines. I visited that. It is much better than human vaccine ones. They create all the important animal vaccines. So there are issues, there are means and others to tackle One Health through the data, through the new spatial geography things, hydrology and other things, environmental monitoring, chlorophyll monitoring, the global warming, the temperatures around to which the dengue is really related. So there are issues, but the human behavior is one of the major issues. It is very difficult to change human behavior, even our own behavior. So this is something which should be frontally tackled. I'm sorry that I took more time than was allotted to me, but I thought that I will tell you the stories, because stories ultimately are remembered. Like our grandmother told to give whatever stories she told us, we still remember, although I'm now plus 80. So that's why I gave my lecture through stories. Thank you very much.
Thank you, sir, so much. It's really wonderful to hear your stories, and it's an injustice to have you for a shorter time. And I am sure we will get you here to hear at length all the kinds of. I've been associated with you over the last 2.5 decades, and it's always a new learning every time I interact with you.
I have published a story on COVID and nutrigenomics.
Okay, sir.
So I will send you the
Sure.
reference.
Thank you,
Okay.
sir. Professor Katoj, I just had a request. Could we have your lecture 15 minutes later? Because Lieutenant General Pawan Chadha is here and he has a flight to catch from here.
Absolutely fine. Sure, sure,
Should
sure.
be fine. Okay.
Yeah.
So I'm so sorry for this accommodation, but we've been trying our best to juggle experts' times. Yeah. So I think I'll give over to Sharmishta to take over.
I now invite Lieutenant General Pawan Chadha, recipient of Vishisht Seva Medal, who is the Director General Environment in the Indian Army, overseeing environmental matters at the highest level. With a distinguished career spanning over 36 years in civil engineering and managing extensive infrastructure projects, he has been honored with the Eco Innovation Award by the World Environment Foundation and a Presidential Award for Distinguished Service. His pioneering efforts in integrating biophilic wisdom into sustainable habitats stand as a beacon for creating pandemic resistant and health conscious environments. It is also a humble request to refrain from taking photographs or recording videos during this session. I now request Professor Chaudhary to present a token of our gratitude to Lieutenant General Chadha. Thank you, sir. Yeah.
So I would like to mention, please, if you would have clicked any picture, do not post it in any social media. This is a special request from the Army.
Today, the event is also adorned by the presence of Dr. Vishwa Mohan Katoch, who is a distinguished Indian medical scientist known for his significant contributions to the field of microbiology and healthcare. He has served as the Secretary of the Department of Health Research, Ministry of Health and Family Welfare, Government of India, and the former Director General of the Indian Council of Medical Research. His expertise lies in the areas of tuberculosis, HIV, AIDS, and vaccine research. He has played a pivotal role in shaping public health policies in India and has received numerous accolades, including the prestigious Padma Shri Award. His dedication to advancing medical research and promoting public health has left a lasting impact on the healthcare landscape of India. He has established the network of 102 viral labs in India, which played a significant role in testing during COVID. I now request Dr. Katoch to share his words with us.
Thank you very much. Thank you. So for a while, I was disconnected, so I didn't know whether I'm out and the connection is off. Are you able to hear me? Are you able to hear? No.
Yes, sir, we can hear you.
Oh, good. Thank you very much. Thank you. I couldn't hear I think the lecture of General Chadha, but anyway, I think I'll catch up later. But since this morning, right from the introductory remarks by Professor Chaudhary, then I think, telling about the broad architecture of what needs to be done by Professor Methali. And then, of course, my illustrious senior Professor Ganguly, actually, his examples of how he dealt with the different, major outbreaks, major health issues pertaining to mostly of them of the zoonotic in character. When you look at this, I think when the deliberations will move on, you look at the journey of what we have traveled. Actually, I think there's only few things I'll reflect on, because the key elements have been, I think, very nicely introduced by Professor Chaudhary. Professor Mithali, as I said, she has really again summed up everything what needs to be considered, thought about, discussed. And Professor Ganguly gave you an examples. When there is a crisis and there's something arises, Indian minds are capable of leading the way. We succeed. We all mostly succeed in war and any campaign actually. Latest example being the COVID. But when we look at the story of the One Health, it's not a very old story, hardly 15-year-old. Right from the day that this concept got the imagination of people, this was initiated in 2007. And I moved to Delhi in 2008. I remember vividly those days. One project from NICET Kolkata, again a project which was driven by a institution in UK. And then another project again, which was actually within partnership with the IBRI. Again, that was driven by some institution in Europe. I think we have gone a long way. We have moved a long way. This is the conceptual framework of what needs to be done, and this concept is for us also, for all people on this globe. That has caught up the Indian scene very well, actually. And we are able to hear the right voices, right right ingredients also. But the journey is not so easy, I'm telling you. It's not because it's almost a cultural change of thinking in a very different way. And when you want to think differently, I think that evolution is societal change in the policy making, decision making, and also in science also. It doesn't come so easily. These symbolic exercise, we are very apt in catching any symbolic slogans across the world, and many of the intellectual Indians, they move with the times. They understand what is happening across the world. They adopt those language, that music very fast. They really do good work, or many of them they do good work also. Many of them are sincere also, but many people don't sustain the campaign. But when you start working on areas like One Health and think is a part of a way of life for everybody, for every discipline, because why we want to progress actually. We want to lead a better life, happier society, balanced society, which by its own actions doesn't dwindle away. What is now you see in Uttarakhand, you see in Himachal Pradesh, you see in many other places where the mindless development has led to the disasters. Everybody knows that. And this is happening in cities, this is happening in our fields, this is happening elsewhere. So the decisions taken in the name of the progress actually, at that time, we don't realize what's going to happen actually. When you look at the example of this zoonosis, now this work on zoonosis has really, it goes on, starts, it catches up, it doesn't move beyond a point actually. Indian Council of Medical Research scientists, they want to work on the human side. ICR scientists want to work on the zoonosis side, the animal side. But we don't, we really don't work one-to-one together actually. Like this, such joint agreements, joint even programs to work together, great institutions like what has happened in Nagpur, they become very isolated events actually. They're not sustained. While we could succeed in many of the events, which Professor Ganguly gave, those are the examples which tell you that we can succeed. But we don't move in very other diseases like Crimean Congo hemorrhagic fever, which could be as lethal actually, could be as lethal as Ebola actually, could spread elsewhere also. So far it is not spread. Why it has not spread, nobody knows. We have not tried to understand that also. Few parts of Gujarat, few parts of the adjoining areas, it is there actually. But except for I think the few cases happening in Gujarat, few cases happening in Rajasthan, fortunately, this has not started killing the people in a big way, but they can at any time. So I think, and when you look at the COVID story, we think everything attention goes to the China, the bats and everything. But when we look at the Indian scene, I was after this COVID story, I was chairing a group in ICR. Then I found, the almost all cattle in India, they suffer from the COVID infections, not from today, for a long time. They have the same type of symptoms. Fortunately, they have not transmitted to us. Same way, there are so many other infections which have a balance. Professor Ganguly gave a number of examples. They have a balance, but they don't spread actually. But we must be aware of them actually. So the constantly working together is the key. Now, for example, we give example of tuberculosis. The area, the time I worked as a scientist also, what we found in most of the infections, they're one way actually. They're from humans to cattle. From cattle back to humans, we really don't know the story. Bovine tuberculosis, fortunately, I think is not a big issue here. We have not been able to detect in humans, maybe by boiling of milk, maybe to other regions, or it is a disproportionately so small, it has not really affected. But infection from the handlers going to the animals, that we found in the farms, in military farms, we found in the civil farms, we found in the other places. So, but that doesn't lead to action actually. So point is what I'm trying to emphasize. We have to start, working in the areas where we show the examples to the people to succeed. If we say we stop the infection of the cattle by the humans, the human handlers, that itself is a big success. But that we must launch a program for that. So in information should lead to an action. We should not continue to be working a nation in, when there's an outbreak, when there's an epidemic, pandemic, we get into action. And there is a war, we get into action. But One Health will never be a success. This concept, its effects of this entire, way of doing together will not succeed until it's a sustained action. And this has to be a sustained action. So I think when we work on any area, we create technology, whatever we create, do anything, we must ensure, that evidence leads to action. And the second point I want to make. It's very nice, this concept originated in the West. This word particularly, we were knowing the concept, we were working on these areas without using the word. But the point was, so far, I've attended many symposia, many seminars. It is, we are talking on the basis of the evidence generated in the West. We talk of the pollution of the water, the soil by the pharmaceutical products actually. We talk of the pollution, the situation created by possibly by the widespread use of the antibiotics in the animals. But have we studied the impact actually? And if we study the impact, then show the evidence, and then show by action policy change, by habit change, giving an alternative, that yes, what we were talking makes sense actually. So we are not deciding based on a data somewhere from Norway or Sweden or somewhere else actually. Their situations are different actually. Same may be happening here also. I'm not saying science is science. A wrong action is a wrong action, but is it happening? Is it happening on that scale? Is it really influencing us? I think the point arises, it should be the actionable points actually. Evidence, local action, and showing the local impact. Then over a period of time, this will catch the imagination of everybody. When I say everybody, mainly the policymaker and the policy people who approve the policy, the politicians. It will be only then possible, that we succeed. Because the examples I'm quoting you, there are examples that telling you the story has to be very given in a very different way. Technology generation, knowledge generation, its proper utilization by but Professor Chaudhary said about the using appropriate use of the data, the digital health, maybe the new technologies, artificial intelligence and those approaches. But they will all depend upon the science we do and at the end of our purpose actually, what we want to achieve in a shorter run. Because agenda is huge actually. Agenda is of urbanization, agenda is of agriculture, agenda of the animal handling, and that involves so many facets actually. You gave the example, take up the example of pesticides. Pesticides continue to be used, but then what alternative? If you are synthesizing pesticides, why don't we invest heavily on the research which will lead to degradation, after a shorter while actually? If we synthesize so many chemicals, about whose disposal we are worried about, why we don't work on the chemistry which leads to the same distinction of the same chemical actually? So the point arises, the science for future also has to be driven both ways actually. Synthesis and distinction. Synthesis and its own degradation. And there we stop actually. Mostly when we synthesize, but by degradation we stop actually. I don't think we invest heavily also on that front actually. The fact is that actually. So these science drivers, whether they are science policymakers, the people, the scientists who want to push for a change, they should show the examples. They should show the example. They should go try to create a balance, which is in the best interest of everybody. This Dr. Mitali also gave those examples. Dr. Shantanu, Dr. Professor Chaudhary also gave those examples. See, the point rises. It is so many sectors, so many aspects. I think points are many actually, because we will continue to live together. We should live together because that's how the nature has created us. The God has created us. And that balance is not for a fear actually. So for example, finding of a coronaviruses in the cattle we should start worrying. Rotaviruses are there also in the animals. They have not done havoc to us, but we should be aware of them. They are there, and we should be constantly sharing a note between us, the veterinary scientist, human scientist, but we hardly meet actually. It can't be left with a voluntarily meeting actually. Somehow those policy changes will have to be on the top, that this regularity has to be maintained in data sharing. Then data sharing of what? That is again the agenda has to be laid down. India is generating data actually. Huge data in India is generating. It is not the Indians are not working. Okay, there is a big section of Indian scientists who just ape the West just to publish in their journals to remain in limelight. That is also a big group actually. We understand that also. All of us understand that. But there is a large number of good scientists who do science with a meaningful science. But there is no opportunity to share. So what I'm pointing, 1, 2, 3, 4, that when we lay out the areas, which area we want to focus on, whether it is on a particular synthesis part, degradation parts, their disposal part, which are our issues, and how much we know about that, and then we can achieve the part, what we want to do on that, and then we can say which way to dispose of also, and which way to do that. Because I'll give you one example of endosulfan. That's the last example I'll give again, because I don't want to be, want you to delay more than that. Endosulfan story, when it was broke out in the Kerala and the Karnataka, it was the aerial spray of the endosulfan. Endosulfan was being used across the country, and there had hardly any side effects, and because it's used actually. But there, the aerial spray by the government helicopters led to concentration into the water bodies, which I think started creating effects in humans, animals, everywhere. And then there was huge cry, and the suddenly we were in panic, court orders, and then we wanted to block the ban it. But the most powerful country in the world, yes, it is a budge. So that means, it's not a panic reaction actually. Same way when we don't want to have, when we did the survey work in India, we found, but we did the analysis part. I was co-chairing a session with a committee with the Animal Husbandry Commissioner. We found there are 33 other actually the pesticides which have the similar effects actually. So why you are not banning them? That means the banning was a more of a commercial decision, political decision pushed by the chemical lobbies who want to sell a product with a bigger margin. So it is not the interest of the human health, or we are taking a decision. So the point arises, what decision we take in dealing with whether with the chemicals, dealing with our interaction with the animals, our interaction with the environment, its bugs. I think to see that for a peaceful coexistence and is for the mutual benefit. And then if we synthesize something, we must have a way to say how it can be degraded also same time. And that science also, degradation science, should be parallelly followed. And it is a doable actually. We don't want to do on that because commercial people they're not interested. They want to sell something. They're not interested in disposal. But then the scientist and the country and everybody should be interested in that. So I think that those investments have to be pushed in. And then this actually policy decisions of, doing a science together in one area. Then how can you eradicate brucellosis? How can you eradicate anthrax? How can you eradicate the tuberculosis? How can you eradicate these diseases? And they work together only when a district magistrate calls a meeting actually. So that's not the way actually. So I think those statutory changes have to be a part of our life system for future if we want to succeed, because the aspects are too many. I will not be able to discuss everything, and it's not by your intention of inviting me to give these remarks. Also, you want to hear, is I think about much broader, I think issues, much broader pathways, which the speakers will, I think they will dwell upon them. I think most of us are very intelligent people. We capture what we want to do. We understand what to do. But then, of course, the last mantra is we stop somewhere in between. Thus, I think all of us who wants to do something, we should not stop in between actually. As a scientist, if nobody is listening to you, publish a good paper. That will make its impact and disseminate it. Influence the policy in a long-term basis, so that that makes a sense actually for the future. So it should not be a science for when there is a one outbreak, one epidemic, or one actually a disaster somewhere, and then we stop after that. So I think this entire environmental science, environmental health, and all these aspects which we are really dwelling upon, I just saw a list of very eminent speakers. I think they all should look at the sustenance part. So that I think how it should be done, and then the people who can push the policy must sustain in their efforts, persevere their efforts to make a change. May not be today, maybe tomorrow, but I think that's the way to go about. But I'm very glad, these words have caught up. The Indian psyche, they are now part of our policy thinking, they are part of our scientist thinking, they're part of the elite good institutions like IIT's thinking, the leaders like Professor Chaudhary and Professor Metali and other people who matter, their thinking. So I must thank Dr. Toteja to connect me to Professor Chaudhary, and I think for this invitation, so that I could listen to, I think, the remarks by Professor Chaudhary, Professor Metali, and of course my senior illustrious mentor, Senior Professor Ganguly, because these all ideas will help the other people to ignite minds. And I really hope, that they will lead to a very sustained action, which will ultimately succeed. Best wishes.
minute. Yeah. So you can hear me, right?
Yeah, Pasumantali, yes.
Thank you, sir. So we would very much like if you would be able to join in us for the entire day. But I know that you're traveling somewhere. But if you are there, then please be associated with us. We'll be very grateful.
Thank you, Pasumantali. I'll try it, sure.
Okay.
Yes,
Thank you, sir. Thank you. So we are breaking for tea for 15 minutes and we'll assemble back. So our first session, we had another speaker, so that's why we have a time. So we will break for tea for 15 minutes and then we'll assemble back, sir. Thank you. Thank you for people who are joining online. We will just come back in 15 minutes.
वापस मुड़ के मैंने उसे थैले में डाला है, मैंने रखा है, it's not possible to do just
Yeah, it is here. It is here. It is here.
सुनो मेरी बात, मुझे भी चाहिए, हमने भी रजिस्टर किया ये
बाहर से मिल जाएंगे.
दे दे इसको.
एक मिनट इधर आ जाओ, ऊपर आ जाओ. वो एक बार चेक करो. सर दीवार में जा रहा है. आगे से ओपन करके देखो.
फिर डिस्कशन करना है. हाँ, ये तो हो गया. हाँ हाँ, तो उसमें जो कि मैम वो डिस्कशन करना चाहते हैं, क्योंकि पहले ऐसा था कि मनक सर बोलेंगे, फिर लेफ्टिनेंट जनरल चढ़ा बोलेंगे, फिर मैम पे करेंगे, डिस्कस करके फिर फेलिसिटेशन होगी. तो मुझे बस डिस्कशन और फेलिसिटेशन का कंफर्मेशन दे दो.
फेलिसिटेशन
एकदम लास्ट में
वो पूछ लेते हैं.
वो पूछ लो. फेलिसिटेशन और डिस्कशन इनको कब करना है, मतलब इस वाले सेशन में कब करना है, दूसरे वाले सेशन में तो एकदम लास्ट में करेंगे डिस्कशन और फेलिसिटेशन. और ये
चलो 2 टॉप के बाद है या फिर सब
लास्ट में है, क्योंकि 4 है अभी. हाँ, और लेफ्टिनेंट जनरल चलेगा ना. हाँ, वो हो गया. नहीं, वो उनका था, इसलिए मैं बोल रही थी कि डिस्कशन बीच में नहीं.
अभी तो टी टाइम के एक टॉप काम कर रहा है.
हाँ, तो अभी 4 के 2 प्रॉब्लम हम चाहते हैं, तो 4 के लास्ट में भी डिस्कस करते हैं. वो एकदम मेरे को करे कंपनी
लाइक गुड हो गई या सब नहीं की है. या पीछे छोड़ और साइज बड़ी है इसकी. कपूरी हो गए ना. पॉइंटर है.
पॉइंटर चाहिए ना.
किसी को चाहिए तो फिर दौड़ना पड़ेगा. पॉइंटर कहाँ पे. हाँ जाके रखते हैं. इसमें कुछ है कि नहीं. हाँ ठीक है. मुझे लगा कि लोड हो. इसमें पॉइंटर चाहिए होगा. एनिमेशन ये क्या हुआ मुझे. अच्छा स्लो है इसीलिए इसको कंप्रेस नहीं कर सकते. एनिमेशन में तो 5-3-4 दिन चल जाएगी. बाकी में भी होगा. बहुत धीरे चल रहा है. दिक्कत नहीं. 7 सेकंड ये तब तक प्ले हो जाएगी और टैप ही है। आप चेंज कर रहे थे क्या स्लाइड्स? वही
नहीं, स्लाइड्स तो वही चेंज कर रही थी यहाँ से। अच्छा, अभी मैं बता रही हूँ। आप रहोगे ना वहाँ पे? हाँ, इसके बाद बता रही हूँ। तो अभी मैं
चले गए।
ये नहीं, सॉरी। फिर प्रेजेंटेशन मुझे यहाँ पे शेयर करना पड़ेगा ना?
ठीक है। ये तो इलेक्शन होता है। सब आते हैं।
सब आखिरी में ठीक
मतलब
डिस्कशन।
पूरे टॉप हो जाएंगे, फिर डिस्कशन में प्रेजेंटेशन में
तो हर सेशन का
सब कुछ लास्ट में ही होगा।
सब लास्ट में।
हाँ।
तो बीच बीच में उनको सेशन वाले ये नहीं करने,
सेशन वाले
डिस्कशन।
हर सेशन का
जैसे
discuss-
देखो,
इस सेशन का डिस्कशन होगा ना उस टाइम पे पहले से मतलब कि
हाँ मतलब सेशन स्पेसिफिक।
जैसे कि अभी हो गया ना इनका टॉप हो गया, फिर यहाँ डिस्कशन हुआ ना,
हाँ
उसी के बाद प्रेजेंटेशन
हाँ वही रहा।
सेशन स्पेसिफिक ही रहेगा क्योंकि बाकी लोग जाएंगे ना उसके बाद ऐसा भी होगा।
हाँ मैं ठीक है।
चेंज करती हूँ क्या करते हैं?
हाँ ये मैं एक प्रोजेक्ट होगा, फिर मैं बोलूँगी क्या करते हैं। तुम अभी रहोगे क्या सेशन?
मैं तो यही
यही हो और फिर देख लेना कि सही है।
हाँ
और फिर मैं इनका प्रेजेंटेशन शेयर करूँ। प्रेजेंटेशन की क्वालिटी रखना है। यहाँ पे कुछ और शेयर करना है। ये वेबएक्स पे शेयर करना है।
यहाँ पे प्रेजेंट कर तो उसको पहले से ही करके पहले से
तो फिर सब आएगा।
सब आएगा मतलब कि जब तक तुम जो भी इस ट्रेन का प्रोजेक्ट हो वो हर बार आते पहले से उसको प्रेजेंट करते।
ये तो खोल के रखा है, फिर जैसे वो बोलेंगे शेयर कर देंगे।
ये वाले डालना नहीं चाह रही है, चाह रही है क्योंकि ये डायरेक्टली पे जा रहा है।
ये वाला नहीं डालो भाई, ये नहीं डालना
डाल सकते हैं।
हाँ वो कोई दिक्कत थोड़ी है सेशन तो उसको ना शेयर पूरा शेयर करके रखो जब जब तुम उसको मेन स्क्रीन पे लाते जाओगे जो भी प्रोजेक्ट होगा मेन स्क्रीन पे वो होते हैं तो वही बार बार वो करने की जरूरत नहीं है।
हाँ
कर लिया
हाँ डाउन एक
देख लो एक बार, फिर यहाँ वो लगा भी पॉइंटर वाले। हो गया मैडम। मेरे को वापस देख लो, हो गए देख लो, हो गए ठीक
हाँ हाँ
है।
एक बार भी कंफर्म करो बस सब सजा सीक्वेंस में
We will now resume our session on sustainable solutions for One Health. So our first speaker for this session is Dr. A.T. Vanak. He's a notable Indian ecologist renowned for his pioneering work in wildlife conservation and human-wildlife interactions. He holds the position of Director of the Center for Policy Design and Senior Fellow at the Ashoka Trust for Research in Ecology and Environment, ATRI. His research primarily focuses on urban wildlife, carnivore ecology, and dynamics between humans and animals in shared landscapes. He has authored numerous research papers and collaborated with national and international conservation organizations, leaving a profound impact on the field of ecology and conservation in India. I now invite Dr. Vanak to talk on the ecological basis for robust One Health systems.
Thanks. Morning all, and thank you for having me here to speak at this really important meeting. Actually, much of my talk has already been given, and I could leave these slides here and not have to worry about it, because the speakers before me have really given you some excellent examples of One Health at work and the place of ecology in it. But since I'm here, I figured I might as well give you a couple of good stories myself. Yeah. Okay, yeah, go ahead.
Thank you. Sorry for the interruption.
So, yeah, so, let's not worry about the definition of One Health and so on too much. I'm sure most of you have heard it. Is there a way for me to maximize that? Ah, there you go. But all of you, of course, are quite well aware, I'm sure now, of the interconnectedness. Everybody's talked about it: intersectoral coordination, interconnectedness. We're all one health, one happy family, etc., etc. But in its very essence, though, One Health is a collaborative, multi-sectoral and transdisciplinary approach, as well as interdisciplinary approach. So keeping that in mind, let's talk about how where these interactions come in and what is the importance of these interactions. We've heard a lot about zoonosis transmission. We've all gone through a pandemic, once in our lifetime, hopefully. But let's talk a little bit about these mechanisms. What does it mean? How does it come? What do these interactions, how do these interactions form, and what is the impact of these interactions on us? So there's a couple of terms here. One is spillover, which is cross-species transmission. and zoonotic spillover, which is animal to human transmission. Okay, so let's imagine we have a wild interface somewhere there, and wildlife are doing their thing. And here we've got bats as an example, but you can use any other kind of taxa. It could be rodents, could be primates, anything else. Okay, and then you have people on the landscape. Of course, there's farmers, there's city dwellers, there's urbanites. Now, infection and disease transmission is a natural process. Microbes or pathogens, what we call pathogens, are also living organisms for the most part. Viruses are, in sort of this gray area. So they're part of ecosystems. They have important functions to play. So despite us thinking of them as deadly enemies, they are still living beings that are part of ecosystems and play very vital roles in those ecosystems. There's a fascinating book by Pranay Lal that I also recommend you read about the role of pathogens, viruses in particular, and what they do to shape ecosystems. But wild animals have an infection cycle. There are low levels of infection spreading throughout those populations. And if you have an infection, you also tend to shed those infectious particles. Now, in some cases, those infectious particles may shed to a bridging host. They could be a domestic animal, or they could shed directly to humans. And that can result in a spillover event. Okay. Now, spillover events happen all the time, but sometimes the infection itself, as a result of that spillover, happens rarely, because there's lots of barriers to cross before a pathogen from animals can actually infect humans. The spread cycle is what's interesting and what's got us most interested recently, because the spread cycle is often independent of what happens on the left side. The spread cycle is often the result of modern human activity. So travel, urbanization, global travel, so on and so forth. And you'll see that in this slide. Basically, you have all of your domestic animal amplification, human amplification, spillover, etc. And we've had instances of epidemics arising, but not leading to pandemics. They've all been localized. For example, Ebola or Marburg and so on, even the Nipah virus. But it's really international travel that has caused the spread of these and to become pandemic. And there's some broad patterns to the risk of emerging and re-emerging infectious diseases. Okay, several scientists have come together to analyze what these patterns tell us. One is that areas that are biodiversity hotspots, so basically where you have more animals and more life, is also where you're likely to have more organisms that can be pathogenic. And of course, as humans, where people live is where we are most susceptible to those pathogens. And where livestock occurs, because where people live, we also have a livestock, they can then form that interface more closely. So those then result in hotspots of risk of emerging and re-emerging infectious diseases. And as you can see, India and southern China basically are amongst the hottest of hotspots, okay, for the risk of emerging and re-emerging infectious diseases. In a sense, what we want to do then, using a One Health surveillance system, is to try and understand what those different boxes are that we want to target. Now, One Health is traditionally, at least in the Indian context, we haven't really embraced it in its entirety, mainly because we are focusing on either the animal side or the human health side. We're actually looking at the after effects of it. We are looking at what happens after the spillover. Very rarely do we look at the spillover event itself or before the spillover event happens. Okay, so this is where I want to bring in centrally the principle of ecology, and why ecology is fundamentally important to the One Health system itself, because without that, all we're doing is traditional health. It's no longer One Health. And this is the puzzle that we're mostly missing. we've proposed, there's all of this is public knowledge. There's nothing new that I'm presenting here. But basically, targeted monitoring strategies are there for One Health sampling. And we know we've got livestock health sampling. We know we've got human health sampling, but the wildlife health is almost completely ignored in India. And this is a huge lacuna. So I'll give you a couple of examples. Now, this is a study that we've been doing in Pune city. Rabies is a really common disease in India, but rabies control has almost exclusively focused on the human side. So post-exposure prophylaxis. Very little focus has been given on the animal side, and what little has been given in terms of mass dog vaccination and so on is again devoid of science from the Indian perspective. A speaker previously, Dr. Kotach, I think, talked about generating our own evidence, and that's kind of been missing. We've been always guided by WHO and WOA about how we should do our vaccination programs. So anyway, I'll quickly go through this because I'm in danger of running out of time. But I worked together with an organization called Rescue that's based in Pune, and they run an animal rescue facility. So we adapted their system into a passive passive surveillance system for rabies. So basically, animals would come into their hospital facility, and if they died, I would test them using a simple, ready-to-use lateral flow assay. All of you are familiar with this now. During COVID time, it became very useful. But you can use a similar device for testing for rabies as well. But you have to test it on the animal's brain extract and not just the saliva, because saliva is not confirmatory. Even this test is not 100%. Definitely, there's a lot of so there's a lot of false negatives in this. So we still send samples over for validation. So what we found is, and this is just 1 year of data. So each red dog in this is a rabid animal, and this is in Pune city. We found that the number of rabies positive cases in Pune is quite alarming. And this is something that people of Pune and definitely the municipality of Pune and all the animal welfare organizations of Pune had not realized the severity of. Okay. So you can see very quickly that map turns red. So this is what the passive surveillance looked like after about 4 years of surveillance. Lots of cases, lots and lots of cases. Okay, almost more than 700 plus cases, and more or less equal throughout the year, with over the years with some sort of seasonal pattern of emergence, with some hotspots in space, but not necessarily in time. Okay. So what this tells us is that there's a lot of, when we are coming back to this picture now, what it tells us that where people are living with animals is always a high risk of disease. Okay, and it's important for us to also study the animals in great detail, study the ecology of the animals in great detail to be able to come up with ways of preventing that spillover or of ensuring that spillover doesn't occur, or if it does occur, we are at the forefront. So in the case with Pune city, whenever we found a rabid positive animal, we sent teams there to educate the people around that area so that they would get prophylaxis. So they would go and get the vaccine itself. Or if any other animals were exposed to that, those animals were given vaccination. And follow-up was done. So that people, and thankfully, no cases of rabies were reported from Pune city itself in all of those 4 or 5 years. All the hospital cases that were reported in Pune came from outside Pune, because rabies still primarily is a problem of rural areas. And all of our vaccination programs and all the people here crying on about dog welfare only focus on cities. Nobody's looking at the rural areas, whereas 95% of human rabies cases in India are reported from rural areas. Something like new figures need to come up, but previous figures indicated about 20,000 human deaths a year. Okay, so it's very alarming. I'll quickly move on to another example. Basically, if you look at what the narrative has been in the last couple of years about human impacts on nature and how humans interacting with wildlife and so on tends to increase our risk of pathogen exposure. So what they tell you is, let's not go into wild areas. Let's reduce our interaction with wildlife. Well, a lot of people in India don't have that luxury. And in fact, it can actually be counterproductive. People depend on forest landscapes for their livelihood. Millions of people do. People depend on animals for their livestock, for their livelihood. Okay, we have the highest number of livestock in the world. So to ask people to reduce their interactions with wildlife, or to reduce the interaction between wildlife and domestic livestock, is almost impossible. So what can we do in this regard? How can we optimize benefits that forest dwellers have whilst trying to reduce the impact of diseases? So this is an example I'll give you from Kyasanur forest disease. And Professor or Dr. Kulkar Ganguly in the morning spoke about KFD, and he talked about the Center for Ecology and Hydrology that was, and Dr. Hoti, and this is a project that I'm a part of as well. And I'll give you an example of what this disease is and how we were able to better understand it, because a lot of pioneering research was done on this disease in the 60s and 70s. And after that, like with many things in India, that goes down and nobody does follow up on it afterwards. So it becomes dogma. Basically, we stop doing science, and we believe that, oh, everything we want to know about has already been done. You know, Professor Rajgopalan did it in the 70s, and we don't need to study it anymore. But what actually turns out is that things we thought we knew back then don't seem to be following those cycles. There are missing gaps in our understanding of this disease. So we sort of went back to the drawing board. Now, this disease is a tick-borne disease, okay, and it's caused by a flavivirus that can cause fairly debilitating hemorrhagic disease. At some point of time, more than 500 cases were reported, but those number of cases have been coming down of late, primarily due to a lot of efforts by the government in trying to educate people about how to reduce their risk from this disease. But the disease has also been spreading in geography. Okay, and it's a very complex transmission cycle, as almost all vector-borne diseases are. Okay. Let's not worry about these, but there are a few species of ticks that are most involved in the transmission of this. And if you look at this, you'll see that the ticks themselves have a multi-step life cycle. Okay, they go from an egg stage to an unfed larva, which then feeds on small mammals, monkeys, birds, becomes a fed larva that then matures into a nymph. Okay, and then from a nymph, it can then become an adult, and from an adult, it will then become the process starts. But at each of these stages, it is finding a host for a blood meal, because those blood meals are important to produce their eggs or to move on to the next stage. Okay, and the amplification of the virus can happen at each of these stages. So we found KFDV in all of those different hosts. They're found in small mammals, they're found in rodents, and they're found in humans, of course. Humans are an end-stage host. They don't transmit that virus further. Livestock don't tend to get the virus, or we haven't found enough evidence that they have high viremia if they get it. So they also don't play a role in transmitting of this virus further, but they do play an important role in tick number amplification itself. Okay, so the more livestock you have in an area, the more number of adult ticks you'll have in that landscape. And what do these landscapes look like? These are typical working landscapes in the Western Ghats. You have forest on one side, some sort of plantation, it's an areca nut or something else. In Maharashtra and parts of Goa, you have cashew nut plantations, you have paddy. So sampling all of these and trying to understand these different stages really requires this interdisciplinary One Health surveillance, where you're not only sampling for ticks and all the domestic animals and catching wild animals to study which species have what and where, not just what, but where. What kinds of habitats are riskier for these kinds of diseases or for risk of catching ticks. But you also have to understand where animals move. So you deploy them with, you put GPS collars on them, follow their movement around. But eventually we are concerned about what happens to people. So we also do people surveillance. We try to understand their behavior and what happens when they move into the forest, what happens when they are doing their normal routine, and which habitats or which landscapes are riskiest for them in terms of catching ticks. Okay, and that way we can develop better systems of trying to prevent people from getting infected, even in the absence. So Dr. Ganguly spoke of vaccine. That vaccine, unfortunately, has been found to be ineffective now. It was old technology. There was no improvement of the vaccine. The vaccine has been discontinued. They're trying to develop a new vaccine now with more modern technology. But at the moment, people are unprotected. So we need to use other methods now of reducing their susceptibility to the disease. So we have come up with different tools. So for example, a decision support tool for trying to predict where zoonotic disease can occur. Now, the problem is that most of these tools focus only on single set of processes that drive this risk. They often, it might be only a social process or an epidemiological process, or very rarely an ecological process. But the interdisciplinary nature of this work means that you are able to then link all of those together in a proper One Health framework, okay, that then allows you to understand what is disease risk. Now remember, risk is hazard and exposure, okay? So when you have the ecological communities there which are creating the hazard, and you have the risk of exposure, which is the resource use and the priorities of forest users. So you have to put both of those together to actually understand what is disease risk. And that's what we came up with for this landscape, where we used all of the data that we had collected, and we were able to then come up with a spatial model, a spatially explicit model of where KFDV can occur in the landscape. So you use data from the past, you used a whole bunch of different GIS layers and other geospatial layers, including data from on the field where the ticks occur, where the KFD virus is found, and so on. Okay, and then we build these models that will allow us then to predict ahead of where the next outbreak can occur. So then using this, we're able to actually pinpoint areas that were previously not affected by KFTB. And we were then able to direct the state authorities, the Department of Health and Family Welfare Services, who were all part of the creation of this model. Now, this is the other thing that was very useful for us is all the government agencies were not passive recipients of this data coming in from an external group of scientists, but were part of a process called co-production. So they were involved at the design stage itself, so they understood what goes into it. Otherwise, government sector practitioners and people in the field sometimes think that people coming from outside don't know what's going on. But if you involve them in the initial design stage of the process itself, they feel part of the process. So this is not coming from outside, it's led from within. And so therefore change is faster, it's more effective, it's more immediate. And that way we can direct this kind of action immediately on the ground. I'm just going to end my talk very quickly with this last slide, where we opened up to see if this is actually happening at the level of India or not. And what we found is that there's a lot of institutions in India that work on zoonotic diseases. Okay, most of them are from the biomedical field or from the animal health field. And you see there's one corner out there, the wildlife health field, which is barely connected to the rest of them. Okay. And that's the gap here. And this is what we really need to address. Ecology is currently missing in the field of One Health in India. And ecology, in fact, has to be at the center of the One Health field, because after all, that's what all the interconnectedness really is in One Health. So I'll stop here. If you want more details about the monkey fever risk project, it's available on our website. But I just want to quickly say that this requires more than a village to raise that baby. So go ahead and take a look. But this is the kind of effort we really need to understand not just zoonotic diseases risk, but almost every other problem that's facing India currently. So I'll end my talk here. And I think we have discussions afterwards. So I'll hand over to the committee again. Thank you.
Thank you, Dr. Vanak. Our next speaker, Dr. Meenu Chhabra, is a professor at IITJ's Department of Bioscience and Bioengineering, holding a PhD in Biochemical Engineering and Biotechnology from IIT Delhi. Her research focuses on microbial fuel cells, algae biofuels, bioremediation, and saline wastewater treatment. I invite Dr. Chhabra to speak on sustainable solutions for energy and environment. Yes.
Uh, a very good morning to all of you, respected Professor Chaudhary, Dr. Todeja, and the entire organizing team. My name is Meenu Chhabra, and I'm going to talk about the sustainable solutions for energy and environment. We've been listening to distinguished speakers. We've been listening to distinguished speakers since morning. And what we have learned is about the One Health, the triad, the interconnections between the human health, animal health, and the environmental health. And this particular slide tells us that it is the environment which connects the One Health with sustainability. And it is actually one of the very, very important component, rather the most underappreciated components of One Health. Because environment health is directly impacting the human health and the animal health. Of course, we heard in the morning that how the human activities and uncontrolled emphasis on the economics of the sustainability triad. This uncontrolled the overweightage of the economics has really taken a toll on the environmental health and the social acceptance of the particular technology. So this environment is something that connects the One Health with the sustainability. And if we look at the different components of the environment, then we know that water, air, soil, and biota constitutes the four most important components of the environment. My probability of catching a disease in this particular room is directly proportional to the distance at which I'm sitting with a person who has an infection. But my probability of catching a disease because of polluted air is much higher because we all are inhaling the same air in this room. We all are consuming the same water that is being supplied to us. So water, air, soil is something that impacts us at a much greater scale. And of course, that doesn't mean that the health angle is not important, absolutely extremely important. But if we look at the root cause of the problems, then it will not be an exaggeration to say that environmental health maybe is at the apex of causing the entire problems or the crisis that the human populations are facing these days. So these two examples which I took, one is climate change. We know how climate change is impacting biodiversity, and this very loss in the biological species has led to zoonotic diseases, scarcity of water, and human encroachment. So we were hearing from Lieutenant General Chadda that how the human encroachment is happening, how the migration is happening because of climate change. People are moving from the mountains, from the Himalayan regions to the plains because they cannot stay there any longer because of the climatic conditions. Environmental contamination, for example, soil contamination, has the ability to impact soil fertility, which can result in the production of inadequate food, can cause malnutrition and emerging diseases. So there are a lot of non-communicable diseases probably which are arising because we are living in a contaminated, we are inhaling polluted air and we are drinking contaminated water. So with that note, the main message that I want to give is that we need to resort to from the conventional methods to the modern treatment methods. A lot of works are happening around the world on development of advanced treatment processes. And this is the time that we adopt those processes if we are seriously thinking about One Health. This particular slide shows the water contamination in the conventional wastewater treatment system. So as we can see that when the water goes down our drains from our toilet flushes and our bathroom sinks, it eventually undergoes 3 types of treatments in a conventional water treatment system. So the primary treatment, which essentially is physical, that separates the solids from the liquid, and the secondary treatment, which is essentially biological, where the microorganisms convert the chemicals which are present in the wastewater into the harmless gases. The primary, secondary, and tertiary treatments are the ones which are responsible for providing clean water in our taps. This entire process is highly energy intensive. So as you can see, there are raw sewage or the raw wastewater. It's taken to the screens, to the grid chamber where the solids and liquids are separated by sedimentation. The treated water, the solids are separated, and the liquid part, which contains the soluble impurities, then enters the secondary treatment where tiny microorganisms degrade the water. A lot of energy is spent in aerating the water, in providing the oxygen to the water to get rid of the wastewater constituents. The wastewater is treated and the insoluble bacteria are produced. These bacteria are also the major ground of holding because it's a consortia of microorganisms. There are a lot of pathogens and therefore a tertiary treatment is done to disinfect the water before providing us to our taps. So while this process is happening, as I said, it's extremely energy intensive, requires very high energy input. It is in the order of 0.3 to 2.1 kilowatt hour per cubic meter. We have to really invest a lot of energy. There's improper utilization of solids and sludge. The solids that are separated are eventually ending in the landfill. We are not making use of that. The long treatment times, one single batch of water takes 10 to 15 days for treatment, and the systems are fixed volume. So this is a picture which shows the typical wastewater treatment plant, and you can see that these are all concrete-based structures which have fixed volumes. They cannot really undertake increased demands or increased flow of wastewaters. If the flow of wastewater increases, the capacity of the treatment of the plant automatically goes down because the systems are not modular, the volumes cannot be increased. So the inability of these systems is also to remove the recalcitrant or difficult to degrade compounds. And the other important thing with the conventional water treatment systems is that the water quality monitoring relies heavily on the lab tests. The water is taken to a laboratory where all the water quality parameters are monitored. Similarly, there is a water distribution network failures that also causes a problem with getting the water through our taps. So adopting modern solutions can really help us in overcoming some of these difficulties. For example, wastewater has 10 times more energy than what we are investing in treating it. If we use the energy which is hidden in the wastewater and harvest that energy, it rather turns the entire cycle into our favor. We don't have to invest energy in treating water, rather we harvest energy by treating water, and while we do that, we also treat the water. Having centralized versus decentralized water treatment systems. If you have a common treatment facility for the entire city, it is very difficult for the water to transport to that particular treatment plant and reach back. But if you have decentralized systems, then that can really help a community, a population, a city, a society to have water quickly through its treatment plant. We can make use of high-rate bioreactors. A number of researchers and a number of researchers across the world, including our institute, have developed processes which are very high rate. They can treat the water at the rates they can meet the demand of the population. Adopting those systems also helps with lesser sludge and energy harvest. Constructed wetlands is one example. Advanced oxidation processes is another example. Then the most important thing is the intelligent sensor systems for smart water management. Water that is currently supplied is of a single quality or a single grade, whether it is coming through my bathroom tap or it is coming through my kitchen tap. It is important to grade water, and that can also help reduce the amount of energy that is invested in treating the water. So for smart water management, a number of sensor systems that can be installed to grade the water where the role of IoT and such networks come into picture. Water surveillance for the transmission of waterborne diseases again become a very, very important component of water sensing system and the creation of early warning systems, as we have been hearing. So just to give one example that we've been working on, of course, there are numerous examples, as I said, but then we can harvest the energy from the wastewater, and we can actually compare that with the conventional processes to see how it weighs over the conventional systems. So if we look at microbial fuel cells, for example, the microbial fuel cells are capable of harvesting energy from the wastewater. They are capable of treating different types of wastewater. If I mix industrial wastewater with the municipal wastewater, there is a probability that the entire system fails because industrial wastewater has toxics. But when we have a robust system that is adaptable, then we can actually mix a composite waste and treat that in a microbial fuel cell. These systems can harness the energy from the waste rather than investing the energy towards the water treatment. Then if we compare the conventional process with this modern process like microbial fuel cell, we can see that the conventional process, it removes carbon, nitrogen, and phosphorus sequentially. And that is why it takes 10 to 15 days time to treat a batch of water. Whereas a system like microbial fuel cell can simultaneously remove the three nutrients. The conventional process needs energy input. The MFC process can produce electrical energy, and it can also be combined to produce biohydrogen or biofuel. So this entire water, energy, and food nexus can be taken care of if these advanced processes are adopted. So these processes can also help with not just the water and energy nexus, but also the water, energy, and food environment nexus that optimizes the usage of energy across the treatment processes. Another example that I have is of the sensors and AIoT-enabled water monitoring and distribution system. The conventional distributions have problems because the water supply rates are lower because the treatment times are longer. The higher treatment costs are there, but with the use of surveillance system, with the use of sensors and networks and grading the water, for example, the nitrogen and phosphorus-rich water can be supplied for agriculture. In that case, one can save the cost on the fertilizers. Lower energy consumption because we now don't have to treat the water completely. Also, it meets the demand and supply by lowering down the energy input into the process. So with that, environment surveillance, as I said, environment lies at the apex, and it's very important to take care of the environmental health, because once I take care of the environmental health, I can take care of the number of crises that are arising because of the One Health. And the consumption and the production activities have to be balanced. Currently, our consumption activities are producing a huge amount of environmental impact and stresses on the ecosystem. In order to conserve that, we need to really get into resource discovery and minimum disposal, like in circular economy, and these advanced oxidation processes and advanced water treatment processes, where a lot of life cycle analysis have been done on case-to-case basis. If these are adopted, then they can help restore biodiversity, they can help control pollution, can help stop pandemics. We've listened to numerous examples in the morning how different type of zoonotic diseases are emerging. But then if we take care of the root cause, probably the ones which are in line Probably we don't know about the infections which are probably ready to infect us, or the pandemics which may come down the line 5 years, 10 years, may be stopped. We can reduce economic stress, enhance food productivity, ensure human and animal health, and also conserve natural ecosystem. With this quote, I'll end my talk. This quote is by Wangari Maathai, who is a Nobel Peace Prize winner. She says, the environment and economy are really the two sides of the same coin. If we cannot sustain the environment, we cannot sustain ourselves. And with that, I'll thank the audience for listening to this talk, and thank you very much.
Thank you, ma'am. Our next speaker is Mr. Hitesh Sharma, who is the South Asia lead for Sustainable Impact Operations and Compliance at HP Incorporated. In this role, he oversees HP's commitment to becoming the world's most sustainable technology company by 2030, focusing on carbon neutrality, circular economy strategies, and for digital equity in the South Asian region. He also serves as the Asia Pacific Japan region lead for circular economy and the HP Planet Partners program. I invite Mr. Sharma to enlighten us about regenerative systems.
So I could operate from here. Right?
Yes, you can change it.
Sure. Thank you so much. A very good afternoon to everyone. Okay, before I start, I would like to thank Dr. Chabra for a great segue connecting environment with economy. So it helps me fit well since we were hearing about One Health since morning today. Before I start, I would want to actually quote something which has been said long, that don't give them the fish, teach them how to fish. I'm sure many of us have heard this particular saying. In fact, almost all of us here. But it all depends on how do we interpret the how to fish of it. Does it come with the skill, the technologies which are required for fishing, with a growth-oriented mindset, a mindset which is more consumption-led, or does it come by the how part of sustainable and responsible way of fishing, where we are more empathetic towards the system in which the consumption has to happen, being more empathetic towards the finiteness of the resource, the fish, which is being provided by the natural ecosystem. And I think that's where we need to step ahead, go beyond in really interpreting and taking a more systemic approach rather than a self-centric approach in dealing with the ecosystem which we all operate in. So on that note, I would like to share about how the presentation. Because the resources are finite, but what we have at disposal for us as humans is definitely the intelligence, the imagination, which has infinite potential. And hence that infinite potential to be best utilized for creating regenerative systems. In fact, while the presentation comes up, it's not just the living system. Human intelligence has shown capacity and capabilities to bring in regenerativeness in the non-living systems. I was reading this article of an MIT study somewhere around January, which uncovered the reason for sustenance of Roman architectural structures over millennia with simple use of lime cast, which actually has a self-healing capacity, which could actually fill into those fractures. And when it gets in touch with the seeped in water, which otherwise is an adversity for an architectural structure, it utilizes it as an opportunity to fill up those fractures. And that has been a reason for those sustenance. In fact, at this forum, I'll take the liberty of making a non-researched rogue comment. When I read this, it kind of brought me back home to Jodhpur. And I was actually thinking about the lime plasters, what we've been using in our structures in Jodhpur. And maybe this is a call out to researchers here, that could we have a case study of Jodhpur and sustaining structures of Jodhpur? With a dangal spirit that Maro IIT, MIT se kam hai kya? So I think on that note, I'll come back to, and I'm sorry for the digression, but I had to actually spend some time before the presentation was up. Okay, now coming to the idea of regeneration. Why it's not working? Yeah. As I was saying, going beyond. So going beyond at HP, the way we talk about is being mindful that it's not just about we producing a product. It's about what lies at the core of what, this consumption. It's the people who are consumers and are part of an ecosystem we all survive and thrive in. With that note, in fact, this is what our leadership actually, I would say, percolate, that we would want to be the world's most sustainable and just tech company. And on that note, it's not just sufficient and enough to actually set a purpose. In fact, the purpose with which HP was brought in 80 years back was to create technology that makes life better for everyone, everywhere. Now, that's again an ambitious calling, because then your stakeholders are not limited. When you say everyone, everywhere, you're actually bringing in your stakeholders beyond your shareholders, your customers, your value chain. You're actually bringing in those stakeholders which are mute, which is the environment, or those stakeholders which are non-existent today, which is the future generation. So how do you ensure that every decision of yours is systemic in nature, more comprehensive in nature, more responsible in nature, more regenerative in nature? And to keep this compass of purpose in our practice, these are two of our major commitments. One, that we would have 75% circularity in all our products and packaging by 2030. And I'm proud to say that we have achieved 39% till last year. 39% of circularity in our product and packaging would mean that our products, the PCs, the printers, when we produce them, we're using recycled content or reused content. Similarly, it applies for the packaging material, which is either recycled, reused, or coming from renewable sources or certified sources like the Forest Stewardship Council certification. Second, on again taking a systemic and a value chain approach, HP is committed to go net zero across its value chain, not just limiting it to its own operations. And just to set perspective, our own operations in this target is just 1%. Our 59 or 51% lies in our downstream on the consumer side, or 49% lies in our upstream, which is the supply side. So we have taken this ambitious target to go net zero by 2040 across the value chain. And how are we doing it? I'm sorry for the heavy slide, but I would just highlight some of the key aspects here. One, identifying what are those strategic pillars on which we need to operate. Of course, looking at the emergent, urgent needs of our time, looking at the pivotal role we could play as some one who could actually manage the supply side as well as the downside, the downstream side, as an electronic manufacturer. And the third important thing, being a technology provider ourselves, what is that competence we carry, which we could contribute towards our communities to bridge the digital divide? Because digital is the next oil, I would say. For anyone to even prosper, that's what we all need. And hence, we are looking at reducing or eliminating this disparity which exists in form of digital divide. So that's our stewardship role. Not getting too much into the other parts of it, but coming to the subject of regenerative system, the way we do it is offering our products and solutions in a manner that we keep material which goes into producing our products at their highest state of value for the longest possible time, reducing the resource consumption in both its make and use, and eliminating both waste and emissions throughout the process. And when I say throughout, as I said, it's a value chain approach what HP takes. So I think on that note, what we say is HP tech has a life cycle, not a lifespan. We look at more circularizing ourselves than a more linear mindset of what we create, dump it to the consumption side and forget about it. And it doesn't make business sense as well. So I think there are three key aspects where we are doing what we're doing the right thing the right way. Before use of our products, during use of our products, and after use, just to simplify things. So coming to before use, which is actually the design stage, HP is looking for alternative sources of material which could make HP products. And this alternative sourcing goes to an extent of using PET bottles, which would have otherwise landed into an ocean, to bring it back, reverse channelize it to create our products. So the HP laptop, what you're using, the fan in it is actually made out of a PET bottle, a waste PET bottle. In fact, to an extent, I would go that we look for such unusual waste streams, as unusual as used cooking oil. We bring it back through biosynthesis and our research and innovation. We are able to create biopolymers and use that used cooking oil to create the basil, what you see on your laptops, which actually saves your screen from the keycaps. So that is actually made out of a used cooking oil. The finish, what you see on your PCs, the speckle, it's coming from the coffee ground residue. So we have, so you're seeing the kind of unusual suppliers we have got now into our value chain, ranging from plastic waste pickers to restaurants to coffee shops. So that's the kind of unusual relationship which needs to be brought in to look what is waste to one could be a resource to us, and how do we actually bring in that interconnectedness or interdependency and actually use it for the betterment. During this use phase, of course, product longevity, repairability, refurbishability, a lot of other aspects go into ensuring the during use phase, I would say, sustainability, and that is all coded at the design stage itself. But what's important is how do we actually even relook at the notion of use itself? So as a consumer, do you really need a computer or computing? Do you really need printing or a printer? So can we re-engineer ourselves as HP to be able to provide you device as a service, to provide you laptop for computing, not to own it, but just use it? And we're doing it. These are, whatever I'm talking about are operational, in-field, I would say. And in fact, I would say 65% of our revenues have started transitioning towards from product-based to service-led models. And this re-engineering is not just limiting in just bringing these notions, but also re-looking at the talent, what we need. So if the talent which we acquired was best fitted for selling a product, today need to be best fitted to service the client. So service orientation, right? So a lot of re-engineering on that phase. At after use phase, which is one of the most important phase where we are able to reverse channelize our end of use, end of life products, we set up huge systems like Planet Partner Program, which I manage for the Asia Pacific Japan region, is one such program which reverse channelizes the entire end of use, end of life material from our consumers. And we are slowly, steadily moving towards reducing that burden of reverse channelization on us. By how? By actually offering service-led models. So you see the kind of interconnectedness and how each feeds into another. The program itself, how they're regenerating itself, rejuvenating itself, that when I bring back a product from the field and see there is a residual life in it, and if I'm able to refurbish it and bring it into the system back, but now as device as a service, because there is this mindset barrier which we need to overcome, where people don't really want to buy a refurbished product. Or I would say not many, because things are changing. Doing so, we are able to actually fuel another business model, which is trying to be introduced into the system. So that's the kind of regeneration or regenerative approaches we bring in to actually rejuvenate the entire consumption process itself. These are some examples. I would not delve too much into it. As I said, 100% of HP PCs, displays, home office printers, which we introduced in 2022, include recycled content. And our current progression is around 39%. And I would also want to highlight, when we actually do these kind of products, right, where we, the operations, where we prevent, let's say, these plastic bottles from reaching the ocean, in process, we are actually investing into the communities. So a plastic waste picker community, which was not fetching enough value for those PET bottles, have enhanced their income because now this product is feeding into a system which produces HP products. So you see an unorganized, informal sector getting formalized with capacity building. And that's the kind of investment we put in these, because we have to actually reinvent our supply chain. These aren't existing supply chains. We have to reinvent them. We have to invest in it. So I keep getting these questions, some that when you're doing all of this, does that mean that your product would be cheaper now? Yes, when we have actually achieved that economy of scale, because right now it's an investment for us to be able to actually create that supply chain, to be able to have a perennial flow of this, to be creating such products. But yes to that later. Again, a major negative externality, what we see coming out of our own product, which is a printer. While the paper what you print on your printer is not my footprint, it's a consumer or a customer's footprint, but that's what we take as our footprint. As I said, that value chain approach, we can't survive and thrive within our own green premises, So we can't be those green islands amid the ocean of garbage. The need is for us to take a steward or play a stewardship role across the value chain. And what we have done here as a project is that we have taken, in fact, we have done a projection of what kind of paper and how much paper would get consumed over the next 10 years over all HP printers installed worldwide. And how would that influence the natural ecosystem, the forest ecosystem? That, basis that as our baseline and as our target, we have initiated projects with some of the world's largest wildlife organization. And these are science-based projects where these afforestation projects are not actually creating monoculture of forestation. These are rather intertwined with working with the indigenous communities, livelihood options, site identification, which can have maximum impact in acting as carbon sinks. So a lot of things. So if I were to just simplify things, whatever HP's printer prints over the next 10 years have already been counterbalanced today as a I would say as an initiative, which over 10 years would one counterbalance, and after 10 years, we believe these to act as carbon sinks for a lot of other GHG emission reduction projects which we offer to our clientele. These are projects which we call carbon neutral computing, where third-party assured carbon neutral certificates are provided to our customers that their entire carbon footprint of their product, right at its production, transportation, and product use over the next 4 years have been, I would say, offset. And that is something which we provide as carbon neutral computing services. Okay, these are some stats. And this is something which we also believe that what we're doing within our own premises need to be communicated to be able to create a change-making effort or influence others to adopt what we're doing, and actually conveying that it's all a lot of business sense. This is not charity. And I come here as a business professional. So whatever we're doing has a lot of business sense in it. So I think on that note, I would just say that let's go beyond together. And also here, I would also want to convey, I started by saying about, growth. There's one major difference between growth and development. And I would want to actually convey that difference by a small example, that a piling up heap of garbage grows, it never develops. But it's the development or the regenerative mindset which can make that difference. I think that's where that whole different, or in fact, that's the change in approach which we all need to adopt to be able to actually create a more regenerative society. Thank you so much.
Thank you, Mr. Sharma. Our next speaker is Mr. Bhagirath Chaudhary, who is the founder and director of the South Asia Biotechnology Center, a recognized scientific and industrial research organization. With extensive experience, he has contributed significantly to the agricultural sector, including roles on boards such as Agricultural and Processed Food Export Development Authority, Spices Board of India, of the Ministry of Commerce and Industry, driving the transfer of bio-innovations from lab to land for India's bioeconomy growth. I invite Mr. Chaudhary to speak on bridging knowledge between science and society, bio-innovation for agriculture, social and environmental change.
Put the presentation?
Yes.
So good afternoon to everyone. First of all, I want to really recognize the student community who's sitting at the back of this particular hall. We are all on the same platform. Okay, so whatever I'm going to talk to you today through my presentation is basically, how you as an individual would like to shape up your career for this whole One Health initiative that has just now been, that you're participating. I'm really very pleased to be part of this IRA campus. I want to thank Professor Chaudhary. Professor Chaudhary, thank you so much. I have been in Jodhpur since 2017. After traveling almost 60 countries, working with best of the best mind in agriculture sciences, I started doing something in Jodhpur. But IIT remain quite far, even though I am based in Jodhpur. So I want to really thank you, sir. My applause to you, sir. Thank you so much. You know, I'm so happy to be here today in this side event. I was part of the keynote speaker of the G20 Biocircular Economy event that happened under the umbrella of RIIG in Dibrugarh. That meeting, Research Innovation Initiative Gathering meeting, it took place under the aegis of DBT, DST, and Earth Sciences. So was very fortunate to be part of that meeting that happened under RIIG. Today, this whole Chief Science Advisor Roundtable, this is another vertical under G20. And for my students, it's very important for us to really understand what this G20 and why these different verticals that exist. You please have to really look into it. These are very important areas for research, science, innovations, and global interconnectedness, collaborations, technology transfers, technology development, co-developments, a lot of things that would happen because of these umbrella programs that India is taking part by hosting the presidency of G20. We as a generation are also very fortunate that not only now we are hosting G20, but we are also celebrating International Year of Millets. Very important because that takes us to the roots of what India as a civilized country is. And fortunately, we are also celebrating 75 years of Amrit Mahotsav. We are so fortunate to be part and parcel of that India where, all these three big celebrations are happening. Today, in next 15 minutes, I'm going to share with you something that relates to agriculture sustainability as part of this One Health initiative. Some of the slides that I'm going to share with you, I actually did share during the biocircular economy meetings that happened in Dibrugarh. And two of the very important sustainability technological components were integrated in the biocircular economy outcome that came out from the Dibrugarh meeting. Agriculture is a very important component of whole of ecosystem that we are talking. HP won't exist. We will not exist if agriculture exists, if the agriculture is not there. It's so important. Agriculture is ecology. Agriculture is part and parcel of the ecosystems that we live in. Agriculture is what we are. The food, without food, nothing will happen. So sustainability in agriculture becomes so paramount that it influences everything that has to happen under the One Health. And you've seen since morning, a lot of these speakers spoke about all the diseases that come from maybe wildlife because of displacement or because of zoonotic diseases, because of livestock. That's part and parcel of agriculture. So, but farming community, I can tell you with my very vast experience that I had for many years now, is changing quite rapidly with quick adoption of technology, innovations, regenerative practices in agriculture, to the extreme of genome editing, to the recombinant DNA technology. Farming community are adopting drone-based technologies. We got into the precision agriculture with all kind of micro, macro irrigation systems that are putting in place in agriculture. Farmers are also moving to decarbonizations. Farmers are also moving to areas where they can sequester carbon. We are also looking at possibilities of how farmer can avail the carbon credit that a Lieutenant General has shown you in the morning, that one carbon credit can fetch close to $5.5 if you can actually sequester your soil, sequester the carbon into the soil. And farming can play a very, very important role. We lived in this country for 75 years not 75 years, till 1993, under this arena where agriculture was basically shackled by license Raj. Nothing used to happen in agriculture without the permission of the government. But that started changing. And all the technologies that I just now described to you is coming to agriculture and trying to evolve agriculture as a very important component of sustainability because of these technological interventions that are being adopted by the farming community. Today, as I speak, our farmers are quite happy because maybe consumer is not very happy because the prices of all the commodities are increasing at the pace that we consumer are facing problem. But farming community, because they lived under the poverty, under the low income settings, today farming communities are cheering to the very good price that being fetched to the produce that they're getting to the market. This whole protectionism in agriculture, the state and center is now moving away, and we have lots of agriculture entrepreneurship activities are happening. We have also seen the huge implication of digital private public infrastructures with all the digital transactions that are happening in urban area are also being adopted by farmers and farming communities in rural areas. So the whole inequality in digitalization is being disappearing, as I have seen. And importantly, what I've seen is that there is a tremendous social respect. I work with, annually, I work with close to 10 to 15,000 farmers as my organization, through my organization. 10 to 15,000 farmers every year. And I've seen that, they feel that, there is a respect that's coming to the those who are producing food for us. And I also seen there is a momentous development in, ecosystem of agri startups in the country. You could see all kind of apps. Even there would be app that would be coming from IIT Jodhpur, I would see, that are helping farmer not only look at the whole production value chain, but how can he optimize the very precious resources that he used to produce food per acre. And because of all these developments, what we have seen is that agriculture has started to play a very important role in terms of contribution to the India's whole GDP. And for last, the estimates that come from the government of India's working group on $5 trillion economy, what we expect is that by 2027, agriculture would contribute close to $1 trillion, $1 trillion, even though we understand that, this is not that can support the number of people that actually do really agriculture. But I think it's a very significant increases in terms of annual growth that you see that agriculture would take India's whole GDP to a $5 trillion economy in the future. That's a very important message that we must all get, and we should try to see that as an individual students or researcher, how best we can help our farming community and ecosystems that they live in with technologies and innovations that we all believe that are very important for the contributions that we are talking about. All the efforts that Government of India is making through agriculture is actually leading to increased availability of agriculture produce, and therefore the surpluses that are making India very big exporters of agriculture commodities. First time, Professor Chaudhary, in 2022, India was able to export $50 billion worth of agriculture commodities. And that market is still, we are at a very nascent stage. We are talking about the international trade in agriculture that is close to $2 trillion. And our contribution, which was never been more than 15, 16, $18 billion. But today we're making a big dent in the international market as far as agriculture and sustainable agriculture produce that we are producing for the communities, not only in India, but also for the other part of the world. Importantly, this is the only sector that I see which is producing trade surplus in the country. The net trade surplus from the import-export that you see. All the electronics that we heard from our HP friend in the morning, those are our net deficits. But here, our smallholder farmers are enabling India to be a trade surplus country with respect to what we do in agriculture. Having said this, I still believe we have quite a bit of problems. And it's very important because without recognizing them, it would be very difficult to really seek the solutions. I think, our population, by 2023, we are the #1 world populous country. and now heading at 1.4, 1.5 billion people. That's where we're going to have a huge challenges of feeding this population. The second very important areas is that we are becoming deficit in water because of the use and the reservoirs that we have. Our rate of extractions is much higher, and that's where the whole sustainable technologies need to play a very big role. Climate change. I and my organization, we work on very important endemic and invasive species. We help farming community to deal with these species that they've never seen before in their lifetime. And that's where, farmers are facing problem because of the climate change induced changes that are happening. Also international trade, lackluster in our whole quarantine systems, that we have seen influx of invasive species in last 10 to 15 years in the country, damaging prospects for production of corn or cotton or chili, whatever they produce that we feel that are important for the export markets. So, Madam, can you just take? So these are the trifecta of big challenges that as a country we must need to solve. And I'm so fortunate that we have initiated a small discussion with Dr. Mitali ji, about the possibility of that what we can do in Thar ecosystems for the farmers who are producing very good quality spices, and also the millets and edible oil, other edible oil seeds produced, which has a very good export market potentials. Government of India, to address these challenges, are taking very substantial steps, and I would like to inform you that it's not only that there has been a very big increase in institutional credit to agriculture sector, but we have also seen very many big mega schemes that Government of India is trying to roll out, reaching out to those individuals, members of the farming community under farmer producer organization. And these are the steps trying to see how best we can have an inclusive growth in the economy that we see. So farmer producer organizations are the concepts that allowing farmer to develop institutions that can help them not only aggregate their produce, but also use the input in the mode of aggregation so they can reduce the cost and on the economy of scale. We have also seen huge implications in terms of crowding of private sector investment in agriculture that I've seen. Big companies from not only India, but also from abroad that are very actively engaged in activities on R&D and others. Government of India, for first time, has seen huge rationalization and simplification of regulatory system. Whether it's come to seed or it comes to pesticides, bio-based products, biostimulant, biotechnology, or genome-edited product, precision agriculture. And I'm going to give you 2-3 examples, before I end my talk. The second very important aspects as far as the sustainability in agriculture is concerned is that Prime Minister is very keen that there must be the waste to wealth, and they're very keen that at least 20% of the ethanol that's being used in the country, the 20% ethanol should be blended with residues either from sugarcane or from other agriculture products. By now, as I'm speaking, we are already ahead of the targets, and Government of India has already achieved 10% of the blending of ethanol with the biofuel. And these are the targets that we are achieving. That's very important for us. I have spoken to you about the skilling, entrepreneurship, and startup initiative. There are many schemes that I've seen. I've never seen those kind of schemes in many of the years in the past, but now you got so many schemes that are helping small, being a student, you can also participate in programs like BIRAC, where there's a lot of funding available for creating startup, companies. And finally, this whole concept of water footprint and decarbonization of agriculture. These are the 2 examples that I would like to share with you based on what I have spoken to you. Drone technology is something that, I first, as a person, as an individual, I tried to lobby with the Government of India to get the approval of drone in May 2020 when, of course, at that point of time, country was facing huge problem with issue of COVID. But, that's the point when we had the migratory locust attack in Western Rajasthan. And I remember 20th May 2020, I personally met with that time Civil Aviation Minister, and we got approval that was given by the government of India to use drone to tackle the problem of the locust, which was an invasive pest in Rajasthan. But look at in last 3 years, now drone became a Kisan drone. Anyone can own it. Government is subsidizing. So what I'm trying to tell you is that there has been so much, policy proactive steps being taken by government to see how technologies can penetrate in agriculture to create this whole sustainable agriculture production system. We have seen similar steps being taken by government of India on genome editing. People who work in bioscience, bioengineering department, you know that globally there has been a polarization of issues of use of recombinant DNA technology in agriculture. But when government actually saw the benefit of products that can be developed using genome editing, and that's again the concept that I mobilized during the National Agriculture Academy meeting, that of the 3 categories of genome edited products, SDN 1 and 2 should be exempted from the higher level of regulatory scrutiny. And precisely in 3 years, now there is a call from the DBT inviting institutions to utilize CRISPR-based systems for modifying so that you can produce crops that are resilient or maybe climate smart crops that can help farmer deal with invasive or endemic pests. And that's where the huge thrust from the government of India. Few more examples I would like to give. Even though we were working on this whole guideline, and I was part and parcel of DBT task force that drafted genome edited guideline also, we have seen institutions that have been really developing products that are very critical for agriculture and food production system in the country. So whether rice or corn or pigeon pea or biofuel microbials from ICGB to rice that actually can thrive in drought conditions, that by IARI, that is a product of Samba Masuri, with a very high yielding potentials that they have developed by the Indian Institute of Rice Research. NABI is working on banana. ICRISAT is working on pearl millets, which can impart this rancidity trait. And of course, I submitted a small note to also, madam. And fortunately, after such a lengthy the work that Dr. Deepak Pental done on mustard, the government of India also woke up to that, and that's also being released, which can help farmer to produce more mustard per unit area. Because India, as you know, last year imported 1.5 lakh crore worth rupees of edible oil to be used for our cooking purposes. That's close to $20 billion, which is almost 75% of all the import that we do. So transformation in edible oil is very important as far as the country is concerned. I want to give you 2 examples. Professor Chaudhary, India is facing acute water problem. We have our farmer, because they find rice and sugarcane very important revenue generation crop for their families. So they continue to, use the traditional method of puddling and using all kind of fossil fuel to reduce the competition of weeds in the field condition. So the whole concept of transplanted rice that we do, because that's really, you need standing water conditions, is I believe in 10 years time, we would see a huge transformations where country would move from 5,000 liter per kg rice production, water that we need, to maybe less than 500 liter water per kg of rice that we can produce. So there are technologies, some mutant lines which are tolerant to herbicides, popular herbicides are being now approved by the government of India. And we see that in future, you will see the rice that are producing, which is much more efficient and less use of water. And therefore, we can continue to be competitive and continue to be a country that can supply rice or other food crops that meet the SPS conditions of importing countries. The second important elements that Professor Chaudhary I want to share with you is about cotton. This is a better cotton fiber that I'm wearing, this gamcha. So we are also trying to see that big transformations from the cotton that we are producing at this point of time in the country can be moved to the high density planting systems, where you can optimize use of resources and produce more cotton. And there has been a big initiative from government of India. They're looking at technologies like agri-photovoltaic systems, HDPS, nutrient pest management, and also eventually using cotton straw or stubbles for making biochars. And there are a lot more such initiatives are going in the country. Finally, I believe these are the points that I would like to share. Some of the strategies that we must as a country should look at is prioritizing research in agriculture. In the morning, all our senior people, the director generals and others are talking that we work on silos, and that's where we have a problem. So I believe there must be, and I think there's some work started, but I believe there must be real big integrations between IITs and institutional ICR and maybe ICMR and CSIR, where we can build projects where you can prioritize crops and you can prioritize traits. You say that I want to develop this particular trait. So for example, in Rajasthan, we need pearl millets that flour can have a longer shelf life. It cannot be done by ICR alone. You need real harmony and you need real cohesive approach here. So I think, and you also need lot many of these techniques to be used. So collaborative approach is very important. And finally, of course, I have been working very hard to see that government, come out with some of the policy measures that allow India to be more protective in production of pulses and edible oil seeds. That's where we are facing huge problems. I have shared, sir, Dr. Chaudhary, I shared this particular slide with that G20 Circular Bioeconomy Group. And I looked at possibility of collaboration beyond institution in India with international communities. We looked at European Union as one of the partner, being a G20 member country, who can actually share expertise on food safety, food processing, Codex compliant MRLs, on pesticides, because they take a lot of these unilateral decisions that harm exports of agricultural commodity from India. And also the whole possibility of traceability and certifications. We looked at Argentina as a country that can actually collaborate with India on drought-tolerant HB4 wheat. So this is a big innovations which provide the tolerance to drought in water stress conditions. Brazil, of course, we are working very closely on cotton and mosaic virus resistance beans. US has big expertise in drought-tolerant again, and the fall armyworm resistance technologies in corn. Similarly for Canada and Indonesia and South Asian, with some of the South Asian countries. The concluding point that I would like to share with the student community, particularly who are into bioscience and bioengineering, I know that in IIT Jodhpur there has been so much focus on medical related sciences. But I believe that India as a country, we need you young generation people to put your brain into agriculture, because that's the beginning and end of what we are today. Thank you so much.
Thank you, Mr. Chaudhary. As we now come to the close of session 1, I invite Professor Mukherjee to have a brief discussion on the cohesive points of the sessions on sustainable solutions for One Health.
I think this and the previous session, between two sessions, we've had a real spectrum of disciplines which are needed to be taken together to be able to address, and everybody had a perspective which was very equally important, and everything was to do with the health of the entire ecosystem. And it was right from development is an inevitable thing. We cannot live without development, but development comes at a cost. And how do we kind of reduce the cost, or it comes at a cost of harming the environment or harming the people? So how do we regenerate the system? So it was really a very, very interesting set, and many things I also learned. But I'm sure there would be few questions. We've overshot the time into the lunch, so we might be able have to reduce the lunch time, but definitely we can take a few questions from the audience to any of the speakers who are here. Any questions? Nobody? Yeah, sure.
Sorry, guys. This is not a complaint, okay? This is really not a complaint. Everyone would be facing this problem. I face this quite often. We spend 50,000 rupees to buy a printer. Not a complaint, okay? Please, just for we buy a printer. And I spend 15,000 rupees just to buy a cartridge. And that cartridge, I can't refill. I can't refill it, that cartridge. So I have to buy again 15,000 of the cartridge. And a country like India, or maybe any developing countries except the big countries, I don't think this is something promote recyclability or circulability, because you're forcing the same customers to even buy more cartridges, and then you create all kind of environmental pollution. So how do you respond to it, and what can you do? This is a personal problem.
Well, I would have loved to take a personal problem offline, but given that it seems resonating with a lot. Okay, see, I think what we don't really look at is what's the total cost. You're looking at 15,000 rupees. But as a steward of my product and the responsibility I take of your health using my product, I can't let you refill from a source which is out of my control. Because there is an ambient air quality which is important, which gets released when using a cartridge. So what material goes into refilling, if I'm not aware of it, I can't let you do that. So it's a responsible move. Coming to the cost of it. So that was the total cost, the reason why we don't let you do that, and why we cancel your warranty when you actually refill from unsupervised or unauthorized sources. So thanks. In fact, it connects with One Health here. But at the same time, the costing of it, we are very mindful, because there is a lot goes into the due diligence of creating these products, these cartridges, sourcing of them, and the kind of material which goes into ensuring healthy ambient air quality for you when you do it. There's a cost aligned to it. But then the answer to reducing cost lies in recyclability, being able to reverse channelize these which are lying at your premises, which you actually throw away at times. So we put in structures, reverse channelize mechanism to be bringing it back so that it reduces those costs, because there's a material which goes into it. Not just that, what we're doing to reduce that cost. We, as I spoke about device as a service or a managed print solution, we also have something called as instant ink, which is an ink subscription model. So when, in fact, even before your ink dries up, there's a proactive insight which lets us know that there's an ink drying up, and we plan our logistic to provide you the ink. So that's a subscription model, which ensures that once it gets empty, it's not dumped, it comes back to us. But as I said, the cost would come down as we reach that economy of scale. When many more such organizations like us actually create an ecosystem of this reverse channelization of the end of use or end of life products or consumables. I hope it addresses to an extent. I know that I can lower the cost, but yes.
Any more questions or comments? Sir, you would like to comment on? Okay. Anybody else has? So I would request Professor Chaudhary if we could felicitate the speakers, and then we will move for lunch. We will reduce the lunch to half an hour, and then we will have some interesting panel discussions.
Actually, I want to ask a question.
Sure. Who is that? Where?
It's
Can you just come ahead and whom do you want to ask the question
the
to?
previous lecture about sustainable agriculture.
Okay. Make it brief, and Dr. Bhagirath, I would also request you to give a brief answer.
Sir, you have talked about sustainable agriculture. So India is moving towards organic farming, and like we have seen in case of Sri Lanka, they have moved toward the sustainable agriculture by adopting the organic farming. So what happened with their economy? And is it okay to go towards sustainable agriculture? And we have to talk about even the insecticide and pesticides we are using. But what Sri Lanka has faced, what about that thing?
I'm so happy that you know what happened in Sri Lanka. We don't prescribe that approach for the country. So India has a very unique way of using multiple technologies and production systems that are enabling us to produce amount of food that we are producing. So we use organic to fetch, to produce the food that fetch premium to the farmer, but it's being practiced by very few farmer who think they can supply that kind of material at a premium price to the consumer outside India or within India. Otherwise, we have different techniques like even regenerative agriculture. We got high intensive cultivation practices. We have precision agriculture. So India is not a country that is actually going the Sri Lankan model, and we use all the technologies so that we continue to produce sufficient food for people in the country. Thank you.
Thanks for the question. Thanks. So we would like to request the speakers of the previous session to kindly come on the stage, and we would like to felicitate you for your Dr. Bhagirath. Dr. Meenu, please come. Dr. Abhi, Mr. Hitesh. We should have a photo.
All together.
Okay. Yes.
Thank you.
Yes.
So much.
So we'll briefly break for lunch, and we'll be back after 30 minutes for our next session. Thank you. Good afternoon again, ladies and gentlemen. It is an honor to have several eminent personalities among us today. Moving on to our first panel discussion on human health and One Health, I now request Professor Shantanu Chaudhary, Director IIT Jodhpur, Dr. Abhimanyu Kumar, former Vice Chancellor Dr. Sarvapalli Radhakrishnan, Rajasthan Ayurveda University, Jodhpur, and Adjunct Professor at IIT Jodhpur, Dr. Bharat Kumar, Associate Professor, Department of General Medicine at AIIMS Jodhpur, Professor Mitali Mukherjee, Head, Department of Bioscience and Bioengineering, IIT Jodhpur, and Dr. Siddharth Srivastav, Professor of Practice at IIT Jodhpur, to kindly join us on the stage for the panel discussion. I now invite Professor Shushmita Jha to moderate this session. Thank you.
A very good afternoon to all of you and welcome back after lunch. Today, we are going to have a panel discussion on something which is very relevant from all of our discussions since today morning, which is human health and One Health. Now, as we start, I would like to start with a fact, which is the World Bank estimates that about $10 billion to $11 billion per year will be required to implement what we want for One Health globally. Of course, from all our discussions that we've had so far since morning, we know that it doesn't just require finances. It requires implementation, multilateral development of resources domestically as well as globally. So I would like to initiate our discussion with Professor Chaudhary, talking about the concept of building an ecosystem that supports digital health and sustainability. Sir.
Thank you, Shushmita, for giving me the opportunity to talk in the panel. Now, I think the key point here is sustainability. Now, what does sustainability mean? Sustainability is essentially making sure the things progress without having a bad effect on other things. I'm trying to put it very simply. So therefore, sustainability essentially would cover all aspects of human health. And obviously, One Health cannot be looked at in with a distinct lens, because human health is linked with One Health in a big way. So therefore, sustainability is where, say, for example, if I use chemical fertilizers for growth of plants, then consuming those plants, that is food crops, in the process, there can be impact in terms of the health to the human to a human being, and we have seen many such examples. Therefore, sustainability essentially means, therefore, the agriculture or the food production has to have the sustainability as a built-in character. Now, when it has a built-in character, then you have to look into what is the commercial implication of that sustainability. And therefore, it requires that point I was talking in the morning itself. you need to look at a systemic model. With reference to a systemic model, you have to ensure that when we talk about One Health, and the health is dependent on the environmental issues, and I'm not touching upon the disease part of it, which can be discussed by the other speakers. I'm talking in terms of simply well-being of human being by consumption of food. So food which is maybe fish, meat, crops, all of these has got now the chemicals into them. Now, therefore, they are not being grown in a sustainable fashion. So therefore, the whole issue is how do you conduct this agriculture, aquaculture, and this entire food production pipeline, the food chain of it, in a sustainable way. And what you need a business model for this sustainability. Because without that, you cannot have One Health issue in terms of sustainability with respect to food chain. I think food chain is something very, very critical in terms of ensuring that One Health and human health to be well protected. And in fact, if you see, there are lots of diseases which has come up, the cancers which has come up, they've all been attributed to variety of chemical presence in crops and other meat products or eggs, etc., etc. So until unless we come up with a strategy for that, without sacrificing the economic benefit to the growers and the people who are actually raising livestock, we cannot achieve sustainability. And this requires a kind of a model with the data playing a key role. Because until and unless you have data about the way the crops are being grown, the different climatic conditions, how that is being responded to, how human beings are consuming that food. So that whole pattern in terms of data is something very, very critical to actually build up the sustainability model. So a data-driven sustainability model with reference to the food and well-being of an individual is essential. That's my submission.
Thank you so much, sir. So while the concept of One Health is new to Western knowledge, we know that for many indigenous traditional knowledge systems across the world, it's a way of life for plants, humans, animals, and the ecosystem to be coexisting. So I would now like to invite Dr. Abhimanyu to discuss how traditional knowledge systems contribute to One Health.
Thank you, Professor Jha. In India, we believe in Vasudha Kutumbakam. And when we say the Vasudha, that is the planet Earth, and the Kutum means the family. So that means here the family is of human beings, animals, birds, microbes, planet, and so on. Just like in our own family, we are having, means the oldest to elder person, and everybody is having its own place. Father may be the senior one to earn, but the smallest kid is also having its role in the family that we all know. Similarly, when we think about a happy family, because in happy family, we know that everybody is happy, whether it may be the elder person or the younger person or the male or female. Similarly, with this Kutumb means the related to Vasudha means the planet Earth. Every member of the family must be happy. Happy means the status of means the optimum level of health, and of course happiness. Even plants, they also feel sadness or the happiness. Similarly, the microbes, because whatever we are, actually we are, normally we think that we are simply the reflection of our genes, but that is only 20%. 80% we are reflection of the environmental factors, the ecological aspect. So this concept of Indian knowledge system, we consider the holistic approach, considering all the creature, all the living structure as a family. So here the concept of One Health is already there. Then we talk about another thing, whatever means in Sanskrit, I think every somebody might have heard that what is means yat pinde tat brahmande, means pind means the body. Whatever physical body we are having, that is reflection of this universe. So that means here we are, the scope is a little bit more broader, and we are not simply thinking about the planet Earth, because this universe is affecting us in a great way. We know we can take example of even sun, how the impact of sun used to regulate our biological clock. And by the way, it regulates various hormones, and those hormones, they get affect our various system. Similarly, different microbes, we know the students of microbiology don't know the broader classification of microbes, the anaerobic, anaerobic, and the means what the impact of sun rays that used to happen with certain species. So ultimately, this is the example of only one planet, but a lot of things are happening in this universe. And how our body, when we say we are the replica of this universe, so how we are connecting with the universe. So in the morning session, this major, Lieutenant Major, he pointed about the 5 basic elements, means Panch Mahabhutas, or Akash, Vayu, Agni, Jal, and Prithvi. I think these are the connecting points. We see the space, what is happening there, that is affecting us a lot. The air, simply we think about the air pollution and what is in air, that affect the health of our, means not simply the human beings, it is affecting the health of all the creature in this universe. Then the Agni, means we can take example here, just like the global warming, how that is affecting us. Jal, mean the water, how this element is governing. I think in few lectures we heard about the water and what is the importance, how we can make change to have this availability, ensure the availability of potable water. And the earth, I think the planet on which we are happily living. So in this way, I think this approach is totally connected and well documented and well practiced. Another example I can give you here, the example of our own existence. Because in the beginning, I said about what we are, the reflection of this genes and the environment. So here the environment is not simply the outer environment. Means the, very rightly Professor Chaudhary said that the sustainability especially linked with the food, agriculture, food. So even when we are, we have taken birth, not physical birth outside, actually we used to take birth at the time of conception. Physically, we take birth, so we celebrate our birthday. But that is very crucial, the moment, and whatever environment, we always talk about the ecology and all these things. So that environment affects our, what we are. So I am coming to the concluding point. So just see that right now, everything is out of order. The environmental factor, of course, some genetic modifications are already there. Professor Mithali ji will tell about that. So what is happening means even since birth, the coming generation is having some problems, and they are taking birth with some problems, so that we are witnessing the increased incidences of developmental disorders. So we have to think in a more holistic way, and the principles are there, clues are there to do research, to apply them at community level. I think in the last, I will request to IIT, because I think it is a wonderful place and can take lead with the help of this Jaipur cluster, Jodhpur cluster, knowledge cluster, to select a village, develop a model, and try to implement it, because now it is high time to the people or experts belonging to different disciplines, they should sit together, just like since morning we are here. But ultimately, we have to convert it, or we have to show the rest of the world. So with these words, thank you very much.
Thank you so much, sir. Thank you. So I think what you've rightly summarized is that we cannot ignore the environment. And the past 3 years of us dealing with the COVID-19 pandemic was a painful reminder that ignoring the environment can come at dire consequences. In fact, this is the only true way that we can make the world safer for everybody, not just for human beings, for animals, for all beings, is a One Health approach. And for this to be truly effective, we have to have a discussion about the role of the environment, or the role of climate change that has played a role in this. So now I would like to ask our panelist, Dr. Bharat, to talk about climate change and its effect on emerging diseases.
Thank you, ma'am. Guys, we know that climate change in the form of deforestation, changes in the pattern of humidity, rainfall, warming ocean temperature, immigration, urbanization, can affect human health in a variety of ways. I will proceed with few examples. Warmer temperature can increase the growth and development of many organisms and can cause various diseases, especially diarrheal diseases like salmonellosis, giardiasis, cholera. So the climate can affect that. Then it is the floods. The climate can cause floods and drought at the same time. At one place it can cause drought, at other place it can cause flood. So increased flood create a safer environment for the organism to grow, and increased flood can be associated with increased diseases like fecal. If the flood water get contaminated with human or animal waste, then there is increased transmission of fecal diseases like hepatitis A. We in our campus at AIIMS Jodhpur, we had a small outbreak of hepatitis A a few months back. Then we have seen the ill effects of climate change in various times. Like in 1994, we have seen the outbreak of bubonic and pneumonic plague. That is also the indirect effect of climate change, because humidity, rainfall, and temperature, they play an important role in the both the transmitting agent, the fleas, and also the natural host, the rodents, rats. So both are affected by these climatic factors. So in this way, we can we should protect the climate, and we should, as a healthcare provider, we should be able to predict and for the climate change, we should do something. Thank you, ma'am.
Thank you, Dr. Bharat. Thank you. So, of course, with all of our discussion, we have reiterated the importance of the environment in One Health. I would now like to talk about the unique environment of the Thar and the opportunities that it provides, as well as the opportunities for us to talk about integrative approaches in human health in the context of the Thar. So I would like to now invite Dr. Mitali Mukherjee to talk about the human health and integrative approaches as part of the Thar Designs projects.
Yeah, this can be an example of one extreme environment. Of course, there are other extreme environments like high altitude or where there is a high burden of water, meaning just like this is dry. But any extreme environment would push all the living forms into one kind of an adaptation to which that allows them to thrive and survive. For example, in the desert environment, there is aridity, there is scanty vegetation, there is high intensity of UV because of reflection. All these things are very severe environmental onslaughts, and because of which animals survive by having genetic modifications in them, which allows them to survive. For example, they will store fat, like in the camel, to be able to melt that whenever food is scarce, or they would have high glucose in their blood because that allows them to have a good osmolarity to retain water. So those are the kind of adaptation which an animal has in an extreme environment. And if the environment changes, and if the genome of the animal is made to cope with those environments, then those very changes become maladaptive. So what is happening in world over in different deserts of the world also is that and the desert people also have native culture, food, which allows them to maximally adapt in that environment. Now, if we are not letting go of those kinds of culture which are good for that environment, and our genomes are wired for that environment, but the environment is changing, then our body will come out of sync of that environment, as a result of which we might be able to starting to transition to many different kinds of diseases. So this is what is being seen in the different parts of the world, either by a phenomena called rurbanization or by urbanization. So what we are doing in Thar is Thar as land to large number of natives, and we are looking at natives in the native area, what gives them more adaptive advantage. That would also be very, very important from biomarker perspective for understanding how people resist such condition. But it also would allow us to see what happens to them when they transition to the other environment. So that's the way we are dealing with it. Along with, we are of course introducing Ayurveda and all to be able to understand in a holistic and a perspective which Sir was just mentioning, that this is also a region which can provoke one of the doshas too much. So how one can have an optimum diet with their optimum genome to be able to calibrate themselves in this kind of an environment. Thank you.
So that very enlightening, ma'am. So that takes us to the perfect segue for our next section, which is when we talk about One Health and when we talk about human health in the context of One Health, we also talk about capacity building. And I would like Dr. Siddharth to actually talk about capacity building for technologies which are required for precision health, for looking at technologies that are unique to the individual.
Thank you for the question. So I'll share my experiential learning that I did from medical technologies program. And while listening to a lot of speakers here, I could definitely figure out that whatever we are getting out, as part of capacity building from MedTech, we can definitely overlay it on programs that may come under the larger umbrella of One Health. So this program was conceived by Professor Chaudhary and a small nucleus of faculty earlier. And there are 3 points, crucial points. One, that we build the diversity of students. So students which are having a varied experiential background and educational background. For example, in MedTech, you can find an electrical engineer brushing shoulders with a medical student. So in larger umbrella of One Health, you can easily see that happening, considering the diversity of people that you need in projects that were elaborated by Dr. Vanak or Professor Mukherjee. The second important point is identifying problem statements through immersion. It's very crucial. So in our program, students go to hospital, AIIMS Jodhpur. There can be very diverse scenarios in terms of One Health where the students could go. And they build the solutions in conjunction with the stakeholders. If you devise solutions like that, it is more likely that the stakeholder will adopt that solution, right, and will utilize it. And the third part is what a lot of speakers have earlier told also about the sustainability of solutions. Somebody has to pay for it. So we have linked those innovations to entrepreneurship. Now, entrepreneurship will also help, devise new business processes. So eventually making this, converting these technologies or taking the technologies to the stakeholders or to the beneficiaries, and that becomes a reality. So using these 3 principles, three pillars, a program in One Health can definitely generate the capacity where, you develop people who can solve problems in One Health. Thank you.
Thank you so much. So I think now we'll have an open question for the panel, and that is, what do you think are the gaps and opportunities that are available in the One Health as well as in the context of human health that are available that we should be addressing, especially in the context of, say, community engagement or digital health or any of the topics that we've talked about?
See, I think there is open space. In fact, the different aspects of One Health and One Health with digital health, there hasn't been any specific programs and activities targeted towards entrepreneurship and innovation. It's an open, that's why if you look into it, it requires completely multidisciplinary knowledge. It requires ecosystem knowledge. It requires the animal kingdom, understanding of the animal, that is zoology. It requires the knowledge about the plant botany. It requires knowledge about the human systems, as well as it requires knowledge of various aspects of engineering and data science, AI, etc. It's not that any one group, any one individual will have all these capacities. But it's a huge opportunity to actually creating business, and not only business, creating technologies or the solutions which can address the problems of One Health needs a multidisciplinary approach. And with a multidisciplinary approach, if we can think of programs with different institutions coming together, which is actually the cluster model is all about, then definitely there can be a progress in this space. What we have found across the country today is there's a group who works in agriculture ICR. There is a group which works in ICMR. There is some other group which works on basically ecology, the geographical part of it. But all of them need to talk to each other to get a comprehensive solution. And that's what is missing in the Indian context today.
I think here is the crisis. That's why we are discussing about the One Health. But I think there is a great opportunity behind this. And globally, I think on this aspect, a lot of people belonging to different disciplines, they have done a lot of work, including in India. So here the opportunity is there that if someone or a group try to collect the information and develop the model, and that model can be, I think, a better solution for this particular problem. So I think this is a good opportunity that I think the students or anyone can avail. Thank you.
From my perspective, One Health is something which cannot be solved by a westernized approach to the problem. This is something which has to be tuned to a local ecosystem. So the beautiful part about India is its diversity of culture, diversity of population, diversity of traditional knowledge. And there's a wealth of it by which how Indians have kept themselves healthy. But the major gaps are that we do not cross-talk. And like Professor Chaudhary said, that if we can actually get so the diversity also creates problems because we are too diverse, so we don't come to common talking points. But what we need to do is we need to identify some unique clusters of diversity and develop models for One Health framework. If we develop these kinds of frameworks even across 2 or 3 diverse groups, it might be portable to a large number of not only Indian population, but also world population, because all the world genetic diversity is in India. So I think we have a very good strategic advantage, and advantage also in our traditional knowledge, which is very rich resource, which only we can tap to at the maximal. So there are huge number of opportunities. It actually needs a mindset change and a transdisciplinary outlook. So that's why.
I have nothing more to add. I would just voice what Professor Mukherjee said. I think entrepreneurship and innovation could be a big answer. As she said, there is a lot of opportunity there. We need people who can exploit it.
I also fully agree with Mithali madam. We should not copy the model from the Western because India is having a unique situation. We should combine the modern medicine with the traditional medicine, and it should be fully supported by the technology, and then only we can move forward. Because in health care system, we need technology a lot. We are greatly lagging behind from the other countries in terms of technology, especially. So I think we should move forward together. That will be a better approach. Thank you.
So that brings us to the end of our panel discussion. I would like to thank our panel members who've enlightened us with their views on this issue of human health and One Health. And I could say that as a summary statement, what we can understand that the only approach that we have moving forward is an integrative, multidisciplinary approach where all stakeholders are equally participative. That is the only way forward. Thank you so much, and thank you so much for your participation.
I thank Professor Jha and all our panel members for this panel discussion. We will now commence our next session on plant and environmental health. Our first speaker for this session is Dr. Shankar Manoharan, who is an enthusiast of microbes and their intricate workings, and he heads the Microbial Physiology Group at IIT Jodhpur's Department of Bioscience and Bioengineering. With a genomics master's and a microbiology PhD, he furthered his expertise to investigate virulence regulation in Klebsiella pneumoniae and to explore the interplay of environmental cues, on human gut microbiota and its impact on host physiology. I now invite Dr. Manoharan to talk on biocrust, ecosystem engineering in the desert.
Thank you, Sarmishta, and good afternoon, ladies and gentlemen. First off, I'd like to thank the Institute for this opportunity to present our work in such an august gathering. First off, I'd like to tell you what we do and why I'm here. So our group looks at microbes, from individual microbes as well as their communities, how they function, and how that's relevant to human health and environmental health. So on one side, we are looking at how virulence is regulated in the hospital-associated pathogen Klebsiella pneumoniae. And we are also interested in looking at some uncharacterized microbial communities in the Thar Desert, which are biological soil crusts. So let me first throw a question. What do you consider as a wasteland? So this is a infographic from the Wasteland Atlas of India, which says that in 2008 to 9, from 2008 to 9 to 2015 to 16, wasteland area has been decreased by around 4,800 square kilometers. Is that something that we need to be proud about? So these are typically land with dense shrub, open shrub, and desertic sands, which are semi-stable, right? So the current understanding is that if nothing grows, it's waste, right? Perhaps it hasn't occurred to us that biodiversity doesn't just exist in what we can see, right? So for example, these grasslands are actually home to endemic species of the desert, like the bustard. And of course, there are endemic grasses which grow only in these areas. So perhaps could there be some kind of ecological design into leaving these lands barren? That's the question that we started off with. And interestingly, we came across a very unique microbial community in the desert, which is the biological soil crust. So you can think of the biological soil crust as a functional skin of the soil, which is formed in the top few centimeters of soil by the coordinated action of several microbes, predominantly cyanobacteria, algae, microfungi, lichens, bacteria, and bryophytes. So the soil particles are aggregated together through the presence and the activity of these microbes. And just imagine cyanobacteria out in the desert in an arid zone. Who would have thought? That was our first reaction when we first heard about it. And then we learned that the crust has a microbial community that has adapted perfectly for survival under arid zone ecosystems. Now, how does it do that? We know that the desert is a very resource-constrained environment, and typically resource-constrained environments will push microbes to cooperate because individual survival is not possible. There's extremely high levels of radiation, so you need some kind of protection from UV, and there will be prolonged spells of aridity, which might mean that you need some kind of protection against desiccation, high temperatures, of course, and increased salinity in the desert, and variable pH across the soils. So the entire community must adapt to survive in each of these functions if it has to make a living in the desert. So this is an exciting community, of course. It's interesting, but you might ask me, why do I care? Why do I care about a soil microbe that lives in the desert? Turns out, these communities perform key ecosystem functions that are required for soil formation, soil development, which will ultimately lead to better growth of vascular plants in the desert. So if you think about it, the cyanobacteria in the crust can fix both nitrogen and carbon through, of course, photosynthesis and nitrogen fixation genes. They participate in biogeochemical cycling, in the process of which they form the soil itself. The cyanobacteria also secrete these polysaccharides, which help kind of stabilize the soil and prevent erosion, and also trap dust, which also acts as an additional source of nutrition. So in fact, biocrusts have been thought of the predominant carbon sinks in the desert next to vascular plants. So if you look at the crust cover around the world, there have been several studies which have looked at biocrusts across the world, specifically in arid zone ecosystems. As you can see from this map, which is from a very recent review on biocrusts, there are very few studies from India, and even these studies have not been conducted in India's arid zones. So when we stepped out in the desert and we found that there are plenty of biocrusts all over the place, including in IITJ's own campus. So such an important ecological component, which covers around 12% of the world's terrestrial surface, is today threatened by our own activities. Such an important ecological engineer in the sense that if the crust gets disturbed, there's less amount of carbon that's going to get fixed. There's less amount of nitrogen that's going to be available for other plants and other species to grow in the soil. So from that point of view, even if we go by the 12% figure, in about 2070, even if we stick to our most stringent climate plan, which is RCP 2.6, which plans to cut all emissions in 100 years, the crust cover is going to be about 70% reduced. So we're already headed into a problem in the sense that we're going to be losing these microbial communities of the desert, which are shaping up the desert ecosystem. So they are additionally also threatened by uninformed greening, agriculture, and other human activities such as mining, tourism, etc. So when we started getting into this problem, we wondered, how do these crusts form? It's actually a very interesting and elegant process that happens. The pioneer species that gets onto the soil is actually cyanobacteria. And these are not normal cyanobacteria, these are actually filamentous cyanobacteria. So when they hit the soil, they start photosynthesizing and making these polysaccharides, and they slide in and out of the soil. Why? Because there's too much UV on top, so they need to go burrow under the soil to protect themselves from the UV. And when there is water or a hydration event, they would move up through these channels of polysaccharides and photosynthesize and then rapidly go back inside. So this process of moving up and down all the time, secreting polysaccharides, actually makes an underground network of polysaccharide fibers, which is the initial step of biocrust formation, which kind of stabilizes the soil. So the species that's involved is actually Microcoelius vaginatus, which this is, of course, information from what's available in American deserts. There's no data available for the Thar Desert itself. So what you're seeing on the right is actually the series of events that would happen. You would have bare soil in the beginning. Within a few months, slowly the soil would first get stabilized. Then over time, you would start to see pigmentation, which is actually the overgrowth of these cyanobacteria. So if you think about what influences biocrusts, these could possibly be, some of them are quite smooth, some of them are rugose, and the desert environmental conditions are what dictate how the crust structure develops. In the Thar Desert, we largely see just smooth and rugose crusts, which are about 3 centimeters, typically characteristic of the hot deserts of the world. So we ended up finding biocrusts in and around Jodhpur. So we decided to sample 3 main areas, one in the slightly wetter regions of the Thar and 2 in the more arid parts of the Thar Desert. So we started off with Beri Ganga in Mandor, which is very close by. This is what the landscape looks like. And what you're seeing over here is the controlled soil with no crusting. And these are the biocrusts, which kind of cover entire stretches of landscapes. So you see that the morphotypes are largely similar in the top 4 panels, and the bottom panel also has moss in addition to the cyanobacteria. We also went to Jaisalmer to pick up some crusts, given its aridity. This is what the landscape looks like. So this is the dry part of the Thar, and it's quite obvious that the control soils, which are completely bare, and you can see the cyanobacterial pigmentation in the crusts, which are growing on a mound of haloxylon plants. It's noteworthy here that the haloxylon is a salt-loving plant species which grows in the desert, and we picked up these crusts from the mounds of these haloxylon plants. The most interesting part of the sampling expedition was finding crusts on a rocky outgrowth right in the middle of the Akal Fossil Park in Jaisalmer. So this is what the landscape looks like. It's quite rocky outgrowths, volcanic rock jutting out of the landscape. And in between the crevices of the rocks, there's densely formed crust. We had to chisel it away to collect some of the sample. You can see that it's completely blackened. The surface is blackened, but when you disturb it, you can actually see that the surface is just black, but the inside is not black. So it's not the rock that's black, it's actually something that's growing on the rock. So we have sampled all of these, and I just wanted to show you some examples of biocrusts within the campus itself. If you go near the temple that's around the end of the campus, you'll find plenty of biocrusts. So the moment we brought them back to the lab, we did some sanity checks to check if there were really cyanobacterial species in the crust with some microscopy. And bingo, we found quite some sheathed cyanobacteria, typical characteristics of biocrusts. And then Lavanya, Shubham, and Neeraj. Lavanya is a former PhD student, and Shubham is an MTech, and Neeraj is a BTech student, have undertook 2 major approaches. One approach is to use the metagenomics approach to look at the entire microbial populations that are in a crust sample. And of course, there is also a culture-based approach that we undertook where we grew microbes from these biocrusts in the lab in different culture media to bioprospect microbes from biocrusts. So this is a small portion of the repository that we have established from biocrusts. We were able to isolate cyanobacteria which are filamentous and growing in clumps, as well as unicellular cyanobacteria. We were also able to see that biocrust microbes are producing antimicrobial substances, which might be of value to the industry. But wait, the catch here is if you attempt a culture-based approach, you're essentially sampling just 1% of the actual diversity. So what I'm showing you here is a tree of life. And just for perspective, this is where we are. This tiny little branch is eukaryotes and what you can actually see all around you. This is the rest of the unseen world, the world of the microbes, dominated by such minuscule organisms yet performing such critical functions. So how do we access the diversity of the microbes? We turn to shotgun metagenomics, which is enabled by nanopore sequencing. So the idea is to extract DNA directly from the soil sample, biocrust sample, fragment the DNA, and then read it using a DNA sequencer. And then from the genomes, try and understand what the microbial community is and what functions these microbes are doing there in the environment. So we use nanopore sequencing technology in our lab, in which the DNA directly passes through a proteinaceous nanopore immobilized on a membrane, and the changes in the electrical signal are read and transcribed into DNA sequence. So it's a fairly simple process which has democratized sequencing in a big way. So what's in a crust? What do we see? We see that predominantly it's bacteria with a little bit of archaea, eukaryota, and there are viruses as well. So that's the advantage of shotgun metagenomics. You're not targeting just one particular domain. You can actually get a picture of what all is in a crust. So if you look at it, predominantly it's proteobacteria with a little bit of actinobacteria, as well as cyanobacteria, which is what is, of course, important in the formation of a crust. Moving forward, if you look at the species of cyanobacteria that are present in the crust, what is evident is it looks like the amount of moisture that's present in the particular environment. It's consciously that we picked up crust samples from the wet, a semi-dry, and a dry environment. What you see here on this far corner is basically the Akal rocky soil crust, which has a distinct microbial community. And this is the one in Kanoi, which is, of course, the grainy soil of the desert. They are very well separated from their respective control soil samples. And we see a group of samples here, all of which were collected from wet Thar, Beriganga, and one wet area in Akal. We also see that within the cyanobacterial population, the microcollias that we were talking about earlier, which is the pioneer species, seems to be quite well distributed, but it largely seems to be restricted only to the wet areas of the Thar. So that means that our biocrusts that are forming in the Thar are not really similar to biocrusts that are seen in other deserts. We are also seeing that some species like Cytonema species and Allocoleopsis, which are enriched in crust samples, appear to be specific to this local ecoregion. I want to talk a little bit more about the Akal rocky biocrust, because it's basically life on nothing, right? There's very little nutrients available. So we see that this particular crust, the cyanobacterial populations are largely Cytonema species and Crucoccidiopsis species, both of which are pigment producers, heavy pigment producers in the sense that it offers them protection from the UV, and they can actively photosynthesize as well as tolerate extremely high amounts of radiation as well as desiccation. In fact, this particular species, the Crucoccidiopsis, has been tested on the International Space Station as an astrobiology experiment to see how long it can survive in space, and has also been proposed to be used in the terraformation of Mars. So where to now? So we would like to further understand how biocrusts develop in these areas, and would also like to use remote sensing and other approaches to map the spread of biocrusts in the Thar Desert, and try and guide policy on how biocrusts as a resource have to be conserved, as well as try and restore the biocrusts which are damaged by anthropological activities using the biocrust biorepository that we have constructed in the laboratory. So with that, I would like to thank all of you for your kind attention. Thank you very much.
Thank you, Dr. Manoharan. Our next speaker, Dr. Chandan Roy, Head Genetics and Plant Breeding at Agricultural University, Jodhpur, is an experienced agricultural scientist with 11 years in the field and holds expertise in developing stress-tolerant cauliflower and wheat varieties. He has also served on expert committees and received training from International Maize and Wheat Improvement Center, Mexico. I now invite Dr. Roy to speak on marker-assisted breeding for disease resistance in plants.
Thank you. Next, you can just click the mouse. Next. Okay. our respected director, IIT Jodhpur, Professor Mukherjee, Head Bioscience and Bioengineering Department, IIT Jodhpur, all the respected speakers, guests, and participants. You know, plants do suffer from the diseases like us, and it causes a serious health concern for the plants and loss in the production in terms of quantity as well as quality. And today's topic is how marker-resisted breeding is useful for the development of resistant varieties. So I'll start with this slide. This slide depicts the present agricultural scenario in India. The graph indicates the food production scenario right from 1950 when since from independence to the present day, from 50 million ton food production to 315 million tons. It's a huge achievement. And India has become from food deficient to we are now food sufficient, as well as we are already exporting different foods, food products and commodities to the other countries. It is a more than 6 times jump in the food production. And not only in food production, we are also having a significant achievement like 13 times increase in the horticulture produce that comes under fruits, vegetables and all. Oilseeds, that is again 6 times jumps, pulses 3 times jump. Milk production, we are the largest producer in the world. Milk as well as meat, livestock, eggs, everywhere. India has achieved a significant achievement. Although we are still lacking some edible oil and pulses, still we are importing from outside. But this is a tremendous achievement in the field of agriculture. So as you know, the great achievement comes with the biggest challenges. So there are several challenges in the previous lecture. Dr. Bhagirath also had discussed, but climate change is one of the serious challenges that is present in our doorstep. We need to really think of it, because all the predictions says that the climate change will directly impact the agriculture production and our food security. So it will change the microclimate as well as the macroclimatic factors that will directly or indirectly lead to the agriculture production, quality as well as quantity. And most importantly, it will also change the pest and pathogen dynamics. And you know, present day, in the whole world, if you see the record of FAO, more than 3.5 million tons of pesticide, I'm talking only about the pesticide, are being used in the agricultural field. In India also, we are not less behind. More than 61,000 metric ton of pesticides we are using annually. And these pesticide residues, they are contaminating the groundwater, they're contaminating the soil, environment, our foods, products, as well as our health. So developing resistance varieties can be one of the solution for the farmers to reduce the pesticide use, reduce the production costs, also increasing the profitability of the farmers and bringing the sustainability in the agriculture. How molecular markers or marker-assisted breeding is useful. There are several use of molecular markers, but to discuss some of these, like for early detection of the plants, even before the onset of the disease, molecular marker can help us to select at the seedling stage whether the plant will be resistant or it will be susceptible. Dealing with the quantitative traits is one of the biggest challenge in the breeding, because in case of quantitative traits, we are not able to differentiate the resistance as well as the susceptible alleles by looking at the phenotype, because there will be minor difference in the phenotype. So molecular markers helps us to select the plants with the positive allele or the resistance allele. Again, when we need to pyramid the multiple genes of the same disease or different diseases, in that case, molecular marker is very much useful. And speedy record of the genome. If you want to improve a particular variety, and by keeping all the quality of the variety as such, we need to recover the background genome. In that case, molecular marker is very useful. This one slide that I'll show how marker is working. The upper two picture, that is picture A and picture B, there is infected plant with leaf rust. That is wheat plant. The variety is BRW934. And the below picture, that is Chiria 3, that is resistant to the leaf rust disease, but it is carrying one of the resistant gene, that is LR34. So if you look at the picture D, where leaves are shown, Chiria 3, the leaves of Chiria 3 is clean, there is no disease, but its tip is necrotic, it's dried up. And the susceptible variety, the whole leaf is already infected. Now, genetic study shows that the gene for tip necrosis is present in close proximity with the LR34 gene. So now in this case, tip necrosis can be used as a marker for LR34 gene. Similarly, DNA-based marker, this is the agarogel product of one of the markers, that is CSLB34. CSLB34 says that the shorter band are in close proximity with the resistant allele of LR34, and the larger band is associated with the susceptible allele. And these are the band of the hybrid products. So by using this marker, we have transferred the LR34 gene to the susceptible variety BRW934 from Chiria 3 to BRW934. And you can see the two plants, that is progeny of BRW934 that is carrying LR34 gene, showing resistance reaction, and without LR34 gene, it is susceptible reaction. The presence of LR34 is reducing also the disease severity significantly. This is another case, and wheat blast disease. There is very recent disease identified in first time in South America, in Bolivia. Is one of the most dangerous diseases in the wheat because it can infect the whole plant. Once it affects the ear, where the grains are formed, it's called ear. Once it affects the ear does not form any seed grain. It will be totally chaffy. And under favorable climatic condition, the disease causes 100% yield loss. So really this disease is very dangerous. And from Bolivia, it has transmitted to the adjoining countries like Brazil, like Paraguay, Uruguay, even Argentina, and it causes a huge loss in the wheat production. Now, what is our concern? In the year 2016, the disease appeared in Bangladesh. Now, that causes a serious concern for us because the whole central India and parts of the Pakistan, there is favorable condition for the disease. And government of India has taken several steps, like declaring wheat holiday in the adjoining districts of Bangladesh, where in the West Bengal states, there will be no cultivation of wheat for 5 kilometers border area, strict quarantine measures, and also it shows that the color indicates the migration of the disease from different districts year by year, from 2016 to 2021. So what we did a study of Indian wheat germplasm by screening them in Bolivia, and we found that some of the genotypes are resistant, and we tried to map the resistant locus that is present on the terminal end of the 2A chromosome, and it is a translocated segment, it is known as 2NS. And this variety we have developed, that is BRW3806, it is highly resistant to the wheat blast disease. And it has observed that the presence of 2NS can significantly reduce again the blast index. But unfortunately, most of the cases, this is the only resistance source found for the 2NS, either from Indian germplasm, from Bangladesh germplasm, even from Chinese germplasm, Mexico, South America, even US germplasm. This is the only locus that is showing the highly resistance to the 2NS. So there are a few cases where marker selection cannot directly useful for transferring the locus or gene. This is one of the typical case for spot blotch disease. If you see the chromosomes, this indicating the different locus or the markers that is showing the resistance to the spot blotch, and the locus as well the QTL, they are spread throughout the genome, and none of the QTLs are major QTLs. So in case of minor QTLs, it's very difficult to transfer through the mass, and in that case, genomic selection can be very useful. Where phenotyping is also very difficult, where markers are present throughout the genome. So genomic selection can play a very significant role in that case for developing of varieties. So we did a model study for spot blotch, and we observed that genomic selection, the genomic prediction accuracy 0.53 across the panel where there is no relatives, and within panel where there is some genetic relationship between training as well as the breeding population, the genomic prediction accuracy of 0.4. But this is not so high for mass till date. But one important thing but the red dot indicates that in most of the cases, more than 90% of the lines that are susceptible to the disease, we can reject it before testing to the field. So it will be very significant achievement by rejecting the susceptible lines from testing, evaluating to the fields, and it will reduce the time as well as the cost. So these are the few other examples. In case rice, peanut, wheat, and palm millet and maize, though there are several others, where marker-restricted breeding was used for developing resistant varieties. And then I would like to say, most of the cases marker-restricted breeding was followed in major crops, where more number of molecular markers are available, where fundings are available, where research groups are available. But we need to really look into the crops which are locally available, but very high value crops are very important, like fruits, like vegetables, like spices. We need to think that how these crops can be come into the marker-restricted selection. And at the end, I would like to thank to the organizer for giving me the opportunity to share my thoughts here. Thank you very much.
Thank you, Dr. Roy. Our next speaker, Dr. Ayan Shadhuka, an assistant professor in the Department of Bioscience and Bioengineering at IIT Jodhpur, specializes in Arabidopsis population genetics and plant abiotic stress tolerance. His academic achievements include a PhD from IIT Guwahati and research tenures at Jodhpur University, Japan, and University of Florida, USA. I now invite Dr. Shadhuka to speak on bioprospecting genes for abiotic stress tolerance and memory.
So how I change slide? Left click. Okay. Go left. Respected Director, sir, Head of the Department, Professor Toteja, dignitaries, my colleagues and students. So I am going to talk about abiotic stress management. So this is a part of the One Health. So my friend, Dr. Chandan Roy, talked about the biotic stress. So I am Dr. Ayan Shadhuka. I work in plant population genetics. I use Arabidopsis model and I look into the plant cell at the molecular level, what's going on. And also we study about the molecular markers in Arabidopsis and how that, and genome-wide association study, how that can lead to discovery of genes for abiotic stress tolerance. So this already have been talked about. We are just crossed China and the most populous country in the world. And there is this problem of food security. So apart from biotic stress, the abiotic stress or the environmental factors like drought is one of the major constraints of agricultural productivity. And we are rapidly progressing towards land degradation and desertification. So among other measures, the improvement of plant productivity under abiotic stress, that is more crop per drop, is the global agenda. So we have to understand the molecular mechanisms of plant abiotic stress tolerance to develop varieties which are more robust. So this drought, UV, salt, heat, cold, this kind of abiotic stresses are complex quantitative traits involving many genes and complex gene networks. So the signal is usually perceived by certain ion channels and transmitted via secondary signaling molecules to transcription factors. So there are actually stress-specific transcription factors. For example, the well-studied dehydration responsive element binding protein, DREBs, so which ultimately bind to the promoters of certain downstream genes, which lead to ion homeostasis scavenging of ROS, protection of the cell structure, etc., under abiotic stress. Now there is a catch. The single drought stresses are very rare in the field. They actually come after intermittent water recovery intervals. So while a severe drought may be detrimental for the plant, mild drought can be tolerated. And in the next drought episode, the plant will present a more robust response. So there are two types. One is the transcriptional or short-term memory. Another is the transgenerational memory, which can even be transmitted to the next generation. So we are beginning to look at the molecular mechanisms of memory. So apart from being sessile, plants also have this capacity of memorizing the stress. So we can see here in the figure, right-hand side. So there is the watered interval followed by a first drought, and then the plant receives some rainfall, for example. In the second drought, you can see some genes are progressively upregulated, while some genes are downregulated. So here you can see this kind of transcriptional memory in case of this ABA and J biosynthesis genes. So these are the drought-specific hormones. So their biosynthesis involves this transcriptional memory. So we can see in the green part of the figure the stomata. So when there is a fast drought, the plant will close the stomata rapidly, but it will memorize that response. And when in the next recovery interval, the plant will not open the stomata fully. It will remain partially open. So this is a strategy so that it can very quickly close it in the next drought. So these are the one of the newest findings. We are just beginning to appreciate this memory behavior in plants. And these are very important in development of stress-resistant varieties which can actually memorize the stresses. So we are in the vicinity of the Thar desert. So the wet part of the Thar, so IIT Jodhpur. So we have different abiotic stress like high pH in the soil, high levels of fluoride, high temperatures, UV radiation, and nutrient deficiency stresses apart from drought. So the question is, what is new in these extremophile plants? So we are surrounded by plants which are known as extremophiles. They are highly adapted to these environments. So not much is known about these extremophile plants. What's different in their molecular physiology? So we can see one plant, this is a date palm. So while other plants have stomata, here we can see these plants have stomatal chimneys. So large waxy deposits around the stomatal guard cells. So we don't know what is the purpose. And also this kind of stomatal closure, the molecular pathways like mediated by the ABA and these kinases and the slack chloride channels, which help in the maintenance of turgidity of the guard cells. So here has been found that in the desert species, there is a much more accelerated stomatal closure. So why are these desert plants important? So these plants, desert plants are mostly medicinal plants. We know they have a lot of secondary metabolites. These are actually designed for them to survive these stresses. While we uptake them as the medicines, they help us fighting our ROS and curing our diseases. So these desert plants will contain tolerance genes responsible for these abiotic stresses and can be the sources of for bioprospecting. So they are the sources of novel mechanisms for integration into the cultivated plants by means of biotechnology. So these desert plants have these two methods. One is the expansion of the repeats or copy number of the tolerance genes. Another is the novel gene sequences, which have more tolerance and memory. So for example, we can look at the recently sequenced Prosopis cinerea or Khejri genome. So that has expansion of this disease resistance genes and terpenoid, this metabolism. So these genes help them to survive under these stress conditions. So here we are in the IIT Jodhpur campus. Grossly, the plants can be divided into this drought-tolerant and drought-avoiding species. So drought-tolerant survive throughout the dry period, but drought-avoiding species complete their life cycle within the rainy season and their seeds survive in the dry period. So those are the many kinds of grasses and other plants in the campus. So one important aspect is that the tolerant plants, they belong to the leguminous family. So this origin and evolution of legumes has always been an enigma. So after the supercontinent, the Gondwana land actually separated. So we can see here the two types of, one is invasive Prosopis juliflora, and another native Khejri or Prosopis cineraria. So we can see this polyploidy. The polyploidy plays an important role in the evolution of legumes. And the legumes are, of course, the most tolerant plants. So we can see the polyploidy, or 2n equal to 56 in the juliflora, so in the invasive plant. So you can see in the map that this invasive plant is actually native in the South America. So some Maharaja actually broadcasted the seeds here very recently in the 1960s. So the common ancestor of these two. So we can see in the evolutionary tree, recently the chloroplast genomes of both these species were sequenced, and we can see the juliflora and the cineraria are most close together in the phylogenetic tree of life. So when the supercontinent, so we know that South America, Africa, and Indian landmass were actually part of the same supercontinent, Gondwana land. So after that, there was two mass extinction events. So the early ancestor of these two prosopis actually separated during that time. And we can see the cineraria belt stretches from the Arabian countries into the India, Western India. And this juliflora was again reintroduced as an invasive species. There is a question why this invasive species outgrow and this prosopis. So we can, one study has been done. Here it has been found that this soil microbiota, so that is called rhizosphere, the soil around the roots. So they, in case of juliflora, the invasive one, the beneficial actinobacteria in the rhizosphere of those plants actually produce some specific antibiotics. They kill the plant pathogens. So more than what the beneficial microbes in the Khejri or native cineraria cannot do. This is one of the reasons why invasive prosopis will outgrow the native prosopis. So I am grateful to the Institute and the departmental head for giving me space, and we have established the state-of-the-art plant molecular biology lab for the first time in the bioscience department. And we work on this model Arabidopsis. So Arabidopsis is a very small plant. It's like the mouse of the plant biology. So it has a very short life cycle. It is self-pollinated, and there are a lot of data. So we have this Arabidopsis from around the world, different ecotypes or strains, as well as several knockout lines collection. And we have around 1 crore, more than that, SNP information, the genotyped data. So this Arabidopsis actually reflects the higher plants, so we can do a lot of fundamental research in Arabidopsis, so which can be translated later into the field crops for higher yield and stress tolerance. So we use GWAS, or genome-wide association study, as a forward genetic tool for gene discovery. So I have collected these Arabidopsis strains from across the world. We can see in the map, including several other deserts, including sub-Saharan Africa and cold deserts of Central Asia. So each of these Arabidopsis are being grown in the lab, and we can know from their genotype, we can map the causative genes for many different kinds of abiotic stresses, which include drought, fluoride, high pH, and nutrient deficiency. So here is one example. We are using this hydroponic platform to phenotype a large number of Arabidopsis ecotypes in the lab. So this is grown under PEG, which mimics the drought stress in the laboratory. And we use this computer to phenotype the primary root length. And we can see it is a normal distribution, like a quantitative trait. This involves a mapping of large number of genes. So we have actually mapped many known as well as novel genes for drought tolerance. So we are also looking into the genetic architecture of drought memory by these complex experiments involving GWAS. So while we use a single GWAS as a control and many reiterated drought exposures for identifying the genetic architecture of drought memory, we identify the AP alleles through bisulfite sequencing and overlap this data with the genotypic variation. So we are also bioprospecting several plant growth promoting bacteria from the Thar. So Thar desert is a huge resource, so which can have direct applications in arid agriculture. So we have actually from the rhizospheres of several desert shrubs. One is Tephrosia sarfunkha, plant described in Ayurveda. So we have isolated several strains. So you can see in the figure that a plant growth is drastically improved by this plant growth promoting bacteria. We have actually gone to the extent of sequencing the entire genome of this bacteria. And we can see even in the pig, the drought stress, there is a drastic improvement in the root and shoot growth. So this genome contains several genes which have these plant growth promoting traits. For example, auxin production, it can produce auxins which lead to the longer root, as well as several genes for nutrient solubilizations from these nutrient poor soils. So another approach, so this is the culturable approach, what Professor Shankar talked, but there is another approach like this functional metagenomics, where we clone directly the genes and genetic cassettes from the soil samples from the rhizosphere and use for development of stress-tolerant plants. So we are also bioprospecting these drought resistance genes from the Khejri, the Prosopis cineraria. We have grown these seedlings in the lab and mimicked the drought stress, and we have done the whole genome like transcriptome sequencing, and we have identified the genes for drought resistance. So apart from the copy number expansion, the very least studied part is the protein structures of this from this Prosopis cineraria. We are looking into that, and apparently the proteins are more robust and stable than the non-desert plants. So the next step is cloning into the binary vectors and putting into this Arabidopsis model for functional studies whether it can improve drought tolerance, so that this can lead to novel candidates for crop improvement using biotechnology. Thank you very much for your attention.
Thank you, Dr. Shadukha. Our next speaker, Dr. Ritu Kapoor, is the head and associate professor of the PG Department of Agat Tantra at DR SRRAU, Jodhpur, with qualifications including BAMS, DRCH, and MD in Dravya Guna. She also holds a PG diploma in criminology and forensic science. Dr. Kapoor has authored numerous books, research papers, and articles in Ayurvedic and traditional medicine. She has actively contributed to multiple projects, presented at more than 20 conferences, and organized numerous treatment camps, that is Chikitsa Nidan, across the country. I invite Dr. Kapoor to speak on impact of environmental changes on medicinal properties of plants and strategies to tackle the outcome.
A very good afternoon to all of you. Before I start my presentation, I want to pay my regards to Professor Shatnuji sir and our ex-VC sir, Professor Abhimanyu Kumarji sir. Now, my presentation is on impact of environmental changes on medicinal properties of the plants and strategies to tackle the outcome. Ayurveda is the immortal science and believes in the Ayurveda is the mortal science and believes in the fact that swastha swas rakshanam aturas vikar prashmancha. It means that Ayurveda believes that we have to treat the diseases as well as Ayurveda aims to maintain the health of the person. Let me tell you something about the from the modern perspective so that you can easily correlate it with the Ayurveda. India is the home of rich biodiversity, as you all know about it, and is the major contributing nation for about 3,000 years old. The inner system of healing is the Ayurveda, and the lack of the rainfall, increase in the temperature, elevation and CO2 level, changes in the soil properties, etc., have caused severe changes in the biodiversity of the plants and the animals. Many of the drugs derived from such medicinal plants are in practice in Ayurveda since ancient times. The global Ayurveda market. The global Ayurveda market was estimated to be about $4.5 billion in 2019, and it's expected to reach the $14.9 billion by 2026. The factors favoring the global Ayurveda market is are the wide knowledge base, modern adaptation to traditional procedures, the trust arising out of the centuries of the uses, advanced educational system, and the large institutional basis. Niche segments of the Ayurveda segment are nutraceuticals and the personal care products. Domestic market for the Ayurveda in India is about $4 billion and this is roughly 89% of the total global market, which is supported by the large pool of trained manpower and patronized by a large and growing middle class. The market is expected to grow at the compound annual growth rate of 16 in the coming years. It means that the market is continuously increasing from the very long time. The top exporters destinations we get that the market of that the Ayurvedic products or the medicines of the Ayurveda are in demand. The demand of all those medicines are being increased nowadays, and the top export destinations from the India are USA, Nepal, UAE, Netherlands, Italy, Russia, and France. Even in Germany, the demand for the Ayurvedic products are increasing nowadays. In this, you can see the global herbal medicine market is continuously increasing from the year, we have just taken the record from the year 2015, which is now increasing, and it is being told that the market will raise too much by the year 2026. That the demand, and from we all know that from the corona pandemic that the demand for the Ayurvedic medicines are being increased, and our Prime Minister is also supporting for this because we have seen that the Ayurvedic medicines has the value, and they have they bear those medicines values which treat the diseases, and it is fulfilling its aim of preventing the person from the disease and ensuring the total health to the person. Now, the impact of the climate change on the traditional medicine plants. The climate change is continuously have the impact on the health of the plant as well as on the health of the animals, the human beings, and all the microbes. We are mainly concerned about the plants here. Here, the loss of the traditional knowledge because the changes of the climate. The climate is changing. The plants is being continuously trying to adapt to that climate. That is why the phenotype of the plant is being changed, and whatever the literature given in our ancient texts is not matching. That is why there is a problem in accepting that plant or taking the plant as the plant we are using in the medicine. Decreased availability of the medicine plants is another factor. The medicine plants are the availability of the medicine plants is being decreased because of the many factors like the temperature is rising, the greenhouse gases effects are there, due to which the some plants are being adapted or some plants are failing to adapt. That is why some plants are becoming extinct or they are coming into the category of endangered species. The loss of biodiversity as well is also there. The extinction of the plant species is there because I've already told you that when the rise of the temperature is there, the risk of extinction is increased. Increased vulnerability to climate sensitive diseases are also there because as the climate changes, the number of the microbes are also develops, and which are not allowing the plants to develop, and that is why they are coming under the category of the extinctions. Main factors responsible for climate change are elevated CO2, which is the main factor for the greenhouse effect and is causing the warming. And because of the elevation of the CO2, that is carbon dioxide, it is decreasing the secondary metabolites there in the plants. It is affecting the plant growth, and due to which the secondary metabolites or primary metabolites are being, or the ratio of these metabolites are being changed. When the ratio of these metabolites are changed, then what happens? We are taking the medicine, we are considering that we are taking the medicine as per the given ratio. But since the ratio of those flavonoids and all are changing, that when we are taking that medicine, the proportion is not the same, and the desirable effect is not achieved. The ozone and the drought. The ozone, we all know that it is phytotoxic in nature and it reduces the plant photosynthesis and the growth, and it induces substantial changes in the protein activity, gene expression, signaling pathways, metabolism, even before any tissue damage can be detected. And similarly, the drought in warm periods is expected to become the most frequent widespread climatic change that negatively affects the terrestrial ecosystem. When the drought is there, the ecosystem is also disturbed. Over-exploitation of medicinal herbs from the forest. As medicinal plants receive increased nowadays what happens, the scientific or the commercial attention is more towards the plants, towards the this metabolites of the plants, towards the chemical components or active components of the plant. Thereby over exploitation is being done, and we are not getting the plants in the proper manner. Rising temperature, heat waves, and the change in rainfall is the another factor for the plants being extinct and the not proper growth of the plants. The impact of the climate change on secondary metabolites, as I have already told you, that climate change components are the light, temperature, carbon dioxide, moisture, and the ultraviolet light, which affects the secondary and the primary metabolites in the plants. The secondary metabolites are, you all know, that phenolics, the terpenoids, and the nitrogen-containing compounds, which are alkaloids. The ratio of these things, these metabolites are being changed, and the proportion which we want for the medicine is not obtained, not achieved. Now, the climate warming versus secondary metabolite production. When the climate warming is there or the climate change is there, the increase in the volatile organic compounds is generally detected. The availability of menthol crystals, when the temperatures increase, the menthol crystals is affected by heavy monsoon rainfall and the temperature. Also, this aspect is very much relevant as a sizable proportion of the population in developing countries relies on the traditional medicine derived from plants for treating various ailments. Secondary metabolite production may differ because growth is often inhibited more than the photosynthesis. Now, the effects of threats to medicinal plant species. Some species will stay in place but adapt to new climatic conditions through selections, but other species move to higher altitudes or the latitudes. Some species adapt to those conditions when the climate changes there. Some species adapt to that situations, but some species fail to adapt and they move to higher altitudes. Due to rising temperature, some cold adapted plants, the plants in the higher altitudes or the hilly areas, when the temperature is reached, as we all know that there's a rise in the temperature is there. So plants are moving to more higher altitudes so that they can adapt to that, but that situation, because they are not able to adapt like conifers. They are not able to adapt to the high, when the temperature is high. They are not adapted to high temperatures. The indiscriminate harvesting such as Macula's macarantha has resulted in significant reduction in its population to a level which poses threat to extinction in Western Ghats, which is one of the biodiversity hotspots. Conservative species with specific habitat requirement or long generation time are more prone to threat to extinction. The conservative species are there which are which can survive in a particular habitat. When the habitat is changed, they are not able to survive. If we want to grow conifers out here, it is just an impossible thing. So the habitat is changed, they are unable to survive. Yes, the heavy metal contamination due to the climate change. When the atmosphere, water, soil are polluted by toxic chemicals, when the irrigation is done by the polluted water, or when the cultivation is done near to the industrial area, we all know that the plants are contaminated. Yeah, plants take on the chemicals, and all chemicals get magnified and stored there in the plants. And when we take those plants in the form of the medicines, then definitely those chemicals are coming inside our body, and we are not getting the required result. In fact, we are getting the toxic effects, and these toxic effects are not shown at that particular time, because the toxicity is in a very less amount, and that is get stored in that those toxins are get stored in our body in the form of the latent poison. And when the suitable factors are there, then only the toxicity appears. We say that given we are suffering from this problem, we are suffering from diarrhea and the constipation alternatively, and I'm suffering from IBS. This is not the common problem. This is because there is exposure of some toxins in a very minute quantity, which is stored there in the body, and the person is suffering from this particular problem. So these factors have negative effect on the plant physiological process and lead to drastic decrease in the vegetative biomass and seed yield to crop species, resulting in reduced agricultural productivity. This is because when the plant is grown in such an atmosphere, along with the toxicity, the effect is there on the plant vegetation also. Now, since I belong to the Ayurvedic field, so I'll discuss about the Ayurvedic perspective of the climate change also. Our acharyas have told about this climate change, and they have foreseen about this climate change thousands of years ago, and they have told it under the heading of Janpadadvans. They have said that when the four factors, that is Jal, Vayu, Desh and Kal, when these all get vitiated, then definitely the stage will come of the Janpadadvans. The Janpadadvans is all about the epidemic diseases, and it is correlated by the climate change. And the fourth factor, that is Jal, Vayu, Desh and Kal, the Kal is, in this scenario, is the climate change. The Kal Viparya is the Janpadadvans. It is leading to the number of epidemic diseases. Acharyas have also said that very soon the earth will cease to manifest proper taste, potency, etc. So Lord Acharya had advised Agnivesh to collect herbs before the time of destruction and before the earth loses fertility, leading to impairment of taste, potency, vipak, and special effects. So Acharya had told to preserve the seeds before the complete destruction is there. Let me tell you about some endangered medicinal plant species. Because of the climate change, the Aconitum ferox is there, the Centella asiatica is there, the Gloriosa superba, Nilambo mockile. the rhododendron is there. And all these plants are very, very useful in a number of diseases. Like if I talk about Aconitum ferox, it is, though it is poisonous, but it has a very useful, it is very useful in leprosy, fever, cholera, gastric disorders, debility. And let me tell you about this thing, Gloissa superba. It is, it causes the powerful contraction of the uterus and used in the treatment of the gout and even in infertility. So all these plants have, they have a very good therapeutic value and are useful in many types of diseases. But these are endangered now, and very soon they will be extinct if we don't take care of these plants. The Ashtavarga, which is described in an Ayurveda, the Ashtavarga is composed of 8 plants, which has a very good medicine value. Even they are health promoting, and they are very good in cell regeneration. They strengthen the immune system also. But they are in the red list of threatened and endangered species. The Ashtavarga consists of Jivak, Rishvak, Meda, Mahameda, Kakoli, Shir Kakoli, Riddhi, and Riddhi. Nowadays, these drugs are unavailable because all these drugs are grown there at the high altitudes, but they are also they are become extinct because of these climate changes. And so now in the medicine, we are using substitute of it, which are Vidari Kand, Shatavari, Ashwagandha, and Varahi Kand. And though we are using substitute, but the original effect of those drugs are not obtained till now. The major reasons for the substitution of the medicine plants: non-availability of original plant source. This is the major, because the extinction is there. Lack of knowledge about the authentic source. Earlier, what used to happen, all the practitioners, they used to collect the medicine themselves. They had the knowledge of the plant, and they identify the plant with the organoleptic characters. But now this is not possible. This all the practitioners don't do it. They get the plants or the medicine from the market. And non-availability of the authentic plant is already being extinct. That is why it is not available. Lack of the standard chemical markers. The chemical markers are also not proper, or they are lacking. That is why the identification of the plant is not possible. That is not done. This is also the area of the research which has to be done. Now, how to tackle the climate change. Many of the treaties are being done, many of the frameworks are being done, many of the strategies are being made to tackle this problem. The global frameworks and the agreements are done by UN conventions and the climate change and Paris agreements. And financing, 3 broad categories of the action for this are cutting emissions, adapting to climate impacts, and financing required adjustments. Switching to energy system from fossil fuel to renewables like solars and the wind are the demand of nowadays. Ayurvedic methods to tackle climate change. Conservation of the biodiversity. All these are being told by our acharyas many thousands of years back. The conservation of biodiversity, sustainable harvesting over exploitations. Means let me tell you, we have the time now? Just 2 minutes. Conservation of biodiversity. I would emphasize the importance of conserving plants, diversity, and protecting natural habitats. Efforts should be made to establish botanical gardens, sanctuaries, and protected areas for the cultivation and the conservation of medicinal plants. Sustainable harvesting should also be done, which including the use of specific plant parts, harvesting during appropriate season. This is very important. Like if we want the fruit of the particular plant, which is for the medicinal purpose, and suppose that plant is like a shrub or the herb, what we do, we take the whole of the plant. And what happens, we need only just the fruit of that, or we need only the leaf of that, and we are taking the whole of the plant. So this should not be done. Also, the one thing is important, that in Ayurveda it has been told that the particular plant product which is needed for the the medicinal purpose is taken in a particular season. Like fruit is taken in our text that has been said that fruit is taken in fruit of Arjun is taken in when it is properly grown up. And we are taking the Arjun fruit when it is small and unripened. It's of no use. And if we are taking the fruit in a particular, it has been said that it has been taken in the summer season. We are taking in the winter season because we need that. So we won't get the proper effect. And also now because of the climate change, we all know that in this season, in this year, we all have come to know that in the month of May, it was heavy rainfall, but now in the month of August, it's all no rainfall is here. So this climate change also has the effect on the quality or the efficient therapeutic value of the plant. So this has to be taken care of because if the climate change is there, definitely there will be the effect on the plants. Yeah, Ayurvedic view to tackle the pollution. Now, what my topic was about the strategy to tackle about it. So, in the case of water pollution, the sand pollution, soil pollution, and the air pollution. If the water pollution is there, many formulations are mentioned there in Ayurveda, like Dhav Ashkarnadi Yoga, which has Asan, Pare, Bhadra, Nirgundi is there, that is Vitex Nigundo. Asan is there, Dhav is there. So there are so many medicinal plants are there in this particular formulation. And in addition to this, many other formulations are being prescribed in Ayurveda, which are mentioned in the context of water pollution. And under my supervision also, there was a study done on this yoga, that Dhavashkarnadi Yoga, and I found the good results. So the further research on this particular thing has to be promoted. In case of land or soil pollution, many drugs are being described, like Katbi is there, Priyangu is there, Pata is there, Vidang is there, and many anti-toxic or anti-poisonous drugs are mentioned in Ayurveda, which has to be which has to be sprinkled there on the land to prevent the land from the effect of the pesticides, the effect of the pollutions, so that the crop which is grown there should be healthy. And when we are taking it, whether the crop is it, or whether the food it is, whether the wheat plant or any other plant is there, we are taking it. If it is grown in a healthy soil or in a healthy atmosphere, definitely we'll get the healthy results and we will be free from diseases. The air pollution. For air pollution, the Laksha, Haridra, Ativisha are mentioned, which has to be burned, and the smoke of that is that like to be spread into the atmosphere to make the air free from pollution. And if it is this, then if we are inhaling the good air, good quality of air, then definitely the disease of the respiratory system will not be there. Yes, it's almost about to over. So how to preserve the medicinal plants from the climate change, which has been told by our acharyas, and in modern time it also has been said that the seed banking is there, which is told by our acharyas also. The biotechnology, the genetic engineering is there, and research on phytochemical changes happen to plants should also be promoted. The prevention of biodiversity loss, I have already discussed about it, and breeding approaches should also be promoted. So thank you with this. And with this, I just want to say that we have to focus on climate change, and it's a need of the time, it's a need of the hour also, to focus on this, to get up, to be, to open our eyes, to open our senses, to be aware of the climate change, because this is not only the climate change, this is affecting on the plant health, this is affecting our health, and we are having many number of diseases because of this climate change. And our Honorable VC sir is also interested in this, to bring the knowledge of the Asian science along with the modern technologies with the collaboration of the IIT, so under the umbrella umbrella of G20 so that we can do something in this. Thank you.
Thank you, Dr. Kapoor. Now, to enlighten us with the essence of technology in One Health, we have Dr. Sumit Kalra. Dr. Sumit Kalra earned his PhD from IIT Kanpur in 2018 and joined IIT Jodhpur as assistant professor in the Department of Computer Science and Engineering. He's mainly interested in exploring the software architectural issues related to quality of the complex software systems across various domains, such as data-intensive processing, edge fog computing, AI, and IoT-based systems. I call upon Dr. Kalra to talk on the role of IoT in One Health. Just the presentation.
Thank you. Thank you for the opportunity to speak on the topic of One Health. When we say One Health, it's not one person's health, it's everyone's health. So every is missing from One Health. When we say every, in technological solution at computer science level, we always think about IoT. So I'm going to talk about IoT, Internet of Things, where everything is connected to internet so that we can monitor them or observe them or maybe respond to the changes or plan for the changes. So like in IoT approach, we'll make our complex system simpler. We are trying to do that in our lab. So we'll talk about that part. Our problem when we need IoT, our human senses are limited. I'll give you a very naive example. We can see less than 2% of the whole radiation, and we can hear less than 2% of the whole waves. So it makes that 98% of the world is not visible to us. But here our sensors came in action. So we can use sensors which we can't see or which we can't perceive. Using these sensors, we can measure lots of parameters like we are doing in our clinical labs. Our doctors are using those parameters to treat us. So that is about only human health. So we have body area network where we talk about these various sensors and try to capture those parameters, maybe continuously with real-time monitoring and maybe remote monitoring using telemedicine solutions. So there we need IoT for human health. Of course, there's a later part of the network where we want to transfer these values in real time without compromising security or privacy breach. So those all complexities are also there in the system. Similarly, we have sensors for plants. So like precision agriculture, or we want to monitor, say, what Professor Shankar talked about the bacteria growing on soil surface. If we want to monitor remotely, not every one of us can go to Akal or go to Jaisalmer every day and collect the samples. So we need remote solutions to have continuous monitoring and have early intervention when it's required. So there are various ways, various kind of sensors like UAV sensors and humidity sensor, temperature sensors, which can be connected with the system and can be used for continuous monitoring. Then we have IoT solution sensors for animals as well. Generally, we do in counting or tracking the path of migratory birds from one location to another location. In fact, we every year we deploy large number of sensors in high altitude areas in Leh, Ladakh, and Kashmir areas, and so that we can closely monitor the environmental condition and accordingly respond. So majorly army uses those sensors as of now. But we now at this point of time, we can start thinking not only army, we should use those sensors data also for One Health perspective. So I explained why IoT is required and what IoT can enable us. Here is small thing which, not small thing, it's a complex small thing which we do in our lab. We build solutions which are IoT enabled. There are various types of sensor with heterogeneous data, with their different sampling rate, different quality quality parameters, and we want to aggregate them all together. You can imagine it is not easy to have 5 people in a meeting like we see in panel discussion. 5 people sitting there and all of have different opinion. In the same way, the sensors which we are producing from our assembly line, they're also not exactly same. So when we want to aggregate those sensors value which are heterogeneous, it makes our task much more challenging. So data analytics and data processing becomes much more complex in that case. So when we talk about this complexity and at the large scale, you can see the web scale. Web scale system where all systems are interconnected, and still we don't have many things connected to internet at this moment. But now we are talking about the Internet of Things, which will outclass the web scale system. It will be larger than our current existing internet. So in those scenarios, how to tackle compute, how to tackle storage, how to tackle the communication part, which will have more complexity in optimizing the resources. So we work out this evolution part of connectivity, storage, and computation part, and we try to see how they are converging at this point, and in future what kind of technologies we can foresee for enabling or implementing IoT-based solutions. So once you can imagine we have IoT system up to certain scale. Now the next problem comes about the data processing. Simply having a data which is being generated by say thousands of sensors every second if it's generating one data point, and all those sensors are geographically apart from each other. Having a connectivity among them and ensuring the robust, reliable connectivity, it's not a straightforward task. I'll give you one example. The Wi-Fi which we are using, it has 37% accuracy on an average. Means the data you are transferring, say you are transferring 1 GB data, actually you are transferring 3 GB data. Out of that 1 GB is correct, 2 GB was erroneous, so we discarded it. And you can perceive it while you are using mobile data and downloading some say 200 MB file, and you see your internet usage goes to 600 MB because your 2/3 of the data was not correct, so your system has discarded it. Now we are talking about the large scale system, and if we are working with 1/3 efficiency, that's not going to work. It will not be cost optimal. So there are various ways in which we can maintain this large amount of data with heterogeneous data, which I talked about, like it can be text, it can be images, it can be videos, it can be audio files as well. So there's a multimedia data which we would like to process it. So different type of data, different nature of data will suggest us to use different approaches like graph processing or textual processing or incremental learning. It depends on what is the context and what kind of data we are collecting. Then we have data analytical category. You can imagine so far we have transferred our movie from USB to our laptop. That was data processing. Now we actually want to watch movie. So when we play movie, high definition movie, there lots of compute resources are used to watch the movie. In the same way, after data processing, when we jump to data analytics, we want to answer some unknown questions. Then data analytical frameworks come into picture, And here we start with traditional statistical and mathematical approaches to more heuristic and deep learning based approaches. Now we are shallow learning, hollow learning as well. So large, here again we have heterogeneous approaches for different contexts. Now you can see there's lots of heterogeneity in IoT based system if we want to analyze the data. So complete pipeline from start to end is quite large and complex. So we need some robust and highly scalable solutions which we don't have as of now. And in our lab, we are continuously working on such systems and making. So we are working in a resource constraints environment where we have small machine and we can scale our system to thousands of millions of users with a small laptop, laptop kind of system, the commodity hardware. These kind of solutions will enable us in future to scale our IoT for One Health. I'll give you one problem which we generally face while building such system is fault tolerance. Suppose there is any failure in any component or any entity or any part of the system, and we want to handle that fault. We don't want our system to fail because of that one or two or partial fault in the system. So there are large number of approaches we worked out like redundancy, migration, failure semantics, failure masking and recovery. I'm not going to lecture you on computer science right now. I'm sorry for that. But I will be happy to welcome you for any elaborate discussion on such approaches. I generally discuss these approaches in my class lectures, how to build a robust, scalable, and highly reliable system at that scale. So with that, thank you all. Any questions? Sure. Yeah. Thank you.
Thank you, Dr. Kalra. So now we'll be moving ahead with our second panel session on technologies for sustainability. We are truly honored to have the privilege of hosting distinguished guests who hail from a diverse array of transdisciplinary domain. So now, okay. So just before that, I request Professor Mukherjee to present our token of appreciation to our previous panel members and the speakers of the previous session. Dr. Abhimanyu Kumar, Dr. Bharat Kumar, and Dr. Siddharth Srivastav, Dr. Manoharan, Dr. Shadukha, Dr. Roy, Dr. Kalra, and Dr. Kapoor. Please join us on the stage. I also request Professor Jha to join us on the stage for the felicitation. ठीक है. So we'll now move on with our second panel session on technologies for sustainability. We are truly honored to have the privilege of hosting our distinguished guests who hail from a diverse array of transdisciplinary domains. So now I invite Dr. Mansi Mukherjee, Program Manager, JCKIF, Dr. Suchetna Chakraborty, Associate Professor, Department of Computer Science and Engineering, IIT Jodhpur, Dr. Suresh Yadav, Scientist C, ICMR, NIIR, NCD Jodhpur, Dr. Saptarshi Pine, Assistant Professor, Department of Computer Science and Engineering, IIT Jodhpur, and Dr. Kuldeep Singh, Dean Academics and Professor at Department of Pediatrics, AIIMS Jodhpur, to join us on stage. I also warmly welcome Dr. Geeta Manjunath, CEO of Niramay, who is with us online for the panel discussion.
Hi. Thank you.
I now invite Dr. Raviraj Venkayala to moderate this session. Thank you.
Good evening, everyone. So myself, Raviraj Vankaila. I'm from Department of Bioscience and Bioengineering at IIT Jodhpur. So welcome to this panel discussion for the technologies for sustainability. So we all had, a wide range of talks, starting from the morning on One Health. So today we have some eminent panelists with diverse backgrounds. So first, I'll start my question with Dr. Suchetna. So Dr. Suchetna, in the perspective of One Health, preservation of the entire ecosystem becomes very important. In this regard, how do you think technologies can help us?
Thank you. Yeah, so as you rightly pointed out, and as we are speaking of the technologies for sustainability, so you see there are these sustainability goals, right? The SDGs that have been set by the United Nations. So if we are to promote the well-being of the society, there are many things to address. There are many problems. And we really, from computer science background, when we talk about the technologies that are disruptive in the sense, we are kind of doing great in terms of considering the or creating the future, say the blockchain or IoT, quantum, right? VR, AR, metaverse. So all these technologies, when you say that how they can address different challenges in healthcare, transportation, food, or whatever to for greater good of the society, the main things that we need to care about whether the choice is right and that itself is sustainable, right? So whether it's affecting the privacy of the users, whether it's accumulating to the 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 electronic waste, right? Whether it is contributing to, say, the when we talk about this energy footprint, right, or the carbon footprint, whether it's contributing to that. So there are multiple aspects when we talk about the technologies, and in that front, it is imperative that we it's a great responsibility for us to develop the technologies in such a manner. Now, when we, in IIT Jodhpur, so among multiple aspects, we are also one of the initiative that we have taken to promote this conservation of biodiversity, right? And there are active participants and members who share the similar interest. Dr. Mansi is actually initiating that venture where we have this BioBlitz program, right? So students, faculty, staff, many, and the family members, so they involve in sharing, and there are amateurs, there are experts, right, who are not so much equal in terms of having the knowledge base about, and there is a responsibility from the societal point of view to know and be aware, spreading the the awareness for so that's what is our initiative, that we have developed this Prakriti app. It's an app, mobile app, and people can install it, download it, and share images as well as the locations, geolocations where something has been sighted, right? Or some particular attributes of a particular flora and fauna that people are not really aware of, and that creates a lot of knowledge dissemination among the which is very much in the vicinity. Unless you know your surroundings, it's difficult, and that's the whole purpose of this app that we are. And toward that, the sustainability aspect that we are trying to bring in is that the user should not feel privacy. So there should be incentivization for the users to use that app. There should not be too much cost of it, right? That it should not take too much bandwidth or say memory, right? Or it may use the battery life of the phone that you are using in an effective manner. And it should not be intrusive. That is the fundamental aspect to the users, as well as the particles that we are using, say the subjects in that context, our flora and fauna. It should not be that much intrusive. It should be non-invasive observation of the environment. That is another fundamental aspect that we are promoting. So today, I shared that QR code, maybe that is there. So if that can be projected, so you are free to, feel free to download that and use it. It's the second version of the Prakriti app that we are launching, and we'll have a small demo is there, just a few seconds to show like what kind of features it includes and how you can make effective use of this app, what kind of difference you can make to promote this kind of idea.
So my next question is to Dr. Mansi, on the lines of what Dr. Suchetna has pointed out, and you're also you work in the area of ecology. So how citizen science is an important concept in ecological science and how it contributes to One Health. Can you shed us some light?
Yeah, thank you so much for the question. And as just Dr. Suchetna pointed it out, that we already have a lot of technological interventions that are growing in the field of ecology. And I often keep talking about citizen science as one of the most important area of science, which is lacking a lot of attention from the field of science. It has huge potential, and how I'll just elaborate a few points on that. Basically, citizen science is where all the public participates and collaborates in gathering scientific data, scientific knowledge in a given protocol, and this approach is completely not age biased, not background biased. So any public can participate in this. And the most important part to note are the factors which are based on this citizen science. One is it actually minimizes the amount of time, the amount of resources that are needed to gather a large amount of ecological data. For example, if you're trying to understand an ecosystem, it would take a year of your time to just gather the data, and then further you can go on with the analysis. And a single person cannot go on accumulating so much of data. So when a lot of people participate, and they are trained to do so, you gather a lot of data in a shorter period of time, and it is in a larger scale. So this is the beauty of citizen science. Well, there are always pros and cons of any approaches that you have, but I would overlook the cons and think of the pros. And to me, we have come up with a study very recently where we have used citizen science program data, crowdsourced data, which is available on eBird, which is one of the best run citizen science programs globally. And we could come up with a beautiful example of delineating ecoregions based on this data. So had it been me alone trying to gather this data, I would have taken 20 years of my time, believe me. So it reduced my time, my cost, my resources, and we could come up with important locations that are needed for conservation just based on citizen science programs.
Thank you, Dr. Mansi. Since we are talking about data in the panel, we also have Dr. Saptarshi Pine from the Department of Computer Science and Engineering, IIT Jodhpur. And his area is big data analytics. So my question to you is, like, in the process of the preservation of the entire ecosystem, how big data analytics can actually play an important role?
Thank you for the question, Dr. Raviraj. As we have seen that from the apps, Dr. Shuchetana has developed the Prakriti app. And then we have Dr. Manasi's eWord app and the other apps so these apps are generating data. As well as we saw from Dr. Kalra's, the IoT sensor, as he has said that these data generated only from the IoT sensors will outclass the scale of the current existing internet in a few years. So those kind of data we are getting generated, and big data, when we are talking about big data, it follows 3 V's. So if a data has 3 properties, it is generating in high volume at a very high velocity, and it has to have variety. So heterogeneous data. We have photos taken from the like eBird and the Prakriti apps. Also from, we saw from Dr. Sankar's biocrust images taken at the macroscopic level and the microscopic level. So we have photos, then drone videos taken from the agricultural lands, as well as we have the molecular data that is being collected. So those kind of data, like for sequencing, so all those data coming together, and when we have to integrate all this data and analyze those data to get insights, that would give us some pointers to create parameters as well as indices. For example, we saw that from Padma Vibhushan Anil Joshiji's talk a few days ago, that he and his team has developed this domestic instead of GDP, he has developed GEP, which is the gross environmental product, those kind of indexes. So we can develop those kind of indices as well as policies. So in summary, I would say that integrating this large amount of data, heterogeneous data, would give us insight that would lead us to make better policies as well as regulate the existing policies.
Thank you, Dr. Saptarshi. So in the panel, we also have Dr. Kuldeep Singh from AIMS Jodhpur. He's a dean of economics at AIMS Jodhpur. Sir, my question to you is that how do you think that implementation of technologies would be relevant to cater remote healthcare systems?
So thank you. And this is a very important forum. And when we are talking about the G20, the theme of this is one Earth, one family, and one future, and also one health. And I think since morning it is being discussed about the One Health. What is the concept of the One Health? One Health, basically, when we talk about One Health, there are three angles of that. One is the environment, which is visible or invisible also. Second is the animals, which can be smaller microbes also. And third is the human disease. So human disease detection is one of the foremost important thing, because here comes the role of technology. So when we talk about the human disease, that symptoms may be visible, may not be there. So what is known as, there is a precision medicine. So another concept which is now coming up is the clinical precision medicine. So what is meant by the clinical precision medicine? Sometimes the symptoms are there, but they are not explainable by the existing technology. And here comes the experience of the treating doctor. So as a doctor, when we see the patients in our hospital, so we suspect something and we do the investigations. So here we use the technology, but there are certain conditions where it is diagnosis very difficult. So for example, we had come across one patient with Balamuthia. This is a very rare condition, rare disease. And that is being detected by the during the neurosurgical procedure by the microbiological department with the help of DNA technology. So there are many things where we have to suspect there is something wrong, and then we have to go. So keeping this in view, Government of India has formed a Department of Biotechnology Consortium for One Health, and AIIMS Jodhpur is a part of that. So before starting this project in 2021, we were not talking to each other, like veterinary scientists, agriculturists, and environmentalists, including the wildlife scientists. But after these projects, we are now talking, they are understanding what the human disease is there. So last year there was a epidemic of this lumpy skin disease, and everybody was scared drinking the milk will cause the disease in the humans. But it was found that it will not cause any disease. Lumpy skin disease is just a viral disease of the cows and the animals, which it is like a chicken pox. And it is only when the sepsis occurs, secondary infections occur, then only it causes death of the animals. Similarly, if we know about the disease, so technology to me is that if we know about the disease in depth, we stop being afraid of that disease. So more informative the knowledge the people have, the better we can treat the disease. And here comes the role of technology. One of the technological aspect is we have a nudge unit also. It is based on the behavioral economics. So when we see something visible, so water we can say the visibly it is dirty, but there are water which are very clean, but there are a lot of bacteria in that. And they are causing a lot of nosocomial or hospital-acquired infections. So sometimes the things are visible. So what the scientists in the Europe have found that if we use the behavioral economics, changing the behavior of the people to think about the disease. So they are told right from the beginning in the school years, never put anything, even a drop of something in the river. It is being taught so that they are nudged toward that behavior. So they have to think 100 times before putting anything in the water. And that behavior is now lacking in our country. So we discard anything everywhere, and that is causing contamination of the environment. We don't know that it is going to affect the future. It can affect the disease. But again, doctors are in the forefront. They're finding out the cause, the symptoms, and how to treat them. So they are treatment also. So technology is also helping with the treatment of these disorders. So I think this is, as Sumit Kalra has explained about that, there are data, Internet of Things, and technology, drone technology, and many of the genomic technology are helping. And we are studying the copy number variations in the organisms. Sometimes the copy number variation changes the pathogenicity of the organism. So all these things are helping the human being. And I think the collaboration is the buzzword. We have to collaborate with each other, whether it is a scientist, engineers, medical professions, it is a traditional medicine, or it is a modern medicine. or even agriculture is wildlife. So all these are things integrating. So integrated medicine is one of the things which is important for our health, and that is One Health.
Thank you, sir. So today we also have Dr. Geeta Manjunath, who has joined with us online. Welcome, ma'am. So Dr. Geeta Manjunath is a AI scientist and who is the founder and CEO of Niramai Health Analytics. So ma'am, my question to you is like, what kind of technology you have used, in your solution which you have developed at Niramai? Can you shed us some light on that?
Sure. And can you hear me?
Yes, ma'am. Yes, we can hear you.
Yeah, sure. It's a pleasure. Sorry, I'm not being able to come there in person. So thank you for that question, Dr. Raviraj. Basically, what I thought I will do is, given that I am remote, I'll just share a few slides, if you allow me. Just not take much time. So basically, what I feel very strongly about is that use of AI for medical imaging can make things very sustainable and address many of the issues the earlier panelists were mentioning about, right? One health and good health for everyone in a sustainable manner. So in fact, earlier also we talked about how AI can be used, in different ways, drones, IoT, etc. But medical images are something that all of us have seen, and this is believed to be the one of the main areas where AI can help. And when we talk about AI, it's basically just to make sure that the terminology is well said. Learning, deep learning, and a subset of that is deep reinforcement learning, and several other newer stuff coming in with ChatGPT and others coming in as well. But when we talk about AI in radiology, what is happening is now there is improved productivity. We also talk about sustainability in terms of human resources, how we efficiently use human resources, minimal expertise that's available, and also making sure that there are reduced error in diagnosis. Could be missed diagnosis or missed cancer, for example, or misdiagnosis, calling out somebody as cancers when it's not there, and so on. Particularly, I am very, very passionate about, and it's very, very relevant to the One Health in sustainability aspect, is where AI can be used to bridge the two gaps that exist in healthcare. There are the haves and the have-nots, and AI can be used to bridge this gap. How? One, in order to make these experts' time available to many more, AI can be used for quickly helping and identifying a first level analysis for people to be more productive. And on the sustainability angle, like, in rural areas where there's no expertise available, this can act as a bot. So particularly to answer your question, Dr. Raviraj, so basically we are addressing this issue of universal healthcare, high quality healthcare, sustainable manner, by developing a new solution of using AI to solve one of the biggest problems in women's health, which is breast cancer, which is the top cancer. And in fact, every 3 minutes, one person is getting detected with breast cancer, and every 6 minutes, one person is dying. While mammography is the default standard, it is not sustainable. There, it is radiation based, not accessible, affordable, and a lot of request, or a lot of, I would say, requirement on high skill that is needed, which is also one of the SDG part, is about how do we make it healthcare for everyone, right? It's not feasible, affordable, etc. So what we have developed here is what we call as thermal analytics, where we use a simple thermal imaging, non-radiation based device to measure the temperature variations on the chest. This is one example of what one of the earlier panelists was talking about. How do we have non-invasive, radiation-free detection, right? So this is just infrared imaging, which is, there's no radiation, just measuring the temperature from our own body that's coming out, like essentially a thermometer of a high resolution, right? And also, doing it in a way that it's completely non-contact, non-invasive, and almost like a changing room experience. So by enabling an AI-based analysis of temperature variations on the body, and generating a breast health report in a very novel manner, we are able to create a new method of detecting breast cancer. Given that there is a research audience, just to go a little bit more into how we are using AI, what we do here is we use AI for multiple things. One is image quality checks. again, when we talk about One Health and sustainable manner, we need to make the tools usable by even low skilled workers. So the a lot of people can actually get jobs, if you will, and able to perform at a much higher potential than what they actually are having, so that it's like enhanced assistance that the tools can provide. So one of the things that we enable is these tools or this screening can be done by simple health workers. So when they make an error, they are likely to make error. The AI should be smart enough to figure out that there are errors in the images that have been taken, because garbage in is garbage out. Obviously, the images have to be good. And also in classifying these thermal images as to whether it's likely to be abnormal or not in a very, very accurate manner with high levels of sensitivity of 100%, for example, is what for screening we have, with of course a false positive rate. But this is how do we use AI to make a simple point of care device, which is what we call as high quality, affordable healthcare for everyone in a sustainable manner, non-radiation based manner, and in a manner where it does not lose any of the accuracy that is needed. So this is something that we have done with regulatory approvals and usage in multiple places, and also making it available in small form factors, small vans, and also able to do this in a sustainable manner even at the corners of the world. This is something that we have done. I'm not going to go into too much of detail, but this is how we are using AI to solve a real problem, which can address this huge issue in a sustainable manner across different parts of the world, I would say, right? Be it in rural areas or urban areas as well, and without using any radiation, right? And so this is something that we have developed here, and I'm happy to sort of go into more details if there are any questions.
Thank you, ma'am. So in the panel, we also have Dr. Suresh Yadav, who is a scientist at ICMR, National Institute for Implementation Research on Non-Communicable Diseases. So Dr. Yadav, my question to you is that, so during the pandemic time, we all have witnessed that preservation of animal health is extremely important. So in this regard, what would be your comments on the animal health monitoring as a measure to prevent further pandemic situations? Could you provide some insights?
Hello, thank you. With respect to zoonotic diseases, this is the least priority with respect to monitoring of zoonotic disease in the country, because the health has been divided into many compartments. When we talk about national programs, then the country's health is a national policy and 50% of it is state policy. The responsibility lies with the state with respect to rollout of all the programs and its implementation. With respect to animal health, it is again divided into many compartments. The Ministry of Agriculture and the veterinary science people are basically into animal health only. So the complex mechanism of transfer of disease from animal to human or human to animals, this transfer is not being monitored. There are organizations and there are parties with respect to monitoring of genetic diseases being transferred from animals to humans and humans to animals. And for that purpose, what is required here is that a network of institutions or network of, we can say, there should be a policy where, all the ectoparasites of animals should be screened for what pathogens they are harboring with, or which pathogens are present in them. Similarly, with respect to monitoring of outbreaks through IDSP program, it leads to tell us which disease has outbroken in which part of the country. But after that, its follow-up with respect to what its outcome is, it is not so. My suggestion with respect to this is, I will say that those people who are into genetic diseases research, or those who are having expertise in dealing with that, they can prioritize and they can make a collective effort with respect to bringing out what load this is and what burden it has, so that a priority can be set for monitoring of genetic disease at a national level, so that we can prevent any pandemic-like situation in the country. This would be my suggestions.
Thank you. So now after this initial round of discussions, we got some idea on how technologies can, be a integral part of monitoring and preservation of One Health. So now again, Dr. Suchetna, my question is to you again. So we are in a desert ecosystem where we encounter a unique set of environmental conditions such as animals, plants, and also unique set of human diseases as well. So in this context, how existing technologies can contribute to the sustainable monitoring and also the preservation of One Health, especially in Thar?
Yeah, thank you. Based on the discussion that we are having, we have been exposed to multiple set of technologies depending on what kind of subject we are going to address, right? Say the plants or animals or general human being for disease detection, or it's an ecosystem. And when you talk about like doctor said, like this integrated medicine, right? So we need a integrated framework where this transformation, right, that or the transferring of the cause and the effect can be captured. So mostly we have this sensor-based system for remote monitoring. We have crowdsourcing technologies which will gather the data from multiple aspects, because we are relying so much on the AI and ML. And all these applications, or wherever we are going for a futuristic inference or prediction or detection, that kind of intelligent decision making or knowledge inference, basically we are relying on data in whatever methods we are collecting from. But understanding that we have a responsibility, that how much data we are collecting, is it intrusive or not, right? So from where we are collecting, so how they are impacting on the sustainability of those entities from which we are collecting, and in whatever manner. So is it accumulating too much error, too much noise? That is another aspect where we need to talk about trustable AI or responsible AI, right? So we are talking about the ML model, and we are relying on the machine intelligence, but then how much reliance we are putting on those data? So that is again a fundamental question where a lot of research is going on, be it the health of human being, or be it the health of plant, and how the whole aspects of ecological system, like the climate, like the local population, the habit, the culture, everything is making an impact. So that's kind of the contextual attributes which are adding value, which in many cases we are missing because we are not looking into the holistic perspective. But that is very much vital, in my opinion, when we are looking into, say, the third ecosystem, right, which is having a very specific kind of attributes that are playing along. So those aspects also need to be taken into consideration while we are developing the technologies to address the sustainability. Yeah, thanks.
Okay, so in terms of data, there is always a problem with the data storage. So there is always a big problem with the data storage. So my question is to Dr. Saptarshi. So I believe high power consumption and heavy duty cooling are also one of the major problems which might impact the environment in an adverse way. So how do you think this problem can be addressed?
Yes, Dr. Ravi, your suspicion is valid, because when we are talking about like big data, we are collecting this kind of big data to make intelligent decisions, then we need big data centers to store those data. And with that, we need to support those big data centers, we need, as you said, that the power consumption as well as the heavy duty cooling systems. So there are some, so I'll answer it in like two small parts. One is the existing solutions. So if we are looking at the GPUs, so if for a daily household, like an average household, the daily usage is like 30,000 watt hours, then a single GPU chip consumes almost 1,000 watt hour itself, just one GPU chip. CPU chips generally take like 300 watt hours, much less. But now we are more and more relying on this kind of GPU chips because the data that we are collecting are mostly like photos, videos, those kind of graphics data. So that is a huge concern that you have said. So one thing is we can for powering up these data centers. So we need two types of electricities. One that is the main power, which can come from electric, but then we need backup power, which is the main problem because we need diesel generators which run all the time. So they are not efficient, they'll run all the time, they work as backup and they need to be running all the time for 24 hours because they are backup. So and this is because most of the places where the data centers are located, which are in the Western countries, they do not have very reliable solar source of energy. But we do not have that problem in the Thar ecosystem. Here we have, even in the winter, we have a very reliable source of like solar energy. So that problem could be mitigated here by creating the backup and the main power grid attached to the solar power. And on the second part, that is the cooling system, there are also people are using different types of cooling system like liquid based, where basically the liquid that is being, because whenever we are having like, let's say we have these servers here in this, on this stage, usually like the air would get heated up and go to towards the ceiling. So ceiling would have basically these liquid tunnels which would get heated up and then they would vaporize. And those vaporized liquids we can bring down to the basically those warm vaporized water we can move to the floor, cool them down, because floor is always the coolest and ceiling is always the hottest because air always, the warm air moves to the top. So those kind of technologies are there. This is the first part with the existing solutions that we can implement in the Thar for creating data centers here. And for a new one, which the idea came from Lieutenant General Chadha's speech today, that he talked about this, our traditional knowledge, which is being repackaged as the biophilic wisdom, which is the wisdom of Tattvas. So where he said that we can create this kind of new architecture. So it was an invitation to all the civil engineers here to create architectures like underground architectures or data centers with walls with lime scale or covered with cow dung, which will keep the data centers very cool. So that was a great point. I want to reiterate that in my response with that. Thank you.
Thank you. That was wonderful. So, Dr. Mansi, like since you're an ecologist, I mean, from the ecology point of view, what exactly technology is and how do you confirm, in enabling the ecological health?
Yeah, thank you for the question. Just as Dr. Saptarshi pointed out, I would like to point this out more importantly, that in ecological world, data storage comes next. Data acquisition becomes more of a problem. Gathering data itself is a big challenge. And it is very true, unless and until there is technological intervention in the world of ecology, we would not be able to gather so much of data as we require to analyze the system, to analyze the products, to analyze the components of the system, whether it is the biotic or the abiotic components, all of them. First point. Secondarily, we say that ecological data, if we are gathering, then how is the data to be analyzed? So few of us have already talked about, lots of ecological, technological interventions that have happened in the field of data analysis. And then further moving on, there are many more technological interventions that have helped ecology to be understood in the future perspective. So we understand the condition of an ecosystem in the past, assess the present, and now we are predicting the future. That also requires technology in there. But I also have to stress that when I coined the term techno-ecology, it's a bidirectional term. It means that as much as technology is important in the field of ecology, ecology is equally important in the field of technology. Ecology has always inspired technology in all forms, whether it is in civil engineering, whether it is in designing, whether it is in products, right? So it has always inspired. Just now, as Dr. Saptarshi was talking about how Dr. Chadda emphasized on the product that we can use from the natural ecosystem to produce our newer constructions. There's an example that I have come across that cactus has inspired a building in Qatar, which is called Qatar Sprouts Building. And if you look at the structure, it has sunshades, panels that are on the windows, and it opens and closes based on the intensity of sunlight it receives. And it's completely based on the inspiration that it has received from the cactus, which again tries to reduce the transpiration rate by doing transpiration only during nights and not during the day. So this kind of inspirations often happen in and around the ecosystems. The lotus, which has a waterproof quality, has inspired waterproof shields. So we often go and submit ourselves to the ecology to find solutions from the ecology, and it is always bidirectional to me. And this synergy is very, very important. Unless and until this synergy keeps up, we will never be in harmony. If we try to overdo the technology on ecology, then again there will be an imbalance. I'm sure about that. Thank you.
So, ma'am, Dr. Geeta Manjunath, ma'am, this question is to you. As you have described, I mean, in the initial round, you elaborated on your, technological innovation for the breast cancer detection. So now, can you shed us some light, like how your healthcare innovation address the sustainable needs of the population and also enable the large societal impact? And also, what challenges you have faced and how did you overcome those?
Absolutely. Thank you for that question. See, what happens is one of the parts that I mentioned before also is that sustainability in healthcare means One Health, like some of the panelists also mentioned, is that how do we make high quality healthcare affordable for everyone? Affordability in terms of cost, and also accessible. Like when we talk about deserts and so on, like there are lots of remote areas. How do we actually make a portable small system, a point of care device, which can go to different corners of the country and then enable this at a high quality again, right? So that is something that we have done extensively. For example, when we are trying to do this in an affordable manner, of course, we talked about radiation free, but still the machines were about, let's say, 1/10 the cost of mammography, but that itself is not sufficient. You had to make it even more, less costly, if you will. So we came up with a different form factor. Can we use something with a mobile phone, which is already, which has an offline, an online kind of a mechanism to take care of internet non-availability? Can we use systems where there is no electricity requirement? There's some kind of a charging that we can provide, but still electricity requirements are much lower. Can we make it in a way that the skill needed to run this is much lesser, so it is more sustainable, more number of people will be able to use it and benefit from this? So these are some of the things. And last but not the least, using no radiation, so that it becomes obviously less burden on the environment itself. So all of these is something that we talk about. In fact, when we were discussing with NHS UK, they have this, of course, we all know about this concept of net zero. So for the, getting to the net zero aspect of it, they also consider how much travel one needs to do, right? In order to go, if she or a patient has to go, let's say, 100 kilometers to get to a hospital, that also adds to the environmental effects because there is more travel and more fuel usage that comes in. So these kind of things are ticking many of the SDG goals that were referred to earlier as well. But one of the main challenges in this, when we are trying to build with a radiation-free imaging solution, is nobody else has done this before well. Right? It's a very, very novel solution. And if you're trying to build an AI-based solution, then the challenge literally is, as one of the panelists mentioned earlier, is about data collection, right? So whenever you're trying to do something very new using AI, where is the data? So in fact, we had to spend a lot of time trying to collect this data ourselves. Second, there's no doctor who can confidently look at a thermal image and say, yes, there is cancer or not. So how do we label the data itself, right? So that's another big aspect of it, where we had to do this test followed by all the standard of care tests that's available in the sort of the best hospitals of the world in order to use a biopsy data as the label, because we can't use any human labeling or anything like this, right? So we had to, same person used to go through thermal and then go through mammogram, ultrasound, and if positive, do a biopsy. And that data was used to say whether the thermal has cancer. I mean, like, it is for a cancer patient or not. And then the whole system has to be learned. And the last bit of it, in order to develop any innovative solution, in fact, and here if it's a sustainable solution as well, is what we do in the lab inside a research is not sufficient when you actually take it on the field. Like, we have experts from AIMS and all on the panel. So when you actually want to use it in a hospital setting, you're directly applying it on patients, and the decision or at least the support for the decision that's coming from the tool is helping the doctor make a decision whether it's cancer or no cancer. It's a very, very critical decision. So when we are trying to do this, simple lab level testing is not sufficient. You need to do prospective studies in a complete blinded systematic studies where, we can prove that the AI model is able to generate the results without knowing the labels for everything. Many times we as researchers build AI models saying, oh, this is 80% is training set, 20% is testing set, and here is my result. That is not at all sufficient when you actually want to build something sustainable in real field, right? It has to be, if possible, you have to do a randomized control study or at least a prospective study on the field and make sure that the results are obtained. And only then we can claim that it is a solution for the public, right? So this is one aspect which I want to bring in, given that we have a research expert crowd here. But this is, as a scientist, I myself, I'm a principal scientist and from IISc and HP and others. So it was a transformative thinking for me, right? In order to build a real solution in the field, what is the level of clinical testing that one needs to do? Anyway, so I thought in this forum, I will also mention this angle. So that for people who are building a newer solution, they can take that into consideration.
Yeah, thank you so much, ma'am. So, Dr. Kuldeep, this question is to you. Can you also tell us a little bit about telemedicine? Because telemedicine also becomes very important during the pandemic time, we all have realized. So, how telemedicine can make the health sector more accessible and economical to a common man?
I think when we talk about the One Health, so there are many of the questions have been answered, like how the technology is helping. But one thing but everybody has to understand is technology is only one component, and technology can also affect the health. We are not seeing the future. What we are seeing, the use of the technology that is affecting our future also. So for every action, there is an equal reaction also. And we are forgetting when we are creating something new, we don't consider that what is the impact on the future. So that is also very important. And when we talk about the patients going to the hospital at tertiary care, what we see in the hospitals are the tip of the iceberg. And there are many more patients who are affected with a similar disease in the community. And that's where the government of India has taken a very important initiative to create health and wellness centers. Health and wellness centers are usually located in the nearby area where the patient is there. So it is providing not only the screening program, but also the diagnostics by the referral. And telemedicine, or for that matter, any technology, is assistive in nature. So telemedicine has a very important impact. It reduces the time of the patient travel, also cost of the fuel and contamination of the environment. And also it is providing the basic care to the patient at the home. And I think telemedicine at AIMS Jodhpur, we are using in the Sirohi. So the tribal population, which is very remotely located, they are being held by the consultant at the AIMS Jodhpur. So they are directly dealing with the neurosurgeon, they are directly with the cardiologist, as well as dermatologist, ophthalmologist. So telemedicine is one of the important thing, which is being now included in the National Medical Commission curriculum also. And every doctor has to be certified in the telemedicine as a telemedicine provider also, because there is some nitty-gritty involved in that also. Not everybody can provide the telemedicine. And Government of India is taking many platform and like decision support system that is also being used with the help of telemedicine. And one important thing is that telemedicine gives us an idea about how the patient's disease can be minimized. But again, the another thing which is being arising is because of the telemedicine, there's an impact on the caregiver provider's burden. The burden on the caregiver provider, it is increasing. There sometimes the telemanus, when we talk about the telemanus, the mental health problems are increasing day by day, and they are going to multiply 100 times in next 10 years. The aggression we see of the peoples, not only of the people but the animals also, it is directly related to technology only. And that mental health effect is more compounding in nature. And Telemanus is one of the platform. But what we have observed, the person behind the Telemanus, they are also suffering because they have to answer the call at odd times. At 2 o'clock in the night, there is a call. So we have to take care of the health of the people who are providing the health. And also, I think for technology to be optimally utilized, everybody should be aware and they should use the ecosystem, ecology, and the economics of the technology so that we can we can provide the optimized healthcare to the people who are in the last in the queue. And that is the purpose of the telemedicine. Thank you.
Thank you, sir. So finally, Dr. Yadav, my final question is to you. So can you just very briefly list us what are the main areas where technology can contribute to the sustainable development of India?
With respect to our Prime Minister's announcement that by next 3 years we would be 3 trillion economy and we are targeting for 5 trillion economy. With this dream and with this progress where we are leading to, what is required here is that ensuring that we are having the largest workforce in the country and providing them good occupational environment as well as ensuring that the safety of the workers, both in the informal sector and those who are working in the formal sector, it is not causing any ill health effect to the workers. This is supposed to be ensured by what? Continuous environmental monitoring. And the biggest challenge which we face when we talk about exposure, any occupational disease is supposed to be established with exposure, and establishing exposure in working environment is very difficult. We face a lot of challenge in establishing that exposure has occurred in that work environment only. This requires technological intervention, and this also requires technological development. We say that air pollution is leading to lung diseases, or we can say that respiratory illnesses in the country. But the association of air pollution directly with the respiratory illnesses in the country is not yet proven or established with respect to each environmental pollutant which has been mapped in the country. I can, as we are presently running one project at our institute, it is a national study, and it is focusing on only this, that how air pollution is associated with causing respiratory illnesses in the country. And in that, what we are targeting is mapping out each and every indicator of air pollution in real-time scenario. When we piloted this one, the biggest challenge which we had was the sensor-based real-time monitors which are available in the market. They do not last for the duration of the study. If we plant the same machine inside the house, it works for 3 years. But if we plant the same machine outside the house of the same house, it does not work for 3 years. The sensor goes in only 8 months. So these are the few challenges where, for ensuring sustainable development of my country, I would say that sustainable technologies are also required. And sustainable technologies with respect to monitoring of, we have to think with respect to 2 aspects. We have to identify which are leading to ill health, or we can say adverse effects on our health. Then trying to find out alternatives to those which are safer than that. Everywhere we are going to the market and we are trying to find BPA free bottles or something like that. But BPA was replaced by something, then only there is an alternative. Otherwise, it was not possible. So we need to, as a technological institute, we need to focus on that. What is hazardous and how it can be replaced by a better compound or better technology so that it can be sustained. So this is the only way forward for developing backend.
Okay. So this brings an end to the panel discussion. I sincerely thank all the panelists for providing very valuable insights from different dimensions. Thank you so much once again for your time. Yeah.
Thank you.
I thank you all for the enlightening session, and I would now request Professor Mukherjee to present a token of our gratitude to our panel members and also the moderator of the session.
Thank you.
So this session is very exciting, and please hold on to your seats because there are small kids, and kids for me are talking, and there's a school kid who has been sitting from early morning. He's a 5th standard kid and he's very excited. So all of you have to hear. So this is for the next generation who is going to face the world, and One Health is going to strike them more, right? So if we have younger citizens coming up to speak, I think we all look forward to hearing them. So Rahima, please take over. Yeah.
Warm greetings to our distinguished delegates, guests, and fellow science enthusiasts. Today, I'm honored to introduce a group of remarkable individuals who are at the heart of our event's theme of citizen science and stakeholders, the integrated perspective. In a world where collaboration and community engagement are key to driving the change, these citizen science participants stand as shining examples of how every individual can contribute to a greater understanding of our environment, health, and the intricate connections that bind them. Our very first speakers are school students from Lucky International School, a brother-sister duo of Jhanak Sharma and Purvansh Sharma, who are passionately dedicated to making this world more sustainable through their efforts. Today, they would be sharing their experience on 2 recent projects taken up by them, which demonstrate the relevance and significance of culture, that is Sanskriti, and nature, that is Prakriti, in complementing each other's sustainability and the role of citizen engagement to catalyze this synergy. So I will call upon Jhanak and Purvansh to present their talk.
Greetings to one and all present here. I'm Purvan Sharma and I would like to share our journey so far on a project, me and my sister Janak Togam. It was over a year ago when we came across our father's credit card lying unattended. When we handed over to him expecting a reward, he didn't care much as it was supposedly expired. We got curious and asked him why this card, which looks hale and hearty, is declared dead. Despite his sincere intent, he couldn't convince us and finally blamed it to be a norm. We weren't comfortable with a norm that can harm our environment. And we decided to go deeper in this problem to know the nature and the size of this problem. We asked many domain experts and could not find any rational convincing to have expiry dates on payment cards. We found that there are technologies available today that can avoid this so-called need to expire cards. And do you know what? Your debit and credit card on expiry will add up to generate plastic waste, equivalent to 100 billion poly bags over next 5 years. This amount to 10 lakh tons of plastic waste, metallic chips and emission over 30 lakh tons of CO2 equivalent. Feeling the need to create awareness on this issue, we filed a petition through our parents on change.org platform. We asked for physical formats of payment cards made of plastic to be issued without an expiry date. Banks should take back the cards to circularize materials. Our change request was noticed by a national media publishing house, which amplifies it through a media feature. As the size of this problem was huge, but it was comforting to know that the majority of this problem can solve by only 3 global banking platforms, as they served 60% of banking cards in circulation globally. We wrote letter to leadership teams of these companies. We got a positive assurance from 2 of these companies. 4 months back, one of them made a public commitment to create all their content by 2023 recycled PVC cards. A good start, we can say. We also wrote a letter to Honorable Prime Minister Narendra Modi ji, where his office took note of our change request. We are currently in process to amplify these possibilities through RBI communication channels. As this is a small ripple by us in this ocean, we are hopeful that our continued efforts will yield the results that are greener and of greater goodness. We invite you to join this movement of #PayCardsGoGreen. We firmly believe that nature will be benefited if we grow the culture of questioning and challenging the status quo. It starts with a simple why and a why not. Why this waste and why not to innovate to avoid it. Thank you for your patient hearing.
Good greetings to one and all. Me and my brother, we got intrigued after reading about the Bhogi Shaili Parikrama in the newspapers. And out of curiosity, we ran to our Dadima and Nanima. They shared a few interesting traits about this parikrama, that it is also known as the Marwad Ka Mahakumbh. It occurs once in a 3 years' time. And we were actually astonished to know that this cultural practice was practiced since the time unknown. Like a large number of thousands of devotees taking a part in it, more than hundreds of kilometers covering, stretched for 7 days, having its mention in the Skanda Puran. And we were also astonished that this long parikrama had majority of the women participants. Not only this, but most of the participants belong to the indigenous communities of Marwad and Godwad region. They walk around the city of Jodhpur, covering the major temples and kunds on the hillock known as Bhogi Shell, with Bhogi meaning serpent and Shell meaning mountain in Sanskrit. With a curiosity being fueled up, we got challenged by a mom to jump into this parikrama and create a video documentary so that we know more about its significance and relevance, and not only that, but more and more people to know about this cultural tradition. During those 7 days, we experienced that how this cultural tradition was deeply intertwined with the natural ecosystems. Speaking to all the key stakeholders of this parikrama, from the monks to the saints, to the devotees, to the pilgrims, to the organizers, to the king, to the commoner, we were convinced that there was one common string which tied them all: the spirit of Vasudeva Kutumbakam. One world, one family. With a disclaimer that a project is still under progress, let me share the key findings that justifies my statement. Bhogi Shell, a mountain being revered during this parikrama, where to quote one of the pilgrims saying that we need this shell, meaning mountain, for us to do the Bhogi Shell parikrama. Mountains stop the clouds for us to let the rain pour down. And it also helps in the growth of crops and pastures for our Gaumata. After all, isn't our health interconnected? Unquote. Wasn't that a humble definition of One Health? I feel, and we've noticed, that natural system is kept alive because it is rewarded by the culture. Every place of this pilgrimage, be it Arna Jharna, Kadam Khandi, Vraspati Kund, Beri Ganga, Surya Kund, Jogi Tirth, either had a waterfall, pond, or natural spring where these devotees used to take holy dips in it. We spoke to geologists in search of the relevance of these holy dips with the human health, and we got to know that the reason was the presence of minerals, mainly sulfur. Quoting another devotees, we give these ponds punya, that means blessings, as much as we take from it. We take as much as benefits from it. Well, we are still wondering, what was she hinting on? Isn't a culture alive because of a living natural system? Finally, when they return after an arduous walk across the wilderness of untrodden paths, they are greeted by the erstwhile king and his family. When asked for the reasons, the devotees say, king and a queen are treated as the parents of a community of a region, and we, as his family, go and pay respect to them after a successful devotional trek. And they are here to receive the blessings we bring along with us. Could this be a reason and a way for the king to check on the health of his region by staying blessed with the knowledge being aggregated and cross-pollinated amongst the participating indigenous communities during the parikrama? I would like to conclude by quoting an elderly lady who was asked that why do you take a part in this parikrama at such an age? See, she said, like Ganeshji performed the parikrama of his parents, considering them as his universe, it is my opportunity to pay homage to and pray for everything, its people, its flora, and its fauna, which enlivens up my Nagar, my motherland. Thank you for your patient hearing.
Thank you, Janak and Purvansh. This was indeed lovely. Our second speaker is Devavrat, a BTech third-year student at IIT Jodhpur with the visionary idea of reducing cement use in building sustainable homes. He is committed to researching the benefits of soil-based brick home designs, which are cooler during summer, more efficient, sturdy, and cost-effective. He is a passionate ornithologist in making and has a keen interest in studying birds in their natural habitat. The idea of soil bricks came from one of his excellent observations of birdhouses and their compact structures. Let us listen to what he has to say.
Good evening, everyone. My name is Devavrat, and today I'll be showing you how I have a few ideas and how my mentors, Dr. Mithali Mukherjee and Dr. Mansi Mukherjee have guided me in these 2 years. So right now, I had taken up the project initially as a design credit, but later on I decided to pursue it out of my own interests because I found so many ways where we can be inspired by nature and try and implement it in our real life. So the project, let me tell you a bit of the project. The project was about the dusky crag martin, a bird, which builds its nest using mud pellets or soil pellets. So the project has multiple applications. The most important one being discovering a new source of mud for construction in arid regions like Rajasthan, where muddy soil is scarce. So our initial thought was that, okay, the bird goes and finds mud and then it makes into pellets and builds a nest. So the nest is an overhang where the bird just builds it on a cliff edge or any edge, and it has no support from bottom. So here are a few findings which we observed. The most important observation was that the nest soil had 10% more fine particles than the nearby soil, meaning there were specific kind of grains, soil particles selected by the bird to fill in the voids created when it made the pellets. So here you can see that the pellets are stuck layer by layer to build the nest. So now let's move to our regular life, where all of us love buildings which are strong and sturdy, and concrete is our main source of reaching the sky. Where concrete helps us build homes in the air, but we don't realize that we are actually destroying our ecosystem. We are wiping off topsoil. We are wiping off the ecosystem in the topsoil when we use concrete, especially when buildings are demolished. Most of this concrete is just thrown away in landfills and there's no degradation. And also, while getting the main component of concrete, cement, here is some data on how polluting it is. So it counts to 8% of the total CO2 emissions in our entire world, 90% of the greenhouse gas emissions, and 10% of coarse particulate matter that chokes Delhi. So along with this, you also have quarries for limestone and other materials for manufacturing cement. So now we know where we are with concrete. To be more precise, we know where it's going. It's going nowhere. It's not being degraded. The methods to break down and or use it is much more expensive than actually just building it. And since we care more about just building the cement monsters rather than actually making them sustain, I guess we should move over to sustainable methods where we can actually integrate mud or other bio-inspired nature solutions. So why integrate mud structures? Here are some ideas of mine. So one is sustainability. Okay, say you look at bunkers, say submarine bunkers. They build it out of cement, and in the World War II, when they were shot down, the submarines were trapped and that area was unusable. So now I say we can use mud to build the layers, like how the bird's nest was built, and we can also grow cover on it. And when it's broken down or when it's attacked, you can again build it again, or it can be washed off very easily. Then cultural preservation. I mean, cement monsters are in the recent days, but I'm pretty sure most of us would have seen a grandparents' home where it was built of mud and it was, cool and calm, even though the temperature was very hot outside. And it was warm when in winters where the temperature is very cold outside. So there's a natural remediation of heat. And then you have health benefits. So you do not have the air, what do you say, coarse particulate matter floating around when you do not have cement itself. And when you have soil, you get better quality of air, better quality of sound. So there's a dampening of sound when you have soil structures. And then you have climate resilience. Also, if you have ever noticed a wall which has been connected to a mud source, or say an underground wall connected to the earth, that's so much more colder. So you can also look at it as an alternative to cooling methods rather than using AC. A layer of mud, like how in Rajasthan they have those stones. Here you can use a layer of mud between the stones to cool down your apartment. Also, you can call it aesthetics, make it look good, but that's area yet to be explored. And by aesthetics, I meant buildings like these where you have vertical gardens. You can integrate your mud structures with that. Thank you.
Thank you, Devavrat. Next up is a group of college students from Mahila PG Mahavidyalaya who have worked on bioperspective from Vinogradsky column. Their approaches include microbial assessment, green synthesis, genome analysis, power generation, and looking into therapeutic potentials. I request the group to kindly share with us their experience.
Hello everyone, myself Pratiksha Kalla, and we are here. We are the 10 students from Mahila PG Mahavidyalaya Jodhpur. We did our master's dissertation from IIT Jodhpur, and we are really thankful to Professor Mithali Mukherjee ma'am and all the faculties of IIT Jodhpur and JCKIF who made our work possible. So basically our So basically, our work, we worked on a Vinogradsky column, which is a miniature ecosystem which mimics microorganism, natural habitat. We can call it as a home away from home. It is basically a column filled with the sediments and some nutrient supplements for the microorganisms like egg and newspaper, etc. This column was discovered by Sergei Vinogradsky to study the microbial physiological environment. We collected 10 samples from different locations in Jodhpur and we made a Vinogradsky column from it. This is our weekly observation from a chokha location, which is a type of a barren soil. We took some layers from the column and made a biofilm from we did many experiments from this column, and from that column we made some layers and form a biofilm. We did a green synthesis, we did genome analysis, power generation, therapeutic potentials, which make the soil health and soil microorganisms protected from the environment and for the different ecosystem. So we conclude that these techniques such as susceptible test, culture technique, biofilm assay, green synthesis of nanoparticles, genomic DNA analysis, and microbial fuel cells. We would like to express our thankful gratitude to all the faculties and Dr. Nishi Mathur ma'am, respected Dr. Mithali Mukherjee ma'am, and JCKIF for providing us a vision for research, and thank you everyone for your valuable contribution and given confidence to achieve success. Thank you.
A big thanks to this group. Our last speaker is Manik Sejwal, an MTech PhD student of Medical Technologies, a joint program by IIT Jodhpur, AIIMS Jodhpur. For today's session, Manik will talk about conversational AI for patient health and education. He chose this field because based on his personal experience and research, which suggests that we need to improve patient education and compliance using a scalable approach to avoid preventable deaths from heart attack. Let us hear what Manik has to say.
Good afternoon, everyone. Good afternoon, everyone. First of all, I'd like to thank IIT Jodhpur and JCKIF for giving me the opportunity of presenting my views about conversational AI for patient education and health. We know that heart attacks are the leading cause of death globally. And that's why the United Nations World Health Organization considers non-communicable diseases to be one of the top global health issues. We have chronic diseases like diabetes, chronic obstructive pulmonary disease, and hypertension, heart failure, etc., that pose a huge burden to the healthcare infrastructure. If we talk about the origin of the word doctor, it originates from the Latin word docere, which means to teach. It is the responsibility of each and every doctor to ensure proper education of their patients, their families, and the communities. Patient education is different from awareness. In patient education, the goal is to improve the knowledge, provide the attitudes to the patients, and also improve their skills so that they are capable of managing their life with the disease. We need them to optimize their life, their health and well-being. A doctor's job is not easy. When the patient's condition complicates, that is when no other tool can help. Even though the doctor only spends 2 minutes engaging during a patient consultation, when the situation complicates, medicine becomes an art. And when the art of medicine happens, all the decades of learning and experience come into play. They are essential to ensure that the patient survives and a best outcome is possible. Now, when we talk about AI in medicine, we talk about powerful models like the Google MedPalm, and we talk about other models like Chat Doctor. Chat Doctor and Google MedPalm have an around 85% accuracy on USMLE-like questions, which is the exam for like medicine, similar to NEET. That accuracy is not enough. That is because they take a text input and give a text output. That is never enough for medicine. Medicine is complex. Doctors start diagnosis when the patient opens the door. How he walks, how he talks, the tone of voice, the body language that is used. It is a holistic approach, not just question answers or stories. If AI has to help in medicine, it has to simplify what a doctor does, but not replace a doctor. It cannot compete with a doctor anytime soon. To ensure that AI is productive in medicine, we cannot replace diagnosis, but we can use AI to collect the story of the patient. We can use it to collect the signs and symptoms that the patient has to tell. We can use AI to automate follow-ups at home so that the patient can get information at home from the bed right away. Do not have to wait for 4 hours in the queue. A successful AI does not take away control from the doctor. We can have AI explain the prescription instead of assigning the correct drugs. That is too hard. There are too many factors involved. Doctors and patients both prioritize the trustworthiness of the tool that they are relying on. They don't care about the number of parameters that go inside a neural network. They need the right results. They need the right results when the situation worsens even more. It is crucial that we shift our focus from solely enhancing the neural networks towards improving the AI that goes into creating a tool for health. AIMS Jodhpur and IIT Jodhpur have come together and created programs for medical technologies in which engineers and doctors sit together, they study together, they work together. JCKIF has further provided us resources so that we can work on high-risk medical technologies projects and ensure that they reach the population. Let us unite for One Health. Thank you.
As we come to the end of this enlightening session, we are reminded of the profound truth that the health of our environment and the health of humanity are intricately woven together. The insights shared by our students today have illuminated the dynamic interplay between environmental factors and our well-being. In embracing One Health paradigm, we recognize that our planet's ecosystems are not merely the backdrop of our lives, but are vital determinants of our health and prosperity. From the air that we breathe to the water that we drink, and from the diversity of life around us to the intricate ecosystem that sustains us, every element of environment plays a role in shaping our health outcomes. In closing, I want to express our gratitude to our students for their valuable research and passionate presentations, and to all of you for joining us to explore the vital nexus between environment and human health within the One Health framework. Thank you for being a part of this important conversation of citizen science. May our commitment to a healthier planet and healthier lives inspire positive change in every corner of our world. I would like to invite Dr. G.S. Toteja to kindly felicitate the citizen science participants.
All the participants of the citizen science sessions, please come up on the stage.
I would also like to call Dr. Nishi Mathur on the stage.
Smile, smile.
I now invite Professor Mitali Mukherjee to recapitulate the essence of the day through her concluding remarks.
So I would like to thank all of you who have been there with us all through the day. and have got to hear all that. For me, it was really a treat on a Sunday because I learned so many things. And I think all of you might appreciate that a few keywords really came out of the whole thing. One is transdisciplinary, one is health, one is expertise you need to aggregate from everywhere. And everybody, you would see that they had a perspective to share. And I'm very sure amongst the speakers, you got to know, अरे ये जो काम कर रहे हैं इसमें हम भी plug in कर सकते हैं. Meaning, I think we can, if we sit together, we can start to thread our expertise and our knowledge and try to make ourselves not only relevant to each other, but relevant to a problem which we can all address together in a cohesive manner. So all of us have lots of expertise, lots of years of expertise, and you can imagine if you get all those years into one problem, you not only get the expertise, but you can also reduce those many number of years you would spend independently answering each question. So my urge is that this JCKIF foundation is really a great enabler because it allows us to connect in so many ways. Believe me, I've been here only for 2 years. I did not know anybody in Jodhpur, and I did not know anything about Thar design. I am not an ecologist. I am not from any of the area which we discussed today, but just because we got people together one by one or all organically, and nobody knew each other, and nobody the bioscience department also, lots of people were there, but it actually got threaded, and we now start to see that there is a merit in working together. And it's also across clusters. So the craft exhibition which you are seeing, our students, we are also working with the crafts people on the genomics and people of Thar. So like that, everything got connected. And that's why in, I think, 7 days or 10 days time, we could think about actually carrying this program through, where I was traveling also for 5 days, and none of us knew what we would do. And G20 we heard, and then we just got to brainstorm and got all the people through the JCKIF cluster. I'm not sure if there was not a cluster, we could have actually done it in this faster time, right? So we've written deliberations all through the day, and we will circulate that to all the people who have been here, so that you can add in your perspective or comment before we forward it. But the timelines will be very small, 1 or 2 days time. But earlier we were going to go through it through the concluding session, but our time has overrun. So I really would like to really thank all the people who have sat through the whole thing. But I'm sure many of us will go back very, very enriched, and would start to think about how we can be relevant to addressing this problem, right? Newer opportunities and many, many more things can come up. Now I'll invite Dr. Toteja to please formally give the vote of thanks and close the session. And
Okay, thank you. You all are must be tired, na? You want to go home. Okay. But before I give a formally vote of thanks, you see, I would like to submit 2 things which should be recorded, because the report will go to the Prime Minister Advisory Committee. So it's a very important session. One is that somebody did not talk about the antibiotic resistance due to the food chain through animals. Because animals, lot of antibiotics is given. Ultimately, it is coming to us. This is one area which actually I discussed for around 10 years when I was in Food Authority as expert on pesticide residues and antibiotics. But we ourselves could not do anything, but that is very, very vital area. The other thing I would, if you all feel, we should have recommendation here. Because when we talk about that integrated approach, everybody should come together. I didn't see any veterinary scientist here. We have medical people, basic scientists, but veterinary scientists we could not get. But I was involved in two integrated approaches. One in 1989. I joined ICM in 1984. Many of you must have not born. In 89, there was ICM or ICR panel. And under this panel, you see we had four groups: genetic disease, nutrition aspects of fat, mycotoxin, and pesticides. And this effort was successful for a few years, 4 or 5 years. Thereafter, it was discontinued. Then again in 2010, you have seen Dr. Katoj was secretary and DG ICMR. Again, we had ICMR, ICR panel. Again, number of studies were planned and executed also. So that way, you see, all these studies and initiative taken in collaboration ICR and other institutions also, it did not work for a very long time. So what I suggest that from here IIT, you see, we have a very dynamic leader, Professor Shantanu Chaudhary. So what I suggest that if you all agree, then it should be the recommendation that we should make this attempt for Rajasthan. Because if we say ICMR, ICR, pen, other things, the center, that is not under our prerogative. So in Rajasthan, we can like technology, we can IIT, we can have medical colleges, we can have veterinary colleges, etc. All together, we just make one task force, and that task force addresses the issues of Rajasthan. That's a humble beginning. And otherwise, also health is a state subject. So therefore, then we have a positive leadership everywhere. So with this suggestion, if you all agree, that should be recorded. So it should go to the Prime Minister's Scientific Advisory Committee, and there you see we can pursue it further, and we can have a task force under JCKIF banner. Now, a very small vote of thanks. You see, I would like to thank Professor Ganguly. You know, he's very busy, 80 years old, former Director General. I was fortunate to work under his leadership from say 1998 to 2007. I worked directly under his leadership. And a lot of studies have been done then. We had a pesticide residue in cold drinks. Nowhere limits have been fixed for cold drinks, but under the leadership of Dr. Ganguly, under Joint Parliament Committee under Sharad Pawarji, this was done. And then Dr. Katoj, very grateful to him also. Dr. Kapoor, Secretary to Government of India and former DG ICMR from 2008 to 2014. And I was fortunate to work under him 2008 to 2014. And he made me director of the ICMR Institute in Jodhpur in 2012. I have remained director till 2020. So he very dynamic person. He set up the network of 102 viral laboratories. At that time, number of people questioned. But during COVID, all these 102 laboratories work and saved us, saved our country. So he's a great man. So I'm very grateful to Dr. Katoj, Lieutenant General Chadda. You know, he came and he spoke very crisply, you know, from different perspective, but ultimately to address one other aspects of One Health. So very grateful to Lieutenant General Chadda also. And then all our experts, Dr. Abhi was there, Hitesh Sharma ji was there, then Chaudhary Saab was there. Chaudhary Saab, who is not here, he used to come to me for genetically modified food on brinjal, and we had a lot of toxicity data. So he was there. And then I have seen that people have come from ICMR, Dr. Suresh Yadav. Then people have come from Ayurveda University, that Dr. Kapoor is there. People have come from Chandan, is from Agriculture University, and then from AIMS. All those who have come from these institutes, I'm very grateful to them. And our former Vice Chancellor, Dr. Abhinay Kumar, he is a very nice person. He's so silent, you know. Sometimes you see, we just miss him. I know him for the last 1 decade, you see, a wonderful person, is former Vice Chancellor. And whenever you see, we invite him, he always come and honor us. Thank you very much, sir. Thank you very much. And then, sir is also there. Vyas is also sitting here. Thank you very much, Vyas sir. And then, of course, the faculty of IIT and our Jodhpur City Knowledge people, Mansi presented very nicely. She spoke very well. So all our people from IIT, faculty, students, administrative staff, financial staff, our PRO assistant registrar madam. Now she's shopping there, but she also worked very hard. She's sending all the messages, etc. So all others, you know, photographers and these girls, they're standing here the whole day. Very nice. No, I appreciate that part. So if I forget someone, please forgive me. Those people sitting there in the box also. So thank you very much to all of you, and let us meet again. And we'll give more time, like Dr. Mitali Mukherjee said, that because of short notice, we could not do what we wanted to do, but maybe next time. And of course, the leadership of our director IIT and our deputy directors have, and madam's leadership also, because it could be possible because of Professor Mitali's leadership and so many her colleagues. Thank you all.
I would like to invite Professor Mitali Mukherjee to kindly come and felicitate Dr. G.S. Roteja.
क्या फैसिलिटेट मुझे थोड़ी कर रहा है, बस अपना है, घर के लोग हैं। रखेगा यार, अगली बार दे दे दोबारा पैसे, JCKIF के पैसे बच जाए, अगली बार दोबारा दे देना मेरे को।
So I think we formally close the session, and all of you are welcome to have the last cup of tea, right? That's there for us, right? We are tired. Okay, thank you all, please.
Thank you.